everyone, welcome you all to the chemistry class. In this video, we are going to study the chapter acids, bases and salts. In this particular session, we are going to study the definitions of acids and bases, and we are also studying about the different types of acids and bases and about the indicators. Okay, let's get started. Yes, my dear students, in this chapter, we are going to study the general properties of acids and bases, and also we will be studying about the chemical properties of acids and bases, like how do they react with each other and how do they react with metals, metal carbonates and all. And we will come across the pH scale. It is a scale which is used to measure the strength of acids or bases. Then we are going to study the importance of pH in everyday life. Then we are going to study salts, that is a product that is formed by the neutralization reaction between acid and bases. Yes. Then we will also study the preparation of some important compounds from common salts. Okay. But in this particular session, we are going to study about the definition of acids and bases and the different types of acids and bases and indicators. Okay. Let's get started. Yes, my dear students, you have heard these words, yes, acids and bases in the class 7th. Would you remember by hearing the words acids and bases, what you recall on this concept? Yes, we know that we have learned that how do acids taste? Yes, acids are sour in taste. This is all studied in class 7th, right? Yes, let me recall this concept. Acids are sour in taste. Suppose if I taste lemon, orange juice, tamarind or unripe mango, how does it taste? It tastes like a sour. Why? Because it contains acid. So all the acids are sour in taste. Then what about the color change when they are dipped in the when litmus paper is dipped in the acidic solution? Acids turn blue litmus to red. Yes. Here, litmus is an indicator which is used to test the presence of acid or base. If you take the litmus paper, that is blue litmus paper, and dip it in the acidic solution, what happens? It will turn to red color. This indicates that a given solution is an acidic solution. Okay. Then acids are good conductors of electricity. These are some general properties that you have studied in class 7th, right? These are good conductors of electricity. Then acids produces hydrogen ions in aqueous solution. Yes, acids produces hydrogen ions in aqueous solution. When acids are dissolved in water, they furnish H plus ions, which give them the characteristic properties of acids. Okay. Then what you have learnt about bases in class 7th? They are bitter in taste. Bases are bitter in taste. Suppose if you taste the toothpaste, okay, how does it taste? It tastes very bitter, yes, because it contains base. They are bitter in taste and they turn red litmus to blue color. Yes, this is how we can test the base by using litmus. Okay. Then these are also good conductors of electricity. Then these produces means as bases produces OH minus ions, that is hydroxide ions in aqueous solution. Okay. The characteristic properties of bases are due to this OH minus ion, that is hydroxide ions. So what is the reason that they conduct electricity? It is because due to this reason. When they are dissolved in water, they form ions which is responsible for conduction of electricity. Okay. Then can you give example of acids? Yes. Citric acid, which is a naturally occurring acid. Citric acid, lactic acid, then hydrochloric acid, etc. These are example of acids. Then what about bases? Magnesium hydroxide, sodium hydroxide. These are examples of bases. Have you seen the soap that you use daily for bathing purposes? It contains base, because of which it is slippery to touch. Yes, bases are also, they are slippery to touch. Why? Because they contain bases. Soaps are slippery to touch. Why? Because they contain bases. Slippery to touch. These are some general properties of acids and bases that you have also seen in the class 7th. Okay. Then how do we define acids? So acids are the substances which furnish H plus ions in aqueous solution. Okay. These are substances which furnish or which produces H plus ions, that is hydrogen ions in aqueous solution. As they produce hydrogen ions, they must contain hydrogen in their molecule. Okay. For example, HCl is hydrochloric acid. It contains hydrogen. HCl, it is
Example,
a hydrochloric
HCl
acid.
is
It
hydrochloric
produces
acid.
H
It
plus
contains
ions in aqueous solution. Therefore, it
hydrogen.
is an acid.
HCl,
Then
example,
hydrochloric
HCl
acid.
is
It
hydrochloric
produces
acid.
H
It
plus ion
contains
acid in aqueous
as it
solution.
furnishes
Therefore, it
hydrogen.
is an ions in aqueous solution. HNO3, nitric acid. This is acetic acid. It also produces H plus ions in water. These are some examples of acids. Okay, this is hydrochloric acid, sulfuric acid, nitric acid, acetic acid. So when these are dissolved in water, when they form aqueous solution, they furnish H plus ions. Like when HCl gas is dissolved in water, it forms H plus ion, Cl minus ion. The characteristic property of acids is due to the formation of H plus ions. Okay. Then let us study the classification of acids. Acids are classified into different categories based on sources, concentration, strength, etc. Based on sources, they are classified into organic acids and inorganic acids. The acids which are produced from plants and animals, they are called as organic acids. Okay. The acids which are obtained from plants and animals, they are called as organic acids. There are many examples that you can see in your daily life also, like examples, citric acid. Where do you find citric acid? Yes, obviously it is found in citrus fruits. Citric acid, which is found in citrus fruits like oranges, lemon. Then lactic acid, it is found in curd. Then oxalic acid, it is found in tomatoes. Tartaric acid, it is found in tamarind and unripe mangoes. These are some organic acids from plant extract. Okay. Then what about animal extracts? That is, in ant sting, there is a presence of methanoic acid. Yes, methanoic acid or bee sting. Then in nettle leaves, there are hair-like structures which contains nettle leaves. They also contains methanoic acid. Yes, nettle leaves. It is found in nettle leaves. Yes, these are some examples of organic acids which are obtained from plants and animals. Okay. Then what about inorganic acids? These are acids which are obtained from minerals. Okay. These are acids obtained from minerals. Yes, can you give examples for inorganic acids? Yes, we have studied right now, that is hydrochloric acid, what we call HCl, nitric acid, that is HNO3, and sulfuric acid. These all are inorganic acids. Organic acids are weak acids. These are weak acids. As they do not completely ionize in aqueous solution to produce H plus ions. Suppose if there are 100 molecules of citric acid, then all of them will not give H plus ions. Only 5 to 10 molecules will give H plus ions in this way. Whereas inorganic acids are, these are strong acids, as they ionize completely in water to form H plus ions. Okay. These are strong acids. Next, based on the strength of an acid, they are divided into strong acid and weak acid. If the acid ionizes completely in water, that is in aqueous solution, it is called as strong acid. It is called strong acid. Just now we have studied hydrochloric acid, sulfuric acid, nitric acid. These are all strong acids as they completely ionize in water to form H plus ions. Okay. Examples: hydrochloric acid, sulfuric acid, nitric acid, etc. These are all strong acids. Okay. Then weak acids are those, means if the acid do not ionize completely in aqueous solution, it is called as weak acid. For example, acetic acid, CH3COOH, it is acetic acid. It will not completely ionize in water to form H plus ions. It will remain in the form of molecules also. If you take the solution of acetic acid in water, there are present there the molecules are also present because it is not completely ionized. It also remains in the form of molecules. Whereas if you take hydrochloric acid in water, it ionizes completely. So whatever the solution consists of ions only. Okay, it doesn't consist of any molecules there because it has completely ionized. Okay, and also formic acid, HCOOH, it is also a weak acid. It will not completely ionize. Okay, there are presence of molecules also. Formic acid molecules are also present in the solution as it doesn't ionize completely. Okay, it is formic acid. Then based on concentration of the acid, it is divided into concentrated acid and dilute acid. Okay, it is dependent on the amount of acid that is dissolved in the solution. Okay, if an acid has relatively high percentage of acid dissolved in it in the aqueous solution, then it is called as a concentrated acid. Okay, then it is called concentrated acid. If I take sulfuric acid solution and it consists of large amount of sulfuric acid, okay, then it is called as concentrated acid. It is a relative term. Okay. Then what about dilute acid? If an acid has relatively low percentage of acid dissolved in the aqueous solution. Acid dissolved in aqueous solution. Then it is called as a dilute acid. Dilute acid. Okay. If I take an acid, if I dissolve some 10 gram of acid in it, okay, if I want to dilute the acid, what I can do, I can add more amount of water to it so that the amount of acid, that is percentage of acid in it, gets reduced. Okay, these two are relative terms. If the acid consists of relatively high percentage of acid in the aqueous solution, then it is called as concentrated acid. And if it consists of low percentage of acid in the aqueous solution, then it is called as dilute acid. Okay. Then these are the classification of acid based on strength, concentration and sources. Now let us understand some of the uses of acids. Okay. As we have already studied that acids are present in many food that we eat, like in vegetables like lemon and in fruits like citrus fruits like oranges, there is a presence of acid, that is citric acid. And where we use the acids in general, let us see. Vinegar is a diluted acetic acid. It is used in the preservation of food. Okay, and also it enhances the taste of food. When you add vinegar to the food, you might have seen that fast food restaurants, usually vinegar is added in order to enhance the taste of the food. This is a one of the uses. Then hydrochloric acid, it is used in the industrial level for cleaning the deposits of boilers. Suppose in the boilers there is a deposition of any material, for as it is used for a longer duration of time, then in order to clean it we can wash it with the hydrochloric acid. Okay, and also it is used in the cleansing of sink also. Then nitric acid, it is used in the manufacture of fertilizers and in cleaning gold and silver ornaments. Then sulfuric acid is used in cells and car batteries. Then salicylic acid is a type of acid. It is used in the preparation of aspirin as it has anti-inflammatory properties. Okay, then carbonic acids which you usually see in the soft drinks. Okay, these are all some of the uses of acids. Now let us see the concept about bases. That is, how do we define bases? Bases are the compounds which produces hydroxide ions in aqueous solution. Okay. These are compounds which furnish hydroxide ions in aqueous solution. Hydroxide ions. The characteristic properties of base are due to the presence of these hydroxide ions. Yes, we know different examples like magnesium hydroxide, sodium hydroxide, NaOH. It is sodium hydroxide. When it is dissolved in water, what happens? It forms sodium cations and hydroxide anions. Then magnesium hydroxide, etc. These are some examples of bases. Okay, now let us see the classification of bases based on strength. We have already discussed about the classification of acids based on their strength. Yes, what do we mean by strong acid and weak acid? We have come to know. Now let us define strong base. The base which dissociate completely in water to form hydroxide ions is called as strong base. The base which dissociates completely in aqueous solution to furnish hydroxide ions to furnish hydroxide ions. They are called as strong base. Okay, is called strong base. For example, potassium hydroxide, sodium hydroxide, these are strong bases. Okay. Example, sodium hydroxide, potassium hydroxide, these are strong bases. Then how do we define weak base? The base which do not completely ionize in aqueous solution. Completely ionize to form hydroxide ions in aqueous solution. Okay, they are called as weak bases. Is called weak base. So the example for weak base is ammonium hydroxide. It is a weak base. It will not ionize completely in water to form hydroxide ions. Okay, this is about a strong base and weak base. Then let us study one more classification of base, which is based on concentration. We call concentrated base as a base which has relatively a high percentage of base present in aqueous solution. Okay, the base which has relatively high percentage of base present in aqueous solution is called concentrated base. Suppose the base consists of large amount of base than water, then we call it as concentrated base. If the amount of water is more present in base, means we have diluted it by adding more and more water, then that base is called as diluted base. If the base which has relatively low percentage of base dissolved in aqueous solution, there is a presence of more amount of water there, so we call it as dilute base, same as dilute acid that we have seen earlier. Okay, relatively low percentage of base in aqueous solution is called dilute base. Okay, this is about concentrated and dilute base. Okay, then one more thing you have to remember here is all the bases are not soluble in water. Okay. Only some bases are soluble in water. The bases which are soluble in water are called as alkalis. What are alkalis? The bases which are soluble in water are called alkalis. Okay. For example, sodium hydroxide, potassium hydroxide, these are alkalis. Okay, then one thing you have to note that all the alkalis are bases, but all the bases are not alkalis. Okay, all the alkalis are bases, but not all the bases are alkalis. Why? Because as I have earlierly said that all the bases are not soluble in water. Only those bases which are soluble in water like sodium hydroxide, potassium hydroxide, they are called as alkalis. So these are also bases. Yes, alkalis are also bases, but not all bases are soluble in water. So they are not always alkalis. Okay. Next. Next, we have seen in the beginning of the chapter that we have find out the identity of a substance, that is whether it is a base or an acid, by using the indicator. So what are indicators then? Indicators are the substances which indicate the presence of acid or base in a solution. Okay. We cannot always taste all the substances. Yes, we know that acids are sour in taste and bases are bitter in taste. But is it possible to taste all the chemicals? No. As acids and bases are corrosive in nature, we cannot taste the substances. So we should have some scale. We should have some indicator which will show the presence of acid or base. So these are the substances which show the presence of acids or bases. We have two types of indicators, that is natural indicators and synthetic indicators. Let us see the examples for natural indicators. As we have seen in the beginning of the chapter that litmus, it is a natural indicator. How it is obtained? It is obtained from the lichen plant. It is extracted from lichen plant belonging to the Thallophyta family. Okay, it is a purple color dye, actually purple color. Okay, it is available in the form of solution nowadays, and also it is available in the form of strips. We prepare two different types of solutions from two different varieties of lichen, that is red litmus and blue litmus. Okay, they are available in the form of solution also, and we can also prepare strips from the litmus. Okay, what happens when we check the acidity of a substance with red litmus? Suppose if you check the acidity or basicity of a substance with red litmus, the acid will show no color change. Okay, means the litmus will show no color change in acidic medium. Okay, no color change. Suppose when red litmus is added to base, it will change to blue color. It will change to blue color. What about blue litmus then? When blue litmus paper is dipped in acidic solution, it will change to red color, red color. And when it is added to base solution, it will show no color change. This is how we will test the identity of a substance, whether it is a base or an acid, by using litmus. We have two litmus, that is red litmus and blue litmus, which is prepared from two different varieties of lichen. Then we have few more natural indicators like turmeric. We all know that it is in bright yellow color. It is a natural indicator. How does it shows the color change? In acidic medium, it shows no color change in acidic medium. Okay. Whereas when it is added to basic media, it will show the color change to red. It changes to red color in basic medium or in basic solution. Okay. This is how turmeric can be used to indicate the presence of acid or base. You have to remember the color change. It will change to red color in basic solution. It will show no color change in acidic medium. Then we have different few more different natural indicators like examples, colored petals of hydrangea plant. Okay, flowers, hydrangea, then petunia and geranium. These are few more natural indicators. Colored petals of hydrangea, petunia and geranium. This is all about natural indicators. Okay. These are few more natural indicators. As it is mentioned in your NCERT textbook, you should remember these. Okay. Natural indicators. Then what about synthetic indicators? As the name itself indicates, they are prepared in the laboratories. Okay. Mainly there are two indicators which are oftenly used. That is Phenolphthalein, it is colorless in color. It is colorless. It is colorless. An alcoholic solution of phenolphthalein is used as an indicator. Okay. It is basically colorless and it shows pink color in basic medium. It shows color change, that is pink color in basic medium. This is about phenolphthalein. Okay. And it is colorless in acidic medium. Suppose you add phenolphthalein to acidic medium, it shows no color change and it turns to pink color in basic medium. Okay. This is one synthetic indicator. Then there is one more synthetic indicator which is often used, that is methyl orange. As name itself suggests, it is orange in color. Okay. Phenolphthalein is colorless. Methyl orange, which is basically orange in color, it turns to red orange in acidic medium, in acidic solution. Whereas when it is added to basic solution, it turns to pale yellow. It turns to pale yellow in basic solution. So this is how the indicators indicate the presence of acids and bases by change in their color. So how do you define indicators then? Indicators are the substances which indicate the presence of acids or base by change in color. This indicates the presence of acids or bases by showing change in color. By showing change in color. Okay. Next. Now, there are special types of indicators called as olfactory indicators. Earlier, we have studied that indicators show color change in when they come in contact with acidic or basic media. But these indicators are special so that they show the presence of acids or bases not by change in color but by change in their smell. Okay. The indicators which shows the presence of acids or bases by showing change in their smell. Okay, these olfactory indicators have their characteristic smell, but when they come in contact with either acids or bases, they change their smell. This is how we can identify a given substance is an acid or base by olfactory indicators. What we need to do? We need to observe the change in odor or change in smell. Can we give examples for that? Yes. Examples: clove oil, vanilla extract, onions. These are some examples for olfactory indicators. Okay. How do they show the change in their smell? Suppose when you keep the vanilla extract in acid medium, it retains its smell. Okay. It retains pleasant smell. Vanilla extract is having the pleasant smell. It retains its smell in acid medium. But when it is kept in basic medium, it will lose its smell or lose its odor. This is how they will show the presence of acids or bases. Okay. A very interesting activity is given in your NCERT textbook about the preparation of onion peel indicator as an olfactory indicator. How can you prepare it? Even you can do it in your home also. Okay. You have to take small pieces of onion in a plastic bag and keep small pieces of clean cloth, small cloth along with onion pieces, onion pieces. Okay. And keep this plastic bag in fridge and keep it overnight. Okay. Keep the bag in the fridge overnight. Then what you need to do next is you have to take out those cloth pieces. Okay, those cloth pieces have gained the smell of onions. Okay, as it has its own characteristic smell, those pieces of cloth has the smell of onion. Then how do we use this as olfactory indicator is, we have to check it for acid and base. Okay, if you check for acid, if you dip the piece of small cloth in acidic solution, the smell of the cloth retained its characteristic smell. Okay, it retains smell. If you dip the cloth that is kept overnight with along with onion peels and you dip it in the acidic solution, then it will show no odor change, means it retains smell. Okay, suppose if you dip the same another one cloth that is kept along with onion pieces in basic medium or in basic solution, what happens? You can easily feel that it loses smell. Okay, whatever the characteristic smell of onion was there before, of dipping it into the basic solution, it has lost its smell. This shows that the given solution is of a base. If it retains the smell, then it is acid. If it loses the smell, then it is basic solution. This is how we will see the order change, means we will feel the order change by using olfactory indicators. These are special type of indicators in order to check whether a given solution is of acid or base by change in order. Okay, this is how we will observe the changes. Let us discuss one interesting question here, which is a in-text question. You have been provided with three test tubes. One of them contains distilled water and the other two contains an acidic solution and basic solution respectively. If you are given only red litmus paper, how will you identify the contents of each test tube? Okay. So now I have only the red litmus paper. What I need to do is dip the red litmus separately in all the solutions. Okay. In all test tubes separately, means you have to take different strips of red litmus only for testing in all test tubes. We know that in basic media, the color change that is observed is, that is the color change is red to blue. Let me write it separately so that you can understand it easily. The red litmus is dipped in basic media, it turns to blue color in basic media. Suppose you dip the red litmus in acidic media, it shows no color change. Okay. Then what is the color of litmus in neutral solution? It is purple color. Okay. By this technique we can understand which of the given solution is acid, base or neutral. Okay. The test tube in which color of red litmus turns to blue indicates that solution is base, because red litmus turns to blue in basic solution. So we have find out one of the test tube has contained base. Then the test tube in which color of red litmus turns to purple indicates that the test tube contains water, because water is neutral in nature. Okay, the distilled water is neutral in nature, that is neutral. Then we have one more test tube that contains acid. How does the color change occurs there? The test tube in which color of red litmus remains same, then the solution is acidic. This is how we will understand the color change and identify the substance which is acid or base. Let me repeat it again. We have given only the red litmus paper and we are given 3 test tubes containing acid, base and neutral. What we have to do is we have to dip the red litmus paper separately in 3 test tubes. If it is neutral, the color of red litmus will change to purple as the color of litmus is purple in neutral solutions. Suppose if it is a basic solution, then it will change to blue color. If it is an acidic solution, then it will show no color change. Okay, this is how we will identify the substances or solutions whether they are acids or bases by using litmus paper. Okay. Okay, in this today's session we have discussed what are acids, bases and classification of acids and bases, and we have also studied about the indicators, types of indicators. Okay, this is all about the first session. Next, let us consider the chemical properties of acids and bases in the next session. Okay. Hello everyone, welcome you all to the chemistry class. In the last class, we were studying about the acids and bases. We have covered the definitions of acids, bases and we have also studied about the indicators. In this session, we are going to study the chemical properties of acids and bases. Okay, let's get started. Okay, first let us study the reaction of acids, that is the first reaction will be with metals. Okay, how do acids react with metals? When metals reacts with acids or acids reacts with metals, what happens? There is a formation of salt and hydrogen gas. There is a formation of salt and hydrogen gas. Okay, let us see this reaction with the help of an activity here. Okay, see this picture. You can see the test tube here. Take a test tube. In it, add 5 ml of dilute sulfuric acid to it. So we are going to study the reaction of acid with metals, right? So we have taken the acid, that is dilute sulfuric acid, in this test tube. Then add zinc granules to it. Zinc is a metal. Okay. What happens? The reaction proceeds. Zinc reacts with dilute sulfuric acid. What happens? There is a liberation of gas here. That gas is collected in this tub, small tub. Okay. Then you can see here the bubbles are formed, which indicates that there is a formation of effervescence of gas. Okay. This is due to the formation of hydrogen gas here. Okay, we will also test how this gas is produced. First, let us write the reaction, write the equation for the reaction. What has happened here? Here, zinc metal has reacted with dilute sulfuric acid, dilute H2SO4 to form salt. Okay, which salt is formed here? It depends on the metal and the acid that you have taken. We have taken the sulfuric acid. So, zinc sulfate is formed. Okay, zinc sulfate is formed in this reaction. Then there is a liberation of hydrogen gas here. Okay, what has happened in this reaction? Here, zinc has displaced hydrogen from this acid to form zinc sulfate salt, and there is liberation of hydrogen gas here. Okay, this is zinc sulfuric acid. There is a formation of salt, that is zinc sulfate, and this is hydrogen. Okay, what has happened here? Zinc granules reacted with sulfuric acid to form salt and hydrogen gas. Then, when this gas is produced, it is colorless. Okay, how do we find that gas is of hydrogen? What we need to do is we have to bring the burning candle near this gas. Okay, once the gas is evolving during the reaction, we have to bring it near the gas. What happens if it is a hydrogen? Then the gas will burn with the pop sound. So this is called as pop test for hydrogen. See here, you can see here, this is a candle. Okay, this is a candle and this is a gas that is evolved. Once it catches fire, that is, it will burn with a pop sound. This is called as pop test for hydrogen, in order to identify which gas is evolved, whether it is hydrogen or not. Okay, then let us see a few more examples here. Magnesium reacts with dilute HCl, dilute hydrochloric acid to form salt, that is magnesium chloride. As I have already said that the type of salt that is formed depends on the acid and metal you have taken. Okay. Here magnesium has displaced hydrogen to form the salt magnesium chloride, and there is a formation of hydrogen gas here. Okay. This is magnesium. It has reacted with hydrochloric acid to form magnesium chloride, and there is a formation of hydrogen. So in general we can say that when acids reacts with metals, what happens, there is a formation of salt and hydrogen gas here. So I can generalize this equation as metals or acids reacts with metals to form salt and hydrogen gas. Okay. If you remember this general equation, then you can easily solve the reactions. You can easily write the reactions of metals with acids. Okay. This is a general equation. Then here the question arises that do all the metals will displace hydrogen? Yes, we have studied the displacement reaction in the first chapter. What has happened here? Here the displacement reaction has taken place where metals have displaced hydrogen from acid to form salts. It is a example for displacement reaction. Now question arises here, do all the metals displaces hydrogen from the acids? No. Only those metals which are reactive, which are more reactive than hydrogen will displace hydrogen. Means will react with acid to form salt and hydrogen gas. But the metals which have low reactivity than hydrogen will not react with acids. Okay. We have also studied this activity series in the chapter 1. As you go down, the reactivity will decrease. Okay. The metals which are placed above in this series above the hydrogen are reactive than hydrogen. These will react with acids to form salt and hydrogen gas. But what about the metals that are below hydrogen? For example, if I take Ag plus H2SO4, whether the reaction occurs? No, the reaction will not take place because it is less reactive than hydrogen. Okay, you have to remember this activity series because it is applicable for displacement reaction that you have studied in chapter 1. It is applicable here also when you study the reaction of metals with acids. Okay, it is also applicable for metallurgical process. So you have to remember this activity series without miss. Okay. So overall you have studied that when metals reacts with acids, they form salt and hydrogen gas. Then how do you test the presence of hydrogen gas there? By bringing a burning candle near the gas. If it burns with a pop sound, then the liberated gas is of hydrogen. Okay. Now let us move to the next part, that is how do bases react with metals. Here one interesting thing is not all the metals react with bases. Only few metals like zinc and aluminium will react with bases. Let us see how do they react. Zinc reacts with base, that is strong base, that is sodium hydroxide, to form sodium zincate salt plus hydrogen. Okay, only few metals that is like zinc and aluminium will react with the strong base like sodium hydroxide to form salt. It is sodium zincate. Sodium zincate is slightly soluble in water. Okay, so not all the metals will react with base to form salts like this. We have to remember that not all the metals react with bases to form salts. So you have to remember this particular reaction as this reaction takes place. That is zinc reacts with strong base, that is sodium hydroxide, to form sodium zincate, and you have to remember this name also, sodium zincate. It is a salt. Then let us solve some of the questions here. Complete the following reactions. Iron plus sulfuric acid. This comes under the reaction of metals with acids. Okay. Metals reacts with acid to form salt and hydrogen gas. We have studied now only. So the salt formed is iron. So there is a formation of iron sulfate and liberation of hydrogen gas. This is iron sulfate. Then reaction of copper with hydrochloric acid. Here also copper being more reactive than hydrogen, it forms copper chloride. Okay, this is copper chloride. When equations like this or reaction like this are given in your examination, you should Remember the activity series. If these metals are more reactive than hydrogen, then you can easily write the equation as like this. And if it is very less reactive than hydrogen, then the reaction will not take place. Okay. Then let us read the next question. What happens when dilute hydrochloric acid reacts with magnesium ribbon? This is also a reaction of metal with acid. Okay, we know that when metals are made to react with acid, they form salt and hydrogen gas. Okay, magnesium metal reacts with dilute hydrochloric acid to form the salt, that is magnesium chloride. As I have already said that the type of salt means which salt is formed depends on the acid and metal we have used. Okay, here there is a formation of magnesium chloride, liberation of hydrogen gas. So this is the reaction that takes place. Okay, so we have seen that when metals reacts with acid, they form salt and hydrogen gas. One more thing you might have observed in your home, that pickles are not stored in metal containers. Okay, have you observed in your home? Always the pickles are stored in plastic or glass jars. Okay, why? Because pickles contain acid. Okay, if lemon pickles are made, or tamarind is added to it, or mango pickles are made, then all of these contain acids. Okay, so when these pickles are kept in the metal containers, what happens? There is a formation of reaction, that is salt and hydrogen gas are formed, which is toxic in nature. Okay, because of which it can harm our body. So we will not usually use the metal containers for storing pickles. It may be asked in your examination that why the pickles are not stored in metal containers. You have to write that the reaction of acids takes place with metal. So the toxic substances are formed there, which can harm our health. So the pickles are always stored in either glass jars or plastic containers. Okay. Now we are going to study the reaction of acids with metal carbonates and metal hydrogen carbonates. What are metal carbonates? Carbonates of metals like sodium carbonate, calcium carbonate, magnesium carbonate. These are carbonates of metals. Carbonate of sodium metal, carbonate of calcium metal, carbonate of magnesium metal. These are called carbonates of metals. Okay. Now we are going to see the reaction of metal carbonates and metal hydrogen carbonates with acids. What about metal hydrogen carbonate then? They are also called as metal bicarbonates. Okay. NaHCO3. Example, this is example for metal hydrogen carbonate, which is also called as sodium bicarbonate. It is called as sodium bicarbonate. Means metal hydrogen carbonates are also called as metal bicarbonates. Okay. Now we are going to see the reaction. Let us understand this with the help of activity here. You can see the test tube here. In this test tube, we have taken the dilute hydrochloric acid, which is acid. Okay, then we are going to add metal carbonate and metal hydrogen carbonate into separate test tubes. Then we are going to observe the reaction. Okay, once this reaction takes place, there is a formation of gas here. Again, this gas is collected in test tube for testing which gas is liberated. We will come to it little later. Okay. Right now, let us understand this with the help of example. Okay, let us take the example of sodium carbonate, which is given in your NCERT text also. This is metal carbonate, reacts with acid, HCl, hydrochloric acid. What it forms is, it forms salt, carbon dioxide and water. By sodium and chloride ions, there is a formation of salt, and also there is a formation of carbon dioxide and water. Okay, this is the reaction that takes place when metal carbonate reacts with acid. There is a formation of salt from sodium and chloride ions, and there is a double displacement reaction takes place actually, and there is a formation of H2CO3 here. To balance this equation, actually there is a formation of H2CO3, and it eventually breaks down to form H2O and CO. Okay, this is what happens here. This is metal carbonate, this is acid, there is a formation of salt and carbon dioxide and water. So in general we can say that when metal carbonates react with acids, they form salt, carbon dioxide and water. Okay. What about metal hydrogen carbonate? Let us take another example. NaHCO3. It is sodium bicarbonate, that is sodium hydrogen carbonate. This reacts with acid to form again salt, carbon dioxide plus water. You can see in both the reaction the products formed are same. Only difference is the amount of hydrochloric acid that is being consumed. In this reaction, only two molecules of hydrochloric acids are consumed, whereas here only one molecule of hydrochloric acid is consumed. Okay, it is metal hydrogen carbonate. This is acid. Here again there is a formation of salt, carbon dioxide and water. So you have to remember in both the cases there is a formation of salt, carbon dioxide and water. Okay. Then as I have already said that once the reaction takes place, there is a liberation of gas. Okay, we have seen here there is a formation of carbon dioxide gas. But by seeing the gas, it is colorless. We cannot understand which gas it is. So we have to test it. How can we test the presence of this gas? Yes, we have a test to test the presence of carbon dioxide in a reaction. We test carbon dioxide gas by passing the gas through lime water. Okay. Let me write the reaction what happens there. When carbon dioxide gas is passed through the lime water, that is calcium hydroxide, it turns lime water milky. Because it is not soluble in water, there is a formation of calcium carbonate there. Okay. Test for carbon dioxide. When CO2 gas is passed through lime water, it turns lime water milky. Okay, what the reaction that takes place? This is lime water, calcium hydroxide. When carbon dioxide gas is passed through it, there is a formation of calcium carbonate there. It is not soluble in water, because of which it turns the lime water milky. It is white precipitate. This is calcium carbonate. Because of the formation of this calcium carbonate only, it turns the lime water milky. Okay. This is the test for carbon dioxide gas. Here you can see that the lime water is taken in this test tube, and whatever the gas that is being liberated is collected in this test tube. So that carbon dioxide gas reacts with calcium hydroxide, that is lime water, to form calcium carbonate. Okay. So by seeing the white precipitate, we can understand that the liberated gas is carbon dioxide gas. One more thing that happens here is when large amount of means excess of carbon dioxide gas is passed through the lime water, what happens? It will react with calcium carbonate to form calcium hydrogen carbonate. Okay. When excess of carbon dioxide gas is passed through it, there is a formation of calcium hydrogen carbonate, which is completely soluble in water. Okay. This is completely soluble in water. Again, the lime water which has turned milky becomes colorless, because all the calcium carbonate that has formed again reacts with carbon dioxide to form calcium hydrogen carbonate. This is soluble in water. Okay. Aqueous means it is soluble in water. This is calcium hydrogen carbonate. So the question may be asked in your examination that what happens when excess of carbon dioxide gas is passed through the lime water. You have to remember both these equations. Okay. When first carbon dioxide gas is passed through the lime water, there is a formation of calcium carbonate here. Again, when excess of carbon dioxide gas is passed, there is a formation of calcium hydrogen carbonate, which is soluble in water. So again the solution becomes colorless. Okay. Means it becomes clear. Calcium carbonate is also called as limestone. Okay. It is also called as limestone, and it is available in form of chalk and marbles. All of them contains calcium carbonate. So it may be asked in your examination by taking these names also. When chalk is made to react with excess carbon dioxide, what happens? Then you need to remember this. These all contains calcium carbonate. Okay. So overall what we have learned here is reaction of metal carbonates and metal hydrogen carbonates with acids. So I can generalize the equation as metal carbonates or metal hydrogen carbonates reacts with acid to form salt, water, and carbon dioxide. Yes, this is a general equation. If you remember this, general equation, then you will be easily able to write the reaction, the equation. Okay, let us solve one example here. It is an in-text question. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. We have to find out what metal compound A is. Okay, we don't know the compound A. It reacts with dilute hydrochloric acid, okay, to form the effervescence, and they have given a hint that this gas evolved extinguishes a burning candle. Usually we know that carbon dioxide gas is a fire extinguisher. Okay, so one of the products that is formed is carbon dioxide gas, we came to know. Then write a balanced chemical equation for the reaction if one of the compounds formed is calcium chloride. And they have also mentioned that one of the compounds formed here is calcium chloride. So we need to complete the reaction and balance it. Okay. Here you can observe that there is a formation of carbon dioxide gas and there is a formation of salt and there is acid here. So which type of metal compounds react with acid to form carbon dioxide gas and salt? Yes, of course. You are right that metal carbonates react with acid to form carbon dioxide, salts and water. Okay. So there must be water here. Which metal carbonate must be A? Okay. We have got salt from calcium. Okay. Then the metal carbonate should be calcium carbonate. Okay. This is a metal carbonate. When it is made to react with aqueous solution, that is hydrochloric acid, it forms the salt calcium chloride plus carbon dioxide plus water. Yes, this is the equation. You can write the name of the reactants and products. It is calcium carbonate. So the metal compound A is calcium carbonate. The metal compound A is calcium carbonate. Okay. Now we are going to study the reaction of acids and bases with each other. When acids and bases react with each other, they form salt and water. Okay. When acids and bases react with each other, they form salt and water. There is a particular name for this reaction. This reaction is called as neutralization reaction. Okay. This reaction is called as, let us take an example. HCl is an acid. When it reacts with base sodium hydroxide, there is a formation of salt, that is sodium chloride and water. So when acid and base react with each other, acid plus base, they form salt and water. What happens here is there is an exchange of ions takes place that you have studied, that is double displacement reaction takes place. Sodium and chlorine, their ions form sodium chloride, and H plus and OH minus ions form H2O. Whatever the H plus ions, they are coming from acid, and OH minus ion of water, they are coming from base. Okay, this is acid base, they have formed salt and water. This particular reaction where acids and bases react with each other to form salt and water is called as neutralization reaction, because here both of them nullify the effect of each other. When acid and base react together, acid nullifies the effect of base and base nullify the effect of acid. As they nullify each other's effect, they neutralize each other to form a neutral substance, that is salt. We cannot always say that this salt is a neutral substance. It may be acidic salt, it may be basic salt. We will come across this concept little bit later. Okay, let us understand this reaction with the help of an example. Okay, this is a test tube containing sodium hydroxide. Okay, this has sodium hydroxide in it. What we have to do? We have to make the reaction of acid and bases. Okay, now I am going to add here HCl to it. Before adding hydrochloric acid to it, check the color of sodium hydroxide with phenolphthalein indicator. How does it look? It looks pink in color. When you dip the phenolphthalein indicator strip, or if you add the phenolphthalein indicator solution to sodium hydroxide, it turns pink color of phenolphthalein because it is a base. Okay, now what happens? Go on adding the hydrochloric acid to it. What happens is there is a disappearance of pink color as you go on adding hydrochloric acid to it. There is a the color, the pink color start disappearing, okay, in this solution, and there comes a point when it becomes colorless. We know that phenolphthalein indicator, it indicates the pink color in basic solution, okay, and there is no color in neutral solution, okay. So again when it turns colorless, go on adding HCl to it, okay, then it will show colorless because there is no base here, as all the base is consumed in neutralization reaction. Here HCl has nullified the effect of sodium hydroxide and sodium hydroxide has nullified the effect of HCl. So it shows colorless. Then what to do is again add some sodium hydroxide to it, again check the color, then again it will show the reappearance of a pink color. Then we have added base to it. So this shows that acid and base nullify the effect of each other. Okay, have you understood how do they neutralize each other's effect? Okay, this is all about neutralization reaction. Okay, you can take few more examples of it. Examples of neutralization reaction: when hydrochloric acid reacts with potassium hydroxide base, it forms salt, potassium chloride and water. And when NaOH, that is base, when it reacts with sulfuric acid, it forms salt, sodium sulfate plus water. Okay, these are some examples for neutralization reaction where there is a formation of salt and water. The type of salt, it depends on the type of acid and base you have used. Okay, these are also example for double displacement reactions. Next, let us study the reaction of acids with metal oxides. Let us take an example of copper oxide with hydrochloric acid. Copper oxide is a oxide of metal, that is copper. Okay, let us take the example. When copper oxide is dissolved in dilute hydrochloric acid, it forms copper chloride, CuCl2, and there is a formation of water. Initially it was black in color. Copper oxide is black in color. When you add to the solution of, that is hydrochloric acid, what happens? There is a formation of blue green copper chloride, because here it has undergone the reaction with hydrochloric acid to form salt and water. It is salt and this is water. Metal oxide, it is metal oxide, oxide of copper, and this is acid. Here there is a formation of salt and water. Little before we have seen that when acids and bases react with each other, there is a formation of salt and water. Here we have acid, here there is a formation of salt and water. Then what does this indicate? It must be basic in nature. So we can say that metal oxides are basic in nature. So let us write the general equation for this. When metal oxides react with acids, they form salt and water. As this is a neutralization reaction, we can say that metal oxides are basic in nature. Metal oxides are basic in nature. So what we have done here, we have taken hydrochloric acid and we have added copper oxide to it. There is a formation of salt, copper chloride and water. As there is a formation of salt and water, this is a neutralization reaction between acid and base. So here copper oxide acts as base. Okay, then let us see the reaction of base with non-metal oxide. Okay, then what might happen there? Let us see. Let us take an example. Carbon dioxide is a non-metal oxide. Carbon is a non-metal and oxide of carbon is carbon dioxide, that is non-metal oxide. And let us make it to react with base. That is, let us take the example. Calcium hydroxide is a base. Let us make the reaction of base with non-metal oxide, that is carbon dioxide. What it forms? It forms salt, calcium carbonate plus water. This is a base and this is a non-metallic oxide. There is a formation of salt and water here. Can you remember this equation? Yes, we have seen it little before. That is for testing the carbon dioxide gas. There we have seen. It is a non-metal oxide and we are going to make this react with calcium hydroxide, that is base. Here there is a formation of salt and water again. Again, what does this indicates? It is a neutralization reaction where base might have reacted with acid, which indicates that non-metallic oxides are acidic in nature, because here acid and base react to form salt and water. We have base here, we have salt and water. Then this non-metallic oxide must be acidic in nature. So what we came to know is non-metallic oxides are basic in nature, sorry, acidic in nature, are acidic in nature. You have to remember these 2 points, okay? Metallic oxides are basic in nature, non-metallic oxides are acidic in nature. This is all about the reaction of acid with metal oxide and base with non-metal oxide. We have seen the properties of acids and bases and how do they react with other substances. Okay, all the acids behave in a similar manner. Okay, they react in a same way, and also bases also react in a same way. Then all the acids must have some common property and bases must also have some property in common. Okay, let us check what is the common property that all the acids are having and what is that common property that all the bases are having. Let us understand this concept by an activity here. Okay, let us perform an activity. What you have to do is, let us see an activity. Take the solutions of glucose, alcohol, dilute hydrochloric acid or dilute sulfuric acid in separate beakers. Then fix two iron nails. You can see in the picture, these are two iron nails. Fix these iron nails on the rubber cork and place it in the beaker. Okay, then connect these terminals to the battery. Okay, then fix the two nails or connect iron nails to the terminals of the battery with bulb and switch. Okay, now you have to take the solutions that are mentioned here, that is glucose, alcohol, dilute HCl and dilute H2SO4 separately. Now switch on the current. First take dilute hydrochloric acid in the beaker and switch on the current. You have to make the observations. What are the changes that you are going to see here? Okay, then repeat the same experiment, that is connect the terminals of the connect the ends of these nails to the terminals of the battery with switch and bulb. Again switch on the current by using the different solution, that is glucose, alcohol, sulfuric acid, one by one. Okay, then make the observation, then repeat same experiment taking different solutions, then make the observations. Okay, make the observation. What happens here when electric current is passed through the battery, that is this circuit is complete now. When you switch on the current, electric current starts flowing. Okay, in the case of hydrochloric acid, sulfuric acid, the bulb was glowing. Okay, the bulb was glowing in the case of hydrochloric acid and sulfuric acid, but it was not glowing in case of glucose and alcohol. What does this indicate? What we have observed here is observation, bulb glows in case of HCl and H2SO4, but the bulb was not glowing in case of glucose and alcohol. Why? Because in order to blow the bulb, what is the necessary condition? That the electric current must flow through the circuit. Okay, for flowing of electric current there must be movement of ions. Okay, when and only when there are ions in this solution, this will conduct the electricity, means the solution will conduct the electricity only in the case that there is a presence of ions there. If the ions are not present here, then the electric current is not supplied to this solution, means the circuit is not complete now. The bulb will not glow at all. In the case of HCl and H2SO4, there is a ionization that has taken place. How? When HCl and H2SO4 are dissolved in water, they form ions like H plus Cl minus. Okay, they have formed the ions. The same has happened in the case of sulfuric acid. Okay, these ions are responsible for flow of electric current, because of which the bulb has glow there. Whereas in case of glucose and alcohol, there is no formation of ions there. Okay, this shows that the acids contain H plus ions, means they produce H plus ions in aqueous solution, which is responsible for their acidic property. Okay, these H plus ions are responsible for acidic property. This we have concluded from the experiment. What about glucose and alcohol? Even glucose contains hydrogens. Okay, it also contains hydrogens, but it will not produce H plus ions. Okay, it will not produce H plus ions. So it has not conducted the electricity, because of which glucose is not an acid, because it will not produce H plus ions. In order to be acid, it must produce H plus ions in aqueous solution. Whatever the characteristic properties of the acid, it is due to the presence of the H plus ions. Okay, you can repeat the same experiment. You can repeat the same experiment by using basis also, basic solution. When you take here the basic solution in this beaker, then also we see that there is a glow of bulb, means the electric current is flowing through the circuit there. Okay, why does the electric current flow in the circuit? Because they have produced ions. When you take bases like sodium hydroxide, they have produced ions, that is sodium ion and hydroxide ion. These ions are responsible for conducting the electricity. For flow of electric current, we know that there must be movement of charges, or there must be movement of ions or electrons. Here, in case of basis also, there is a formation of ions. Okay, you can take KOH, that is potassium hydroxide, it forms ions. So these bases which produced hydroxide ions, these hydroxide ions are responsible for their basic properties. These are responsible for basic nature. So now we have understood that what all the acids have in common. All the acids produce H plus ions in solution, because of which they show the similar properties, that is they show similar reactions with other metals or metal carbonates in this way. And also all the bases, means that are soluble in water. Here we have to take the name alkalis, because we are carrying this experiment in water. Okay, solution of these bases in water. Only those bases which are soluble in water, they produce hydroxide ions. Okay, these alkalis which produce OH minus ions are responsible for basic nature, so they behave in the similar way. So now we have understood what all the acids and bases have in common. Acids produces H plus ions in aqueous solution, and bases produce OH minus ions, which are responsible for their properties. Okay, and also one more thing we have realized, that all the substances that has hydrogen ions are not acids. Okay, we have seen right now that glucose, even though it contains hydrogen, it is not considered as acid, because it will not produce H plus ion in the solution. Okay, only those substances which gives H plus ions in solution will behave as acids. Okay. Hello everyone, welcome you all to the chemistry class. In the previous class, we had discussed about the chemical properties of acids and bases. Okay, and we have also come to know that acids and bases conducts electricity in aqueous solution, because they form ions in aqueous solution. Okay, in this class, we are getting into more detailed explanation of their behavior in water. Okay, and also we are going to study about the pH scale in this class and importance of pH. Okay, let's get started. So in the previous class, we have come to know that when acids and bases are dissolved in water, they form ions, and also because of those ions, they conduct electricity. Okay, here the question arises whether acids produces ions in only water? We have to check this question. Let us study this concept with the help of an activity. Okay, let us perform an activity and let us check whether acids produce ions only in water. Yes, let us check. What you have to do is you have to prepare fresh HCl gas. Okay, take a test tube and in it add sodium chloride and then add sulfuric acid to it. There is a formation of hydrogen chloride gas. Okay, this is a preparation of hydrogen chloride gas. Then what happens when this hydrogen chloride gas is tested with litmus paper? We will come to know about its acidity. Okay, let us perform this activity. Take about 1 gram of sodium chloride in the test tube, then add concentrated sulfuric acid to it. What happens? There is a formation of HCl gas there. Okay, there is a evolution of gas, that is hydrogen chloride. The HCl gas that is formed is passed through this delivery tube and then it is checked with the both dry litmus paper and wet litmus paper. Okay, dry and wet litmus paper separately. Okay, if the environment is moisture in nature, then we have to fix the guard tube containing calcium chloride so that it must absorb the moisture from the environment, as we are checking the acidity of this gas in the dry condition. Okay, and also wet litmus paper is also used in other case. We have to test in both the cases. Okay, then we are observing what's happening, whether the color is changing or not. Okay, what observation do we make here? Here we observe that wet litmus paper has changed its color from blue to red, showing that it is acid. Okay, whereas dry litmus paper has not shown any color change. Why? Because in dry litmus paper there is no dissociation of ions of HCl gas there. HCl has not formed into its respective ions with dry litmus paper. Whereas in case of wet litmus paper, what has happened? The HCl gas that is passed through it in the presence of water, it has dissociated into H plus and Cl minus ions. So this shows that the acidity or the acidic character is due to the formation of H plus ions. And also it shows that not all the compounds that are containing hydrogen will behave as acid. We know that methane contains hydrogen. Yes, methane contains hydrogen. But does it behave like acid? No, not at all, because it will not produce any H plus ions. It is not producing H plus ions, so it is not acidic in nature. So from this experiment, we observe that the substance will behave as acid if it produces H plus ions in solution, that is aqueous solution. Okay, so the observation that we have made are dry litmus paper does not show color change. We know that red litmus paper sorry red litmus paper will turn into blue if it is base, and blue litmus paper will turn into red if it is acid. Okay, whereas wet litmus paper showed the color change from blue to red. Okay, we have taken here one blue litmus paper that is dry, another one is wet blue litmus paper. Okay, from blue to red. This shows that that is acidic in nature. That gas which has produced ions in the presence of water is acidic in nature. Okay, dry HCl gas will not show acidic character because of absence of H plus ions. Once it in the presence of water it produces the ions, then it will behave as acid. Okay, this is the inference that we can draw from this activity. Okay, so we have come to know that in the presence of water it forms H plus ions and chloride ions. Can you observe what is this? These are hydronium ions, means this is a hydronium ion. How it is formed? We know that in aqueous solution H plus ions are produced from HCl, hydrochloric acid, but these H plus ions are not stable, so they always combine with H2O to form hydronium ions. Okay, they always exist in the form of H3O plus, that is hydronium ion. This you should remember. How in the acids hydrogen ions are present? They are present in the form of hydronium ions. More the concentration of hydronium ions, more is the acidic nature of a solution. Okay, this you have to remember. Always H plus ions are present in the form of hydronium ions, so they are always indicated by either H plus aqueous or H3O. So they are always indicated as H plus aqueous or H3O plus, that is hydronium ions. Okay. In the same way, what happens when bases are dissolved in water? The bases which are soluble in water, like NaOH, when it is dissolved in water, what happens? They form Na plus and OH minus ions. Okay. The basic property is due to the presence of these OH minus ions. Okay, the acidic property is due to H plus ions and basic property is due to the hydroxide ions. And also here we are talking about those bases which are soluble in water. As we know that sodium hydroxide and potassium hydroxide, they are soluble in water. So we will represent it as aqueous. Okay. So here we are talking about those bases which are soluble in water. What they are called as? They are called as alkalis. Okay. There are bases which are not soluble in water. Okay. They are simply called bases, but those bases which are soluble in water, they form hydroxide ions. Okay. We will come across still detailed explanation or broader concepts of acid, sign, bases in your higher class. For now, you should remember that bases are those substances which after reaction with acids yield salt and water, and they will produce hydroxide ions in water. And it is true that still there are many bases which are not soluble in water, but they have basic properties. We will come across it in the higher classes. Okay. So the bases which are soluble in water are called alkalis. So once we are talking about the solution of bases in aqueous in water, then we must understand that we are talking about the alkalis here. Okay. These both are alkalis. Sodium hydroxide and potassium hydroxide, both are alkalis. Okay. Now we have understood that H plus are produced by acids and OH minus are produced by bases, will result in the formation of water. Yes, we have studied in the neutralization reaction that acids and bases react with each other to form salt and water. Where does that water come from? It is due to the uh, hydrogen cation from acid and hydroxide anion from base. Okay, this has resulted in the formation of water here. Okay. So now we have come to know that acids will produce ions only in the solution, and the acidic property is due to the presence of those H plus ions. Okay. Not all the compounds which are having hydrogen in it behave as acids. Only those substances which produce H plus ions in water will behave as acids. Okay. Because of which in the previous experiment also we have come to know that why the glucose solution was not conducting electricity, because there was no formation of ions. Okay. Our next concept is about the dilution of acids and bases. What do you mean by dilution? When you add water to the base or acid, then it will be get diluted. The concentration of water in the solution will increases. Okay. Let us study about the dilution concept now. Mixing of, or the process of dissolving acid or base in water is called as dilution. Okay. When you add acid or base to the water, when you mix them, what happens? The process is highly exothermic. A lot amount of heat is released during the process. Okay. Always care must be taken while diluting a base or acid, because of which in your laboratories you might have seen that a warning symbol is displayed on the cans of acids and bases. Okay. The process of dilution is highly exothermic. Lot amount of heat is released. Okay. So always care must be taken. And the most important thing is you must always add acid or base slowly to the water. You should never add water directly to the acid or base solution. If you add water to the concentrated acid or base solution, what happens? All of a sudden the temperature will rise. Lot amount of heat is liberated, which causes the mixture to splash out, and it may cause damage to our skin also. Sometimes the heat liberated is so much that it will cause the breaking of the container in which the acid or base was taken. Okay. Always care must be taken while diluting the acid or base. Okay. Always and acid or base is added slowly to the water. You should never add water to concentrated acid or base. Okay, with constant stirring. You should add it in very small amounts. You should add acid or base in very small amount to the water, and you should always keep stirring it continuously. Okay, so that the heat liberated will not cause the mixture to splash out. Water is a good absorber of heat. What is the difference if you add acid or base to the water or water to acid or base? What happens is, if you add acid or base to water, then also it is exothermic one. Yes, it is true that it is exothermic, but the heat liberated is absorbed by the water. It will not cause the sudden rise of temperature, and it will not cause the splashing out of the mixture. Okay, it is a good absorber of heat. Whereas what happens if you add water to the concentrated acid or base, then acid or base starts dissociating it into ions, into their respective ions. Then suddenly the temperature raises, and there is no water to absorb that heat. It will suddenly splashes out, and also sometimes the breakage of the container may also happen. Okay, with constant stirring. Never add water to concentrated acid or base. Okay. Even in your laboratories, what you have to do, if you want to dilute the acidic or basic solution, then you have to take the beaker. In it, you should take the water. Then you should start adding acid in a very smaller quantities, and then you should stir the mixture. Okay. What happens to the mixture after dilution? Is there any change in the mixture? Yes. Once you add water to the solution of a base or acid, that is, if you add acid or base to the water, what happens? There is a decrease in the concentration of H plus ions or hydronium ions in case of acid, or hydroxide ions in case of base. Okay, mixing of acid or base with water will result in decreasing the concentration of hydronium ions or hydroxide ions in case of base per unit volume. This process is called as dilution. Okay, what happens when the acids or bases are diluted? Why does this result in the formation of decreasing the concentration of hydroxide ions and hydronium ions? Because let us see with the help of example here. Suppose if you have taken a container containing acid, suppose it consists of 1 liter of acid. Let us take an example for your understanding purpose. Okay, again what I will do is I will add water to it. Okay, in practical we are adding acid to water, but for your understanding purpose, let us take that we are diluting it. Okay, here assume that there are 100 molecules. Okay, there will be millions of molecules in it. For your understanding purpose, imagine that there are 100 molecules of acids here, just for imagination purpose. Okay, if I add 1 more liter of water to it, what happens? It gets diluted. Yes or not? If I add 1 more liter to it, then what happens? The overall volume of the solutions become 2 liters. Okay, we are not adding here acid. The amount of acid is same. What I am doing is I am diluting the mixture by simply adding water to it. Initially, what was the case? Initially, there were 100 molecules of acids per 1 liter of acids. Okay, now what is the case? After adding 1 more liter of water to it, there are still 100 molecules. Yes, we have not changed the molecules of acid. The amount of acid taken in the container is same, but now there are 100 molecules per 2 liter of the acid. The amount of whole solution has changed now. This means that if there are 100 molecules per 2 liter of acid, it means that there are 50 molecules. If I convert it for per unit volume, it means 50 molecules per liter, means for 1 liter. Our definition is that dilution results in the decrease in the concentration of ions per unit volume. Okay, initially there were 100 molecules per 1 liter. Now after diluting, what has happened? They have spread all over the solution. These molecules of acids or ions of acids, yes, it is true that they are present in the form of ions here. Let us take hydronium ions. These are all hydronium ions. And also we have chloride ions also in it, as acid consists of both H plus and Cl minus in case of hydrochloric acid. Yes, but we are concentrating here upon H plus ions or hydronium ions because our acidity or acidic character is due to the H plus ions. Okay. Now we have got that there are 50 molecules or 50 hydronium ions per liter. This has resulted in the decrease in concentration of ions per unit volume. Initially there were 100 H3O plus. Do not take it as molecules, take it as ions, because always it is, as it is a strong acid, they are present in the form of ions. Okay, take it as, now we have got that there is a decrease in the concentration of hydronium ions to 50 hydronium ions per liter. So always remember, dilution results in the decrease in concentration of ions per unit volume. Okay. As this is a strong acid, what acid that we have taken is HCl. As it is strong acid, it will dissociate completely to form H plus and Cl minus. Okay, if I have put 100 molecules in it, all the molecules have dissociated into hydronium ions and chloride ions. Okay, because of which now I have got that dilution results in the decrease in concentration of hydronium ions in case of acid, and in case of base it will result in the decrease in concentration of hydroxide ions there. Okay, next let us solve some questions here. It is given in your in-text question also. How is the concentration of hydronium ions affected when a solution of an acid is diluted? Right now we have discussed about it. Okay, we have taken a solution of an acid, we are diluting it. How do we dilute it? By adding water to it. The amount of acid is same in the solution, but we are adding water to it. This results in the dilution. Okay. What happens there? When the acid solution is diluted, it will cause decrease in the concentration of hydronium ions per unit volume. So your answer is the concentration of, this is a very important concept, you should remember. Okay, you will come across the concentration terms in detail in your higher classes also. Okay, the concentration of hydronium ions per unit volume decreases when the solution of an acid is diluted. When the, you might have seen in your home also, if you prepare lemonade, lemon juice using lemon and sugar and water, what happens? You have prepared a perfect lemonade from it. What happens if you add some water to it? Is there any change in the taste? Yes, of course, you feel the change in the taste as the quantity of sugar is being reduced. Actually, the quantity of sugar is not reduced, as the lemonade that you had prepared is diluted. Okay, the concentration of sugar per unit volume decreases, because of which you will feel that the concentration of sugar is reduced there. Okay, this is same what happens here. Upon dilution, the concentration of hydronium ions, this is very important, the concentration of hydronium ions per unit volume decreases when the solution of an acid is diluted. Okay, then next question. How is the concentration of hydroxide ions affected when excess base is dissolved in it? Okay, we have the solution of base here. Now what we are doing is, when excess base is dissolved in it, we have the same solution. Again, I am adding base to it, to the same solution. What happens there? Still more hydroxide ions are produced. Okay, this results in the increase in the concentration of hydroxide ions. Okay, so when excess of base is dissolved in it, so when excess of base is dissolved in the solution, the concentration of hydroxide ions increases. Okay, have you understood about the concept of dilution? You should remember this concept. Okay, this is very important actually. So now we will discuss about the strength of acids and bases. Okay, we know that the strength of acids and bases, it depends on the concentration of H plus ions and OH minus ions, that is hydroxide ions and hydronium ions amount. Okay, so we have qualitatively determined whether a given substance is acid or base by using the indicators. Okay, we have come across many indicators like phenolphthalein, methyl orange, rose, etc. We have determined the acidic or basic character by using them. But now, in order to understand the strength of these acids, okay, how strong is an acid, how strong is a base, we have to determine it. So for that, we will use the indicator called as universal indicator. So by using this universal indicator, we will find the amount of the ions, that is hydronium ions or H plus ions in water and hydroxide ions. The more the amount of these ions, the more is the acidic or basic character. Okay, what is this universal indicator? Actually, this is a mixture of several indicators. Okay, if you take a single indicator, then it will show the range over a very small scale. But if you take the universal indicator, it will cover a very large numbers. Okay, from very weak acids to very strong bases also. Okay, because of which we will use a universal indicator. It is actually a mixture of several indicators, and it shows different colors at different concentration of hydrogen ions. By using this indicator, we will come to know how strong is the acid, and it is always convenient to measure the acidity of a substance in terms of its hydrogen ion concentration. Okay, the more the concentration of hydrogen ions, the more acidic is the substance. The very less the concentration of hydrogen ions, it is not that much acidic. And same with the hydroxide ions also. Okay, more the amount of hydroxide ions, the more basic will be the substance. Okay, so for this we have to quantitatively measure its strength. So a pH scale was developed for measuring the hydrogen ion concentration in a solution. This scale runs from 0 to 14. Okay, this is a scale. We have to quantitatively determine the strength of acid or bases. Okay, for this we must have some scale, which if I give a solution of acid A and tell you to determine its acidity, then what I need to do, I have to compare it with the help of pH scale. Okay, let me show you how it looks. This scale runs from 0. The values of very less quantity means if the value of a solution, that is pH value, is very less, it shows the acidic character, and if it is very large, then it shows a basic character. Okay, let me show you. Okay, see here, this is a pH scale. As you move from 0 to 7, this covers the acidic nature of the substance. If the pH value of a substance is in between 0 to 7, if the pH value of the solution is between, if the pH value of a solution is between 0 to 7, then it is acidic. 0 to 7 means 0 to 6.9 something. If the pH value is exactly 7, then it is neutral in nature. The given substance is neutral. Okay, again, if the pH value is in between 7.1 to 14, then it is basic in nature. These values you have to remember. If the pH value is from 0 to 7, then it is acidic. If it is in between 7 to 14, then it is basic solution. If it is exactly 7, then the given solution is neutral in nature. Okay, I say a two solution A and B, the pH of the solution A is 5 and the pH of the solution B is 2. Which one is more acidic? This B solution is more acidic. Why? Because the lesser the value of pH, the more acidic it will be. The solution B will be more acidic. You can see here, as the numbers decreases here, the acidic character increases, and pH value, it has not any unit, it is just a number. Okay, then if I say the two solution A and B, and the pH of the solution A is 7.5 and pH of the solution B is 13, then if I ask you which one is more basic, then your answer will be the solution B is more basic, because as the value of pH increases, the basicity of the also increases. Okay, then you can see here some of the pH values of the substances like gastric juice, lemon juice, pure water, milk of magnesia, sodium hydroxide. How can you find out the pH value? You have to take the universal indicator strip. Okay, then you have to dip it in the solution whose pH value is to be tested. Suppose if I take lemon juice, okay, I don't know it is a lemon juice, I don't know its pH value. What I will do, I will dip the pH indicator, that is strip of the pH universal indicator. Then I will come to know that the color change is to this orange. Then I will compare it with this pH value, okay, scale. So now I will realize that the pH of the given solution is 2. Okay, understand? And again, if I take milk of magnesia or sodium hydroxide solution, okay, in a beaker, then I will dip the universal indicator in it. Then I will observe the color change. Okay, the color change will be dark blue, something like this. Then I will compare it with this values. Then it comes out to be 14. In this way, I will measure the pH values. This is why universal indicator is very important. If you use a single indicator like phenolphthalein, it will work over a very small range. Okay, it will not cover this broad range. This pH values will cover almost all the substances. Okay, right from gastric juice to sodium hydroxide, which is very basic in nature, it will cover almost all the substances as it is a mixture of indicators. It will show different color changes at different concentrations. Okay, this is all about the pH value and universal indicator. So now we are going to study about the importance of pH. So far we have understood that pH scale is used to determine the values that is related to acidity or basicity of a substance. Now we are going to understand what is the importance of studying this pH. What is the importance to know about the pH? Yes, let us start. The most important thing is all the living organisms work under a narrow range of pH. Okay. The whatever the metabolic activities that are undergoing in our body, that are taking place in our body, is in a specific range of pH. Okay. First of all, we need to understand that all living organisms are pH sensitive. Okay, means the metabolic activities that are taking place in our body will be carried out in a specific narrow range of pH. Not only human beings, all the living organisms including plants and animals, they are pH sensitive. Okay, and our human body works in the narrow range of pH, that is 7 to 7.8. Our body works in the pH range of 7 to 7.8. So it needs to be maintained in balance. Okay, if the values largely deviate from these values, then the person will be affected with many diseases. Okay, then what about pH of rainwater? Okay, we know that rainwater, when it becomes acidic, if the pH of the rainwater decreases, then it will cause harmful, or it will be harmful to the aquatic animals or aquatic plants. How does the pH of the rainwater decreases? We know that the many non-metallic oxides like SO2, CO2, when they are dissolved in water, when the concentration of these gases increases in air, they dissolve in water, that is rainwater, to form their respective oxides. For example, carbon dioxide forms carbonic acid, nitrogen dioxide, it may form nitric acid. In this way, when these dissolve in water, they form their respective acids. Okay, this causes the rainwater to become acidic. The pH of the rainwater will decreases. When the pH of this rainwater decreases, what happens? It will affect the aquatic life and aquatic plants also, and the same rainwater that will be used for agricultural purposes, then also the crops that are harvested or the crops that are grown will also be affected. Okay, so if the pH of rainwater is less than 5.6, less than 5.6, it is called as acid rain. Okay, it is called. So when the pollution in the air increases, the gases like sulfur dioxide, carbon dioxide will increase in the amount in the air. So when they get dissolved in water, they form acid rain. Okay, it is very important to maintain the pH of this rainwater. It must not go below this value. Okay, which affects aquatic life, and also that same water which is supplied for agricultural purposes, it is also affecting the agricultural land. Okay, then what about pH of soil? We should know that our soil has a particular pH value, and the crops that needs the particular value of pH is to be maintained. Okay, Different crops require different pH of the soil. Okay, some crops require some particular range of pH, some other crops require some particular range of pH. Okay, so the pH of soil needs to be maintained, and the dissolving of minerals or nutrients in the soil also depends on the pH value. And one more thing, the microorganisms, that is the good microorganisms that are required for the healthy growth of plants, also depends on the pH of the soil. So what we need to do is, if I am growing some crops in our agricultural land, then I need to send the sample of the soil to the agricultural office where or laboratory where it is find out, that is pH. Then if the soil founds to be too acidic, okay, if it is more acidic than the required amount, then I need to neutralize it with the base by adding the bases like calcium hydroxide or limestone. Then it will decreases the acidity of the soil. Now you are going to understand where we are practically applying the pH values. Okay, so if the soil seems to be more basic in nature, then we will add some organic matter into it in order to decrease the basic nature of the soil. So all crops will work, means will grow in a particular range of pH of the soil. So we need to test the pH of the soil before growing the crop. Okay, the crops or any plants require specific pH range for soil. If the soil is too acidic, if the soil is too acidic, then also the growth of the plant will be deteriorated. Okay, too acidic, the growth of the plant will be decreased. Okay, too acidic, then add limestone or calcium hydroxide, which decrease the acidity of the soil. Or if the soil is too basic, then add organic matter into it to decrease basicity. Okay, because it is very important. Okay, maintaining the agricultural land and maintaining the pH of the soil plays a very important role for agricultural and growth of crops and plants. Now you have understood, if it is too acidic, then add limestone or calcium hydroxide to it, or if it is too basic, then you can add organic matter to decrease the basicity. Okay, next, there is one interesting mechanism that takes place in our body. Okay, our stomach produces gastric juice, okay, for digestion. That gastric juice has hydrochloric acid. Yes, gastric juice, it consists of hydrochloric acid, but it will not harm our stomach. Hydrochloric acid, it is helpful for digestion of the food. Okay, and also when digestion takes place, there is a requirement of digestive enzymes there. Those enzymes are active in the presence of this acid. When this acid is present in our stomach and the pH of the stomach is maintained properly, then those enzymes will work. If there is indigestion, there is a production of excess gastric juice or excess hydrochloric acid in our stomach. It causes pain and irritation in our stomach. You might have felt also. Okay, you might have experienced during indigestion. What happens, there is a burning sensation, or there is some irritation that's happening in your stomach. It is due to the excess hydrochloric acid. Okay, if there is excess hydrochloric acid in stomach, it causes pain and irritation in the stomach. Okay, then what we need to do, we have studied about the neutralization reaction. Okay, let us apply this neutralization reaction in this concept. Okay, we know that bases will nullify the effect of acids and acid will nullify the effect of base. Now if I am suffering from indigestion and my stomach is producing excess hydrochloric acid, then I need to decrease the effect of this hydrochloric acid. How can I do it? By adding base into my stomach. I cannot add any kind of base, means I cannot add randomly any base like sodium hydroxide, as they are corrosive in nature. So only mild bases like, to treat acidity, mild bases like milk of magnesium, that is what antacids consists of. Antacid means it decreases the acidity in our stomach. Okay, mild bases like milk of magnesia, that is magnesium hydroxide, is taken. That is, antacid must be taken which has mild bases like milk of magnesia. It will neutralize the excess acid present in our stomach. So this gastric juice is very important for digestion, that is the hydrochloric acid, where the enzyme will work properly. And if there is excess production of this hydrochloric acid in our stomach, it causes pain and irritation. But in order to treat this acidity, this is called as acidity, we will take mild bases like milk of magnesia as antacid. Okay, this is all about pH in our digestive system. Okay, see, we are applying the pH concept in our daily life, so it is very important to know about the pH. Okay, then pH change as a cause of tooth decay. Okay, you people, almost all of you might have experienced the tooth decay. Why does it happens? It is due to the excess acid in our mouth. Why does this happen? Why does acidity of our mouth increases? Yes, I will explain. What happens? We will eat food or sugar, and the what happens is, when we eat food and other sugar materials or sugary foods, there is a breakage of these food or sugar by the bacteria present in our mouth. Okay, the food we eat or sugar substances or sugary substances that we consume, when they are stuck in the mouth, when they are stuck in the mouth, they are degraded by the bacteria. Okay, they are degraded by bacteria present in our mouth. Okay, while doing so, they release acids. Okay, by releasing acids in our mouth. When the pH of mouth goes below 5.5, it causes tooth decay. Okay, the tooth is said to be corroded. Actually, the tooth enamel is made up of a very strong substance, that is calcium phosphate. Calcium phosphate. What happens once the bacteria releases acids into our mouth, it will get corroded. Okay, the tooth enamel gets corroded and it will causes tooth decay when pH of the mouth decreases below 5.5. Okay, when pH of mouth is less than 5.5, this is how the tooth decay happens. Then what is the remedy? Then we need to wash our mouth properly after eating anything. Okay, this is all caused due to the particles that has been stuck in our mouth, and those particles have been decomposed or degraded by the bacteria present in our mouth by releasing the acids there. Okay, so what happens after eating any meal? We have to clean our mouth properly, and also using the toothpaste that is basic in nature also helps to decrease the acidity in our mouth. Okay, to treat or to prevent tooth decay, wash mouth properly after every meal. Okay, and also use toothpaste that is basic in nature. Use toothpaste that has mild bases. Okay, it will help to decrease the acidity of the mouth. Okay, you have understood about the cause of tooth decay. When we eat the food or sugary substances, they are stuck in the mouth, they are degraded by the bacteria present in our mouth by releasing the acids. Okay, when these release the acids, the tooth get corroded, so that the pH of the mouth is less than 5.5. This causes the tooth decay. In order to prevent the tooth decay, we need to wash our mouth properly after eating every meal, and also we should use the toothpaste that has mild base. Okay, next, there is an interesting defense mechanism that takes place in plants and animals. Every plant or every organism on this earth try to protect themselves. Okay, when the animals like bees or ants, when they bite any other organism or human beings, what happens? They release some acids on our skin. Okay, because of which we will be feeling the pain and irritation or burning sensation. Why do they do so? Because they try to protect themselves. Okay, when they are attacked by the predators, Like human beings, if you go on touching them, what they think, in order to protect themselves, they will release acids by biting on our skin. Okay, bees and ants bite, they release acids on our on skin. Usually bee sting consists of acid, that is methanoic acid. So just after biting on our skin, what happens, we will feel the irritation and burning sensation on us. Okay, so what we need to do is we have to rub that area with the help of baking soda, which is a base. We know that methanoic acid is acid. Because of that acid, we are feeling the pain and irritation. What happens, in order to prevent that, in order to get relief, we have to rub the stung area with baking soda, so that this baking soda neutralizes the acid that is injected on our skin by bees or ants. Okay, okay, this is a self defense by animals. What they have done, in order to get protected themselves from the predators, they will release acid, so we will move away from them. And this acids that get this acids irritates us, means they irritate our skin. So in order to get relief from them, we have to rub the stung area with baking soda. Okay, then what about defense mechanism that is seen in plants? Have you seen the nettle leaves? It is a kind of plant. Nettle plants have nettle leaves. Okay, nettle leaves, they have hair like structure on their leaves, have hair like structure on their leaves. Suppose if we touch it unintentionally, what happens, the hair like structure consists of acid. Okay, and because of that acid getting injected on our skin, we will get irritated and also pain occurs on our skin. So what happens, we need to neutralize that acid. What they have injected, they have injected the acid, that is it consists of methanoic acid. Methanoic acid, again we have to neutralize this acid. And one more interesting thing is, wherever there are nettle plants, in most of the cases there will be nearby the plant named dog plant. Okay, the name of the plant is dog plant. In order to get relief, we have to rub the stung area, or the area which we have get irritated, we have to rub there with the help of the leaves of dog plant. We have to crush those leaves and we have to apply the liquid, that liquid on our skin. It will get relief. Why? Because the dog plant leaves have basic substances in them. Basic they have basic substance, because of which we get relief from the methanoic acid, the burning sensation that is caused by methanoic acid. Okay, have you understood how the pH value plays a very important role in our daily life, that we come across many instances where we have to apply the knowledge of pH value. Okay, by this let us conclude today's session, and in the tomorrow's session we will continue with the next part. Okay, hello everyone, welcome you all to the chemistry class. In the previous class, we had discussed about the chemical properties of acids and bases. Okay, and we have also come to know that acids and bases conducts electricity in aqueous solution because they form ions in aqueous solution. Okay, in this class, we are getting into more detailed explanation of their behavior in water. Okay, and also we are going to study about the pH scale in this class and importance of pH. Okay, let's get started. So in the previous class, we have come to know that when acids and bases are dissolved in water, they form ions, and also because of those ions, they conduct electricity. Okay, here the question arises whether acids produces ions in only water. We have to check this question. Let us study this concept with the help of an activity. Okay, let us perform an activity and let us check whether acids produce ions only in water. Yes, let us check. What you have to do is you have to prepare fresh HCl gas. Okay, take a test tube and in it add sodium chloride and then add sulfuric acid to it. There is a formation of hydrogen chloride gas. Okay, this is a preparation of hydrogen chloride gas. Then what happens when this hydrogen chloride gas is tested with litmus paper? We will come to know about its acidity. Okay, let us perform this activity. Take about 1 gram of sodium chloride in the test tube, then add concentrated sulfuric acid to it. What happens? There is a formation of HCl gas there. Okay, there is a evolution of gas, that is hydrogen chloride. The HCl gas that is formed is passed through this delivery tube, and then it is checked with the both dry litmus paper and wet litmus paper. Okay, dry and wet litmus paper separately. Okay, if the environment is moisture in nature, then we have to fix the guard tube containing calcium chloride so that it must absorb the moisture from the environment, as we are checking the acidity of this gas in the dry condition. Okay, and also wet litmus paper is also used in other case. We have to test in both the cases. Okay, then we are observing what's happening, whether the color is changing or not. Okay, what observation do we make here? Here we observe that wet litmus paper has changed its color from blue to red, showing that it is acid. Okay, whereas dry litmus paper has not shown any color change. Why? Because in dry litmus paper there is no dissociation of ions of HCl gas there. HCl has not formed into its respective ions with dry litmus paper. Whereas in case of wet litmus paper, what has happened? The HCl gas that is passed through it in the presence of water, it has dissociated into H plus and Cl minus ions. So this shows that the acidity or the acidic character is due to the formation of H plus ions. And also it shows that not all the compounds that are containing hydrogen will behave as acid. We know that methane contains hydrogen. Yes, methane contain hydrogen. But does it behave like acid? No, not at all, because it will not produce any H plus ions. It is not producing H plus ions, so it is not acidic in nature. So from this experiment we observe that the substance will behave as acid if it produces H plus ions in solution, that is aqueous solution. Okay, so the observation that we have made are dry litmus paper does not show color change. We know that red litmus paper sorry uh, red litmus paper will turn into blue if it is base, and blue litmus paper will turn into red if it is acid. Okay, whereas wet litmus paper showed the color change from blue to red. Okay, we have taken here one blue litmus paper that is dry, another one is wet blue litmus paper. Okay, from blue to red. This shows that that is acidic in nature. That gas which has produced ions in the presence of water is acidic in nature. Okay, dry HCl gas will not show acidic character because of absence of H plus ions. Once it in the presence of water it produces the ions, then it will behave as acid. Okay, this is the inference that we can draw from this activity. Okay, so we have come to know that in the presence of water it forms H plus ions and chloride ions. Can you observe what is this? These are hydronium ions, means this is a hydronium ion. How it is formed? We know that in aqueous solution H plus ions are produced from HCl, hydrochloric acid, but these H plus ions are not stable, so they always combine with H2O to form hydronium ions. Okay, they always exist in the form of H3O plus, that is hydronium ion. This you should remember. How how in the acids hydrogen ions are present? They are present in the form of hydronium ions. More the concentration of hydronium ions, more is the acidic nature of a solution. Okay, this you have to remember. Always H plus ions are present in the form of hydronium ions. So they are always indicated by either H plus aqueous or H3O. So they are always indicated as H plus aqueous or H3O plus, that is hydronium ions. Okay. In the same way, what happens when bases are dissolved in water? The bases which are soluble in water like NaOH, when it is dissolved in water, what happens? They form Na plus and OH minus ions. Okay. The basic property is due to the presence of these OH minus ions. Okay, the acidic property is due to H plus ions and basic property is due to the hydroxide ions. And also here we are talking about those bases which are soluble in water. As we know that sodium hydroxide and potassium hydroxide, they are soluble in water. So we will represent it as aqueous. Okay. So here we are talking about those bases which are soluble in water. What they are called as? They are called as alkalis. Okay. There are bases which are not soluble in water. Okay. They are simply called bases, but those bases which are soluble in water, they form hydroxide ions. Okay. We will come across still detailed explanation or broader concepts of acid sign bases in your higher class. For now, you should remember that bases are those substances which after reaction with acids yield salt and water, and they will produce hydroxide ions in water. And it is true that still there are many bases which are not soluble in water, but they have basic properties. We will come across it in the higher classes. Okay. So the bases which are soluble in water are called alkalis. So once we are talking about the solution of bases in aqueous in water, then we must understand that we are talking about the alkalis here. Okay. These both are alkalis. Sodium hydroxide and potassium hydroxide, both are alkalis. Okay. Now we have understood that H plus are produced by acids and OH minus are produced by bases will result in the formation of water. Yes. We have studied in the neutralization reaction that acids and bases react with each other to form salt and water. Where does that water come from? It is due to the hydrogen cation from acid and hydroxide anion from base. Okay. This has resulted in the formation of water here. Okay. So now we have come to know that acids will produce ions only in the solution, and the acidic property is due to the presence of those H plus ions. Okay. Not all the compounds which are having hydrogen in it behave as acids. Only those substances which produce H plus ions in water will behave as acids. Okay. Because of which in the previous experiment also we have come to know that why the glucose solution was not conducting electricity, because there was no formation of ions. Okay. Our next concept is about the dilution of acids and bases. What do you mean by dilution? When you add water to the base or acid, then it will be get diluted. The concentration of water in the solution will increases. Okay. Let us study about the dilution concept now. Mixing of, or the process of dissolving acid or base in water is called as dilution. Okay. When you add acid or base to the water, when you mix them, what happens? The process is highly exothermic. A lot amount of heat is released during the process. Okay. Always care must be taken while diluting a base or acid, because of which in your laboratories you might have seen that a warning symbol is displayed on the cans of acids and bases. Okay. The process of dilution is highly exothermic. Lot amount of heat is released. Okay. So always care must be taken. And the most important thing is you must always add acid or base slowly to the water. You should never add water directly to the acid or base solution. If you add water to the concentrated acid or base solution, what happens? All of a sudden the temperature will rise. Lot amount of heat is liberated, which causes the mixture to splash out, and it may cause damage to our skin also. Sometimes the heat liberated is so much that it will cause the breaking of the container in which the acid or base was taken. Okay. Always care must be taken while diluting the acid or base. Okay. Always an acid or base is added slowly to the water. You should never add water to concentrated acid or base. Okay. With constant stirring. You should add it in very very small amounts. You should add acid or base in very small amount to the water, and you should always keep stirring it continuously. Okay. so that the heat liberated will not cause the mixture to splash out. Water is a good absorber of heat. What is the difference if you add acid or base to the water or water to acid or base? What happens is, if you add acid or base to water, then also it is exothermic one. Yes, it is true that it is exothermic, but the heat liberated is absorbed by the water. It will not cause the sudden rise of temperature and it will not cause the splashing out of the mixture. Okay, it is a good absorber of heat. Whereas what happens if you add water to the concentrated acid or base, then acid or base starts dissociating it into ions, into their respective ions. Then suddenly the temperature raises and there is no water to absorb that heat. It will suddenly splashes out, and also sometimes the breakage of the container may also happen. Okay, with constant stirring. Never add water to concentrated acid or base. Okay. Even in your laboratories, what you have to do, if you want to dilute the acidic or basic solution, then you have to take the beaker. In it, you should take the water. Then you should start adding acid in a very smaller quantities, and then you should stir the mixture. Okay. What happens to the mixture after dilution? Is there any change in the mixture? Yes. Once you add water to the solution of a base or acid, that is, if you add acid or base to the water, what happens? There is a decrease in the concentration of H plus ions or hydronium ions in case of acid, or hydroxide ions in case of base. Okay, mixing of acid or base with water will result in decreasing the concentration of hydronium ions or hydroxide ions in case of base per unit volume. This process is called as dilution. Okay, what happens when the acids or bases are diluted? Why does this result in the formation of decreasing the concentration of hydroxide ions and hydronium ions? Because let us see with the help of example here. Suppose if you have taken a container containing acid, suppose it consists of 1 liter of acid. Let us take an example for your understanding purpose. Okay, again what I will do is I will add water to it. Okay, in practical we are adding acid to water, but for your understanding purpose let us take that we are diluting it. Okay, here assume that there are 100 molecules. Okay, there will be millions of molecules in it. For your understanding purpose, imagine that there are 100 molecules of acids here, just for imagination purpose. Okay, if I add 1 more liter of water to it, what happens? It gets diluted. Yes or not? If I add 1 more liter to it, then what happens? The overall volume of the solutions become 2 liters. Okay, we are not adding here acid. The amount of acid is same. What I am doing is I am diluting the mixture by simply adding water to it. Initially what was the case? Initially there were 100 molecules of acids per 1 liter of acids. Okay, now what is the case? After adding 1 more liter of water to it, there are still 100 molecules. Yes, we have not changed the molecules of acid. The amount of acid taken in the container is same, but now there are 100 molecules per 2 liter of the acid. The amount of whole solution has changed now. This means that if there are 100 molecules per 2 liter of acid, it means that there are 50 molecules. If I convert it for per unit volume, it means 50 molecules per liter, means for 1 liter. Our definition is that dilution results in the decrease in the concentration of ions per unit volume. Okay, initially there were 100 molecules per 1 liter. Now after diluting, what has happened? They have spread all over the solution. These molecules of acids or ions of acids, yes, it is true that they are present in the form of ions here. Let us take hydronium ions. These are all hydronium ions. And also we have chloride ions also in it, as acid consists of both H plus and Cl minus in case of hydrochloric acid. Yes, but we are concentrating here upon H plus ions or hydronium ions because our acidity or acidic character is due to the H plus ions. Okay, now we have got that there are 50 molecules or 50 hydronium ions per liter. This has resulted in the decrease in concentration of ions per unit volume. Initially there were 100 H3O plus. Do not take it as molecules, take it as ions, because always it is, as it is a strong acid, they are present in the form of ions. Okay, take it as, now we have got that there is a decrease in the concentration of hydronium ions to 50 hydronium ions per liter. So always remember, dilution results in the decrease in concentration of ions per unit volume. Okay. As this is a strong acid, what acid that we have taken is HCl. As it is strong acid, it will dissociate completely to form H plus and Cl minus. Okay, if I have put 100 molecules in it, all the molecules have dissociated into hydronium ions and chloride ions. Okay, because of which now I have got that dilution results in the decrease in concentration of hydronium ions in case of acid, and in case of base it will result in the decrease in concentration of hydroxide ions there. Okay, next let us solve some questions here. It is given in your in-text question also. How is the concentration of hydronium ions affected when a solution of an acid is diluted? Right now we have discussed about it. Okay, we have taken a solution of an acid, we are diluting it. How do we dilute it? By adding water to it. The amount of acid is same in the solution, but we are adding water to it. This results in the dilution. Okay, what happens there? When the acid solution is diluted, it will cause decrease in the concentration of hydronium ions per unit volume. So your answer is the concentration of, this is a very important concept, you should remember. Okay, you will come across the concentration terms in detail in your higher classes also. Okay, the concentration of hydronium ions per unit volume decreases when the solution of an acid is diluted. When the, you might have seen in your home also, if you prepare lemonade, lemon juice using lemon and sugar and water, what happens? You have prepared a perfect lemonade from it. What happens if you add some water to it? Is there any change in the taste? Yes, of course, you feel the change in the taste as the quantity of sugar is being reduced. Actually, the quantity of sugar is not reduced, as the lemonade that you had prepared is diluted. Okay, the concentration of sugar per unit volume decreases, because of which you will feel that the concentration of sugar is reduced there. Okay, this is same what happens here. Upon dilution, the concentration of hydronium ions, this is very important, the concentration of hydronium ions per unit volume decreases when the solution of an acid is diluted. Okay, then next question. How is the concentration of hydroxide ions affected when excess base is dissolved in it? Okay, we have the solution of base here. Now what we are doing is, when excess base is dissolved in it, we have the same solution. Again, I am adding base to it, to the same solution. What happens there? Still more hydroxide ions are produced. Okay, this results in the increase in the concentration of hydroxide ions. Okay, so when excess of base is dissolved in it, so when excess of base is dissolved in the solution, the concentration of hydroxide ions increases. Okay, have you understood about the concept of dilution? You should remember this concept. Okay, this is very important actually. So now we will discuss about the strength of acids and bases. Okay, we know that the strength of acids and bases, it depends on the concentration of H plus ions and OH minus ions, that is hydroxide ions and hydronium ions amount. Okay, so we have qualitatively determined whether a given substance is acid or base by using the indicators. Okay, we have come across many indicators like phenolphthalein, methyl orange, Shina etc. We have determined the acidic or basic character by using them. But now, in order to understand the strength of these acids, okay, how strong is an acid, how strong is a base, we have to determine it. So for that, we will use the indicator called as universal indicator. So by using this universal indicator, we will find the amount of the ions, that is hydronium ions or H plus ions in water and hydroxide ions. The more the amount of these ions, the more is the acidic or basic character. Okay, what is this universal indicator? Actually, this is a mixture of several indicators. Okay, if you take a single indicator, then it will show the range over a very small scale. But if you take the universal indicator, it will cover a very large numbers. Okay, from very weak acids to very strong bases also. Okay, because of which we will use a universal indicator. It is actually a mixture of several indicators, and it shows different colors at different concentration of hydrogen ions. By using this indicator, we will come to know how strong is the acid, and it is always convenient to measure the acidity of a substance in terms of its hydrogen ion concentration. Okay, the more the concentration of hydrogen ions, the more acidic is the substance. The very less the concentration of hydrogen ions, it is not that much acidic. And same with the hydroxide ions also. Okay, more the amount of hydroxide ions, the more basic will be the substance. Okay, so for this we have to quantitatively measure its strength. So a pH scale was developed for measuring the hydrogen ion concentration in a solution. This scale runs from 0 to 14. Okay, this is a scale. We have to quantitatively determine the strength of acid or bases. Okay, for this we must have some scale, which if I give a solution of acid A and tell you to determine its acidity, then what I need to do, I have to compare it with the help of pH scale. Okay, let me show you how it looks. This scale runs from 0. The values of very less quantity means if the value of a solution, that is pH value, is very less, it shows the acidic character, and if it is very large, then it shows a basic character. Okay, let me show you. Okay, see here, this is a pH scale. As you move from 0 to 7, this covers the acidic nature of the substance. If the pH value of a substance is in between 0 to 7, if the pH value of the solution is between, if the pH value of a solution is between 0 to 7, then it is acidic. 0 to 7 means 0 to 6.9 something. If the pH value is exactly 7, then it is neutral in nature. The given substance is neutral. Okay, again, if the pH value is in between 7.1 to 14, then it is basic in nature. These values you have to remember. If the pH value is from 0 to 7, then it is acidic. If it is in between 7 to 14, then it is basic solution. If it is exactly 7, then the given solution is neutral in nature. Okay, I say a two solution A and B, the pH of the solution A is 5 and the pH of the solution B is 2. Which one is more acidic? This B solution is more acidic. Why? Because the lesser the value of pH, the more acidic it will be. The solution B will be more acidic. You can see here, as the numbers decreases here, the acidic character increases, and pH value, it has not any unit, it is just a number. Okay, then if I say the two solution A and B, and the pH of the solution A is 7.5, and pH of the solution B is 13, then if I ask you which one is more basic, then your answer will be the solution B is more basic, because as the value of pH increases, the basicity of the also increases. Okay, then you can see here some of the pH values of the substances like gastric juice, lemon juice, pure water, milk of magnesia, sodium hydroxide. How can you find out the pH value? You have to take the universal indicator strip. Okay, then you have to dip it in the solution whose pH value is to be tested. Suppose if I take lemon juice, okay, I don't know it is a lemon juice, I don't know its pH value. What I will do, I will dip the pH indicator, that is strip of the pH universal indicator. Then I will come to know that the color change is to this orange. Then I will compare it with this pH value. Okay, scale. So now I will realize that the pH of the given solution is 2. Okay, understand? And again, if I take milk of magnesia or sodium hydroxide solution, okay, in a beaker, then I will dip the universal indicator in it. Then I will observe the color change. Okay, the color change will be dark blue, something like this. Then I will compare it with this values. Then it comes out to be 14. In this this way I will measure the pH values. This is why universal indicator is very important. If you use a single indicator like phenolphthalein, it will work over a very small range. Okay, it will not cover this broad range. This pH values will cover almost all the substances. Okay, right from gastric juice to sodium hydroxide, which is very basic in nature, it will cover almost all the substances as it is a mixture of indicators. It will show different color changes at different concentrations. Okay, this is all about the pH value and universal indicator. So now we are going to study about the importance of pH. So far we have understood that pH scale is used to determine the values that is related to acidity or basicity of a substance. Now we are going to understand what is the importance of studying this pH. What is the importance to know about the pH? Yes, let us start. The most important thing is all the living organisms work under a narrow range of pH. Okay, the whatever the metabolic activities that are undergoing in our body, that are taking place in our body, is in a specific range of pH. Okay, first of all we need to understand that all living organisms are pH sensitive. Okay, means the metabolic activities that are taking place in our body will be carried out in a specific narrow range of pH. Not only human beings, all the living organisms including plants and animals, they are pH sensitive. Okay, and our human body works in the narrow range of pH, that is 7 to 7.8. Our body works in the pH range of 7 to 7.8. So it needs to be maintained in balance. Okay, if the values largely deviate from these values, then the person will be affected with any diseases. Okay, then what about pH of rainwater? Okay, we know that rainwater, when it becomes acidic, if the pH of the rainwater decreases, then it will cause harmful, or it will be harmful to the aquatic animals or aquatic plants. How does the pH of the rainwater decreases? We know that the many non-metallic oxides like SO2, CO2, when they are dissolved in water, when the concentration of these gases increases in air, they dissolve in water, that is rainwater, to form their respective oxides. For example, carbon dioxide forms carbonic acid, nitrogen dioxide, it may form nitric acid. In this way, when these dissolve in water, they form their respective acids. Okay, this causes the rainwater to become acidic. The pH of the rainwater will decreases. When the pH of this rainwater decreases, what happens? It will affect the aquatic life and aquatic plants also, and the same rainwater that will be used for agricultural purposes, then also the crops that are harvested or the crops that are grown will also be affected. Okay, so if the pH of rainwater is less than 5.6, it is called as acid rain. Okay, it is called. So when the pollution in the air increases, the gases like sulfur dioxide, carbon dioxide will increase in the amount in the air. So when they get dissolved in water, they form acid rain. Okay, it is very important to maintain the pH of this rainwater. It must not go below this value. Okay, which affects aquatic life, and also that same water which is supplied for agricultural purposes, it is also affecting the agricultural land. Okay, then what about pH of soil? We should know that our soil has a particular pH value, and the crops that needs the particular value of pH is to be maintained. Okay, different crops require different pH of the soil. Okay, some crops require some particular range of pH, some other crops require some particular range of pH. Okay, so the pH of soil needs to be maintained, and the dissolving of minerals or nutrients in the soil also depends on the pH value. And one more thing, the microorganisms, that is the good microorganisms that are required for the healthy growth of plants, also depends on the pH of the soil. So what we need to do is, if I am growing some crops in our agricultural land, then I need to send the sample of the soil to the agricultural office where or laboratory where it is find out, that is pH. Then if the soil founds to be too acidic, okay, if it is more acidic than the required amount, then I need to neutralize it with the base by adding the bases like calcium hydroxide or limestone. Then it will decreases the acidity of the soil. Now you are going to understand where we are practically applying the pH values. Okay, so if the soil seems to be more basic in nature, then we will add some organic matter into it in order to decrease the basic nature of the soil. So all crops will work, means will grow in a particular range of pH of the soil. So we need to test the pH of the soil before growing the crop. Okay, the crops or any plants require specific pH range for soil. If the soil is too acidic, if the soil is too acidic, then also the growth of the plant will be deteriorated. Okay, too acidic, the growth of the plant will be decreased. Okay, too acidic, then add limestone or calcium hydroxide, which decrease the acidity of the soil. Or if the soil is too basic, then add organic matter into it to decrease basicity. Okay, because it is very important. Okay, agriculture, maintaining the agricultural land and maintaining the pH of the soil plays a very important role for agricultural and growth of crops and plants. Now you have understood, if it is too acidic, then add limestone or calcium hydroxide to it, or if it is too basic, then you can add organic matter to decrease the basicity. Okay, next, there is one interesting mechanism that takes place in our body. Okay, our stomach produces gastric juice, okay, for digestion. That gastric juice has hydrochloric acid. Yes, gastric juice, it consists of hydrochloric acid, but it will not harm our stomach. Hydrochloric acid, it is helpful for digestion of the food. Okay, and also when digestion takes place, there is a requirement of digestive enzymes there. Those enzymes are active in the presence of this acid. When this acid is present in our stomach and the pH of the stomach is maintained properly, then those enzymes will work. If there is indigestion, there is a production of excess gastric juice or excess hydrochloric acid in our stomach. It causes pain and irritation in our stomach. You might have felt also. Okay, you might have experienced during indigestion. What happens, there is a burning sensation, or there is some irritation that's happening in your stomach. It is due to the excess hydrochloric acid. Okay, if there is excess hydrochloric acid in stomach, it causes pain and irritation in the stomach. Okay, then what we need to do, we have studied about the neutralization reaction. Okay, let us apply this neutralization reaction in this concept. Okay, we know that bases will nullify the effect of acids and acid will nullify the effect of base. Now if I am suffering from indigestion and my stomach is producing excess hydrochloric acid, then I need to decrease the effect of this hydrochloric acid. How can I do it? By adding base into my stomach. I cannot add any kind of base, means I cannot add randomly any base like sodium hydroxide, as they are corrosive in nature. So only mild bases like, to treat acidity, mild bases like milk of magnesium. That is what antacids consists of. Antacid means it decreases the acidity in our stomach. Okay, mild bases like milk of magnesia, that is magnesium hydroxide, is taken. That is antacid must be taken which has mild bases like milk of magnesia. It will neutralize the excess acid present in our stomach. So this gastric juice is very important for digestion, that is the hydrochloric acid, where the enzyme will work properly. And if there is excess production of this hydrochloric acid in our stomach, it causes pain and irritation. But in order to treat this acidity, this is called as acidity, we will take mild bases like milk of magnesia as antacid. Okay, this is all about pH in our digestive system. Okay, see, we are applying the pH concept in our daily life, so it is very important to know about the pH. Okay, then pH change as a cause of tooth decay. Okay, you people, almost all of you might have experienced the tooth decay. Why does it happens? It is due to the excess acid in our mouth. Why does this happen? Why does acidity of our mouth increases? Yes, I will explain. What happens? We will eat food or sugar, and the what happens is when we eat food and other sugar materials or sugary foods, there is a breakage of these food or sugar by the bacteria present in our mouth. Okay, the food we eat or sugar substances or sugary substances that we consume, when they are stuck in the mouth, when they are stuck in the mouth, they are degraded by the bacteria. Okay, they are degraded by bacteria present in our mouth. Okay, while doing so they release acids. Okay, by releasing acids in our mouth. When the pH of mouth goes below 5.5, it causes tooth decay. Okay, the tooth is said to be corroded. Actually, the tooth enamel is made up of a very strong substance, that is calcium phosphate. Calcium phosphate. What happens once the bacteria releases acids into our mouth, it will get corroded. Okay, the tooth enamel gets corroded and it will causes tooth decay when pH of the mouth decreases below 5.5. Okay, when pH of mouth is less than 5.5, this is how the tooth decay happens. Then what is the remedy? Then we need to wash our mouth properly after eating anything. Okay, this is all caused due to the particles that has been stuck in our mouth, and those particles have been decomposed or degraded by the bacteria present in our mouth by releasing the acids there. Okay, so what happens after eating any meal? We have to clean our mouth properly, and also using the toothpaste that is basic in nature also helps to decrease the acidity in our mouth. Okay, to treat or to prevent tooth decay, wash mouth properly after every meal. Okay, and also use toothpaste that is basic in nature. Use toothpaste that has mild bases. Okay, it will help to decrease the acidity of the mouth. Okay, you have understood about the cause of tooth decay. When we eat the food or sugary substances, they are stuck in the mouth. They are degraded by the bacteria present in our mouth by releasing the acids. Okay, when these release the acids, the tooth get corroded, so that the pH of the mouth is less than 5.5. This causes the tooth decay. In order to prevent the tooth decay, we need to wash our mouth properly after eating every meal, and also we should use the toothpaste that has mild base. Okay, next, there is an interesting defense mechanism that takes place in plants and animals. Every plant or every organism on this earth try to protect themselves. Okay, when the animals like bees or ants, when they bite any other organism or human beings, what happens? They release some acids on our skin. Okay, because of which we will be feeling the pain and irritation or burning sensation. Why do they do so? Because they try to protect themselves. Okay, when they are attacked by the predators like human beings, if you go on touching them, what they think? In order to protect themselves, they will release acids by biting on our skin. Okay, bees and ants bite, they release acids on our on skin. Usually bee sting consists of acid, that is methanoic acid. So just after biting on our skin, what happens? We will feel the irritation and burning sensation on us. Okay, so what we need to do is we have to rub that area with the help of baking soda, which is a base. We know that methanoic acid is acid. Because of that acid we are feeling the pain and irritation. What happens? In order to prevent that, in order to get relief, we have to rub the stung area with baking soda, so that this baking soda neutralizes the acid that is injected on our skin by bees or ants. Okay, okay, this is a self defense by animals. What they have done in order to get protected themselves from the predators, they will release acid, so we will move away from them. And these acids irritates us, means they irritate our skin. So in order to get relief from them, we have to rub the stung area with baking soda. Okay. Then what about defense mechanism that is seen in plants? Have you seen the nettle leaves? It is a kind of plant. Nettle plants have nettle leaves. Okay. Nettle leaves. They have hair-like structure on their leaves. Have hair-like structure on their leaves. Suppose if we touch it unintentionally, what happens? The hair-like structure consists of acid. Okay. And because of that acid getting injected on our skin, we will get irritated and also pain occurs on our skin. So what happens? We need to neutralize that acid. What they have injected? They have injected the acid, that is it consists of methanoic acid. Methanoic acid. Again we have to neutralize this acid. And one more interesting thing is, wherever there are nettle plants, in most of the cases there will be nearby the plant named dog plant. Okay, the name of the plant is dog plant. In order to get relief, we have to rub the stung area or the area which we have get irritated. We have to rub there with the help of the leaves of dog plant. We have to crush those leaves and we have to apply the liquid, that liquid on our skin. It will get relief. Why? Because the dog plant leaves have basic substances in them. Basic they have basic substance because of which we get relief from the methanoic acid, the burning sensation that is caused by methanoic acid. Okay, have you understood how the pH value plays a very important role in our daily life, that we come across many instances where we have to apply the knowledge of pH value. Okay, by this let us conclude today's session, and in the tomorrow's session we will continue with the next part. Okay. Hello everyone. In the previous class, we have discussed about the chemical properties of acids and bases, and we have also studied the pH values of acids and bases and the importance of pH in everyday life. Okay. In the today's session, we are going to discuss about salts. Before moving to salts, let us solve some examples here related to pH. Let me read the question. You have two solutions A and B. The pH of solution A is 6 and the pH of solution B is 8. Which solution has more hydrogen ion concentration, and which of this is acidic and which of this is basic? Okay, they have given that there are two solutions A and B, and the pH value of A is 6 and the pH value of solution B is 8. We have to find out which solution has more hydrogen ion concentration and which is acidic and which is basic. We have learnt that if the pH value is in between 0 to 7, then the solution will be acidic. If it is exactly 7, then the solution will be neutral. If it is in between 7 to 14, then it will be basic. Here you can easily observe that the solution A has pH 6. So without doubt, the solution will be acidic. The solution A will be acidic. Then what about B? It is in between 7 and 14 and the solution will be basic in nature. Okay. And also we have to answer that which solution has more hydrogen ion concentration. We know that lesser the pH value, the more is H plus ion concentration. Okay, they are inversely related. You can see here pH value of A is 6, which is less than that of B, which has 8. So the lesser the pH value, the more is the hydrogen ion concentration. So I can write here the solution A has more hydrogen ion concentration. And the more the pH value, the more basic will be the solution. Okay. Then let us read the next question. Do basic solutions also have H plus ions? If yes, then why are these basic? Yes, we know that solution of bases are made in water. So water is a weak electrolyte. It will be having H plus ions also, as it dissociates as H plus and OH minus ions. Yes, the solution of these bases in water will have H plus ions. But the thing is, the amount of OH minus ion concentration is very, very greater than that of H plus ion concentration. So we have to write here, yes, basic solutions also have H plus ions as these solutions are prepared in water. But the concentration of OH minus ion is very much greater than that of H plus ions. But the concentration of OH minus ions is very much greater than that of H plus ion concentration. So as the concentration of OH minus ion is very much, the solution will be basic in nature. So the solution will be basic. Okay. Yes. Now let us move to the next part, that is we are going to study about the salts. Okay, we know that salts are the products of neutralization reaction, that is between acid and bases. Okay, these are ionic compounds. What are salts? These are ionic compounds formed by the neutralization reaction between acids and bases. And we should know that there are many salts which are naturally occurring in nature. That is, you know that seawater contains many salts. It is a mixture of many salts there. We usually extract salts from the evaporation of seawater. Basically, the sodium chloride, which is a edible salt that we use for cooking, is extracted from seawater only, as it consists of large amount of sodium chloride crystals. Okay, actually it is in the dissolved form. We will make the evaporation of seawater in order to get sodium chloride, and along with the sodium chloride there are also many salts that are present. What we will do is we will separate sodium chloride from those salts. Okay, what is common salt? Sodium chloride is called as common salt, which is basically used for cooking. It is the main ingredient in our cooking, yes, and it is also called as table salt. Sodium, we have seen that it is formed in the neutralization reaction between sodium hydroxide and hydrochloric acid. Okay, but for commercial purposes, for our domestic use, we will extract sodium chloride that is easily available in seawater. How do we prepare it? It is also called as table salt, which is used for cooking. How do we get common salt then? It is common salt is extracted by evaporating seawater. How they are made? Usually the small land beds like this, they are made near the seas in which the seawater is poured into them. They will be in larger quantities. Okay, so once this seawater gets dried up by the heat action of sun or by the wind, here the particles that are left will be of the salt. There are many salts that are dissolved in the seawater. Along with sodium chloride, there will be many salts like magnesium chloride and all. And after the evaporation of this seawater, there will be the remaining of mixture of salts. From that, sodium chloride is separated. Seawater contains many other dissolved salts. The sodium chloride is separated from other salts. Okay, and also solid deposits of rocks are found in different parts of the world. They are due to the drying up of the seas that were present in older times. The type of salt that is found in the form of big rocks, it is called as rock salt. In many areas, deposits of solid salts is available in many parts of the world, which was found to due to drying up of the seas that were present in olden times. After many years, what happens there? The drying of those seas will result in the formation of big rock structures. Those rock structure, that is the salts of those rocks, they are called as rock salt. It is usually brown in color because there is a presence of impurities in those rock salt. Okay, due to drying up of seas in olden times, such a salt is called as rock salt. So now we have understood about the availability of salt, that is in the form of seawater. We will extract sodium chloride from seawater by drying the seawater, and also along with the sodium chloride there will be mixture of many other salts. We should acquire only sodium chloride by separating it from other salts. And also rock salt is also available in many parts of the world, which is formed due to the evaporation of the seas in olden times. And the salt that is found in the form of rocks is called as rock salt, and it is brown in color due to the presence of impurities. Then let us see why this sodium chloride salt is very important and what is the necessary of studying this sodium chloride. Because we do have many commercial applications of common salt here. Let us see them. Common salt is an important raw material for various substances like sodium hydroxide, baking soda, washing soda, and bleaching powder. Yes, this sodium chloride salt forms the raw material for all these preparations, that is sodium hydroxide, baking soda, washing soda, bleaching powder. If the raw material is very economical, then it will be a very good reagent in the preparation of other products. We know that it is available in plenty of amounts, so it is a very good raw material in the production of all these materials, that is sodium hydroxide, baking soda, washing soda, and bleaching powder. This salt is used as preservative for making pickles. In your home you might have seen that your mother or grandmother will add more amount of salt into the pickles so that it will remain fresh for many months or even years. And also in storage of meat and fish we will use this sodium chloride salt. And as we all know that it is a major ingredient in cooking of food, and it is also used in manufacture of soaps. This is all about the uses of common salt. Then let us study that how this common salt is used in preparation of these products, that is sodium hydroxide, baking soda, washing soda, and bleaching powder. Okay, this is very important topic. You need to remember how do we prepare these substances from common salt. Let us first study sodium hydroxide. How is it prepared from sodium chloride? Okay. Sodium hydroxide is prepared from the solution of sodium chloride by passing electricity through the solution of sodium chloride in water. That is, the solution of sodium chloride in water is called as brine solution. Okay, you can see here it is brine, means solution of sodium chloride in water. What do you mean by brine? It is a solution of sodium chloride in water. Simply we have to add sodium chloride to the water, then the resulting mixture is called as brine solution. When electric current is passed through aqueous solution of sodium chloride in water, sodium hydroxide is formed. Sodium hydroxide is formed. See here, we have taken the solution of sodium chloride here, that is in water. Once you prepare this solution, there will be the formation of ions there. There will be the dissociation of sodium and chloride ions in water. And also we know that water has also H plus ion, OH minus ions. So in this mixture, we will be having Cl minus ions, Na plus ions, H plus ions, and also OH minus ions. It is due to the dissolution of this salt in water will result in the formation of these ions here. Once the electric current is passed through it, these two are electrodes for connecting the electricity through this solution. This is connected to the positive terminal of the battery, that is anode, and this is connected to the negative terminal of the battery. This will be anode and this will be cathode. We know that towards anode always anions are collected or anions are attracted here, and towards the cathode the cations are attracted here. Once these ions are formed in the solution, what happens here? These chlorine ions are moving towards the anode. So towards anode what happens? At anode what happens? These chlorine ions are attracted. Okay, these chlorine ions lose electrons. They will lose electrons to form chlorine gas. And at cath what happens? The H plus ions will be attracted. Although there is presence of sodium ions also, H plus ions are having more affinity to gain the electron here, so that they will be liberated as H2 gas. So at cathode the H plus ions, they will gain electrons to form H2 gas. Understood how this happens? Once the electric current is passed through the solution, the chloride anions are attracted towards the anions. There they lose electrons to form chlorine gas. so that chlorine gas is liberated at anode, and about cathode the hydrogen ions are attracted. They will gain electrons to form hydrogen gas, so that hydrogen gas is liberated at cathode. In this way the reaction takes place. Let us see the reaction. We have taken the solution of sodium chloride in water. This is what we were preparing. The sodium hydroxide will be prepared from sodium chloride in water by passing electricity through the solution of sodium chloride in water. Then what happens once the chlorine is liberated as chlorine and hydrogen cations liberated as hydrogen gas? What will be left in the solution? There will be sodium ions and hydroxide ions. These two combine to form sodium hydroxide. Understood how this sodium hydroxide is formed here? Once the chlorine and hydrogen ions are liberated as chlorine and hydrogen gas, what will be left in the solution? There will be sodium ions and hydroxide anions. They will combine to form sodium hydroxide. This is what we were preparing. Balance the equation. Yes, this is sodium hydroxide. Sodium hydroxide is also called as caustic soda. Why it is called as caustic soda? Because it is very corrosive in nature, so it is called as caustic soda. And whatever the products that are obtained in this reaction are very useful for commercial purpose. We will be studying what are the uses of this sodium hydroxide, chlorine, hydrogen in this class only. So let us recall what has happened in this reaction. We were preparing sodium hydroxide from sodium chloride solution by passing electricity through the brine. Once the electric current is passed through it, the ions whatever present in this tank, they are attracted towards their respective electrodes. Means cations are attracted towards cathode, anions are attracted towards anode, resulting in the formation of chlorine gas and hydrogen gas at anode and cathode respectively. Then there will be remaining ions, that is sodium and hydroxide ions. They will combine with each other to form sodium hydroxide. This is the equation that happens here. This is the equation. Sodium chloride in water will result in the formation of sodium hydroxide, chlorine and hydrogen. This is very important from the examination point of view. You should know the method how the sodium hydroxide is prepared from the brine solution, and also you should remember this equation also, and you should remember this diagram also. You should remember that caustic soda is also called as sodium hydroxide. This is another name of sodium hydroxide, and this process is also called as chlor-alkali process. This process is also called as chlor-alkali process. Can you guess why? Because chlorine and alkali, that is sodium hydroxide. We know that sodium hydroxide is alkali as it is soluble in water, because of which it is called as chlor-alkali process, due to formation of chlorine and due to formation of sodium hydroxide, that is alkali. Hope you have all understood about the preparation of sodium hydroxide from brine solution. So we will be moving to the next concept now. Yes, as I have already said that the products that were obtained from the chlor-alkali process have commercial importance. Let us see one by one. Chlorine, we have got the chlorine gas in this reaction. Where it is used, we have already know that this chlorine is used in the water treatment because it acts as germicides. It will kill the germs and other microorganisms. So it is used in the water treatment. Then it is also used in the cleaning of swimming pools. We know that swimming pools have chlorinated water. In order to make them clean and germ free, they are treated with chlorine. And chlorine is also used in the manufacture of some products like PVC, polyvinyl chloride, and it is used in the manufacture of pesticides and chlorofluorocarbons. This is a very very important use of chlorine here, and it is also used in bleaching the fabrics. The fabrics gets shinier after bleaching. This is due to the thing that they are getting treated with chlorine there. And what about hydrogen? Hydrogen is also a byproduct of chlor-alkali process here. This is used in fuels. In rocket fuel also we see hydrogen gas is used. Then preparation of margarine. It is a margarine means it is a butter substitute. Usually butter is prepared from animal milk like cow and buffalo, whereas this margarine is prepared from vegetable oils by treating with hydrogen. It is used as a butter substitute. Then hydrogen is used in the manufacture of ammonia for fertilizers. Ammonia is a very important for making fertilizers. For preparation of ammonia, hydrogen gas is used. Then manufacture of hydrochloric acid. Hydrochloric acid is a very important reagent in our laboratory. It is very important for laboratory also, and also in the industrial level it is a very good reagent. We will be seeing how the hydrochloric acid is very important here. It is used in cleaning steel or in cleaning many metals, in degreasing them. They are used in cleaning purpose. And also it is used in the preparation of ammonium chloride, NH4Cl. It is prepared from chlorine only. Then used in medicines and cosmetics. And there are many other use of hydrochloric acid in industries also. Then sodium hydroxide. What the main product that we have obtained in this reaction is sodium hydroxide. It is used in degreasing the metals. The metals which are covered by very thick grease or oily material inside them or on the surface is cleaned by applying or by pouring sodium hydroxide solution on it so that it will become clean. Then it is used in the preparation of soaps and detergents and also used in bleaching fabrics. They get shinier appearance after bleaching. Then used in manufacture of paper industry. When paper are prepared from wood pulp, it is bleached by using sodium hydroxide, because of which the paper that are present in books looks shinier. This is due to bleaching of wood pulp using sodium hydroxide. This is all about the uses of the byproducts that are obtained from chlor-alkali process. Okay. So we have got chlorine during the chlor-alkali process. This chlorine is used in the preparation of bleaching powder. The chemical formula of bleaching powder is CaOCl2. It is also called as calcium oxychloride. This is a chemical formula. You need to remember the chemical formula. Sometimes they will ask in your examination also. How it is prepared? It is prepared by the action of chlorine on slaked lime. When slaked lime, you have to take the dry slaked lime. Okay. It is prepared by the action of chlorine on dry slaked lime. We know that slaked lime has the formula CaOH twice. We will take the dry slaked lime and we make it to react with chlorine gas that we have obtained during chlor-alkali process. Then we get bleaching powder. This is bleaching powder. There are many uses of bleaching powder. As the name itself indicates, it is used in the bleaching of textiles, papers, and also it is used in the laundry for bleaching the washed clothes. Let us see their uses. Bleaching powder is used in the textile industry for bleaching the fabrics. The fabrics get shinier once they are bleached with the bleaching powder. And also in paper industry, they are bleached with the bleaching powder, that is calcium oxychloride. The wood pulp is treated with bleaching powder so that the paper that is formed has shinier appearance. Then it is used in laundry for bleaching washed clothes. It is also used at domestic level for bleaching the washed clothes here. Then also it is used as oxidizing agent here, and it is used in the disinfecting the drinking water. It also acts as germicide so that it is used in disinfecting the drinking water. These are all the uses of bleaching powder, and you should remember this equation. You should remember the chemical formula of this compound, and also you should remember this name. Then let us move to the next part. Another important compound that can be prepared from sodium chloride is baking soda. Almost all you might have heard this name, baking soda, and also in everyone's kitchens there is use of baking soda for cooking. Yes, it is a very important ingredient that we see in our daily life too. Then how is it prepared from sodium chloride? Let us see. The chemical name of baking soda is sodium bicarbonate. The formula is NaHCO3. It is called as sodium bicarbonate. How is it prepared? It is prepared from sodium chloride as a raw material. It is made to react with water, carbon dioxide and ammonia. We get ammonium chloride and sodium bicarbonate. This is ammonium chloride, and we know that this is sodium bicarbonate, that is baking soda. So we know that it is used for cooking purposes. To make the quick boiling of dals, rice, we will use baking soda, and also to make the crispier chaklis or pakoras, we will use baking soda. And also in bakeries we see that baking soda is a must added product. Why? Because it will make the cakes or bread very spongier and fluffy. How can the breads and cakes are made spongy? We can see when sodium bicarbonate is heated. When it is heated, there is a formation of sodium carbonate, water and carbon dioxide. Okay, when it is heated, there is a formation of carbon dioxide gas here. This gas is responsible for making the breads or cookies or cakes very spongy and fluffy. And there is also formation of, this is sodium carbonate. This is also one of the main important compound. We will come to it little later. Because of this formation of carbon dioxide, it will make the food items very fluffy. This is how we will make use of baking soda in our kitchen. And there are also many other uses of baking soda, like it is used in making baking powder. What is baking powder? It is mixture of sodium bicarbonate and any edible acid like citric acid or tartaric acid. Edible acid like citric or tartaric acid. How do we prepare the baking powder from baking soda? By mixing sodium bicarbonate and edible acid like citric or tartaric acid. Once this mixture is heated, what happens? H plus means it is any acid, whether it may be citric or tartaric acid. What happens there? There is a formation of carbon dioxide, water, and there is a formation of sodium salt of this acid. Sodium salt of acid. And this carbon dioxide that is released during the heating of baking powder, it will make the cakes or breads very spongier. And then where baking soda is used? It is used as an ingredient in antacids. We know that whenever there is excess acid in our stomach, it will be irritating and burning sensation in our stomach due to extra acid. In order to neutralize that extra acid, we have to neutralize it with the base. So this baking soda, that is sodium bicarbonate, has basic nature. It is a mild base, because of which it can neutralize the excess acid in our stomach. We know that when baking soda reacts with acid, there is a formation of carbon dioxide. In soda acid fire extinguishers, what happens? We make use of this reaction there. When there is formation of carbon dioxide in that instrument or in that cylinder, there is a formation of carbon dioxide which is used to extinguish the fire. This carbon dioxide will make as a blanket around the material that has caught fire, and it will prevent the oxidation, means it will prevent the supply of oxygen to those materials, and it will prevent the fire hazard. In this way it is used as soda acid fire extinguishers. The next important compound that is prepared from sodium chloride is washing soda. The chemical formula of washing soda is Na2CO3 10H2O. This 10H2O is called as water of crystallization. It is called as water of crystallization. Water of crystallization is the fixed number of water molecules that are present in the crystal structure of this salt per formula unit. For one molecule, that is for one formula unit of sodium carbonates, there are 10 water of crystallization molecules there. It is present in the crystal structure. So it may also be called as sodium carbonate decahydrate. Means as there are 10 molecules of water of crystallization, it is also called as sodium carbonate decahydrate. If there are 5 molecules, it is called as pentahydrate. If there are only 2 molecules of water of crystallization, that it may be called as dihydrate. If it has only half water molecule of crystallization, it may be called as hemihydrate. In this way, so washing soda is basically sodium carbonate decahydrate. In the previous Example only we have seen that this sodium carbonate was prepared from sodium bicarbonate by heating it. Okay, we have prepared by heating sodium carbonate. We have got sodium carbonate. This is sodium carbonate. From this, how do we prepare washing soda? By recrystallization from the solution. So overall, washing soda is obtained by heating baking soda and recrystallization of sodium carbonate gives washing soda. Once this sodium carbonate is obtained, what we will do is we will dissolve it in particular amount of water. Then we will extract the crystal. We will leave it for some time. Then there is a formation of crystals there, that is of sodium carbonate decahydrate. After recrystallization, that is we will leave it for some time, we will get sodium carbonate decahydrate. Recrystallization of sodium carbonate gives washing soda, that is Na2CO3 plus 10H2O. During recrystallization, what happens? The water molecules will be involved in the formation of crystal structure. So they are chemically bonded in the crystal structure, resulting in the formation of water of crystallization. This is washing soda. We know that washing soda has got very important role. It is very important product for washing purposes. It is used in the glass, soap and paper industries also, and it is used in the manufacture of sodium compounds. You can see here it is used in glass, soap and paper industry. It is used as a cleansing agent for domestic purposes also, that we use in our daily life. Then it is used in removing permanent hardness of water. In order to make the hard water soft, we will add washing soda to it. This is all about importance of washing soda and how do we prepare washing soda from sodium bicarbonate. So in the previous example of washing soda, we have seen the water of crystallization. In sodium carbonate decahydrate, there are 10 water of crystallization. We have already learnt that water of crystallization is the fixed number of water molecules present per formula unit of the salt in the crystal structure. So what is water of crystallization? It is the fixed number of water molecules present in one formula unit of the salt. So for one formula unit of sodium carbonate, there are 10 water of crystallization. These water of crystallization, these molecules are present in the crystal structure that are chemically bonded to the salt. Then there are several examples where the salts have water of crystallization. For example, when you see copper sulfate, the crystals of copper sulfate have water of crystallization, that is it is pentahydrate, because of which it is blue in color. Actually, the crystals of copper sulfate are blue in color. What happens when you heat these copper sulfate crystals? The water molecules are removed from the crystal structure, resulting in the formation of copper sulfate anhydride. Okay, when copper sulfate crystals are heated, the water molecules are removed to form, this is copper sulfate, that is anhydrous copper sulfate. Anhydrous copper sulfate. Here, after heating, was what has happened? The water of crystallization, they are removed to form anhydrous copper sulfate. Initially, it was blue in color. It is bright blue in color. After the removal of this water of crystallization, it turns somewhat white anhydrous copper sulfate. Again, if you add water to it, the water is absorbed in the crystal structure to form again blue color copper sulfate pentahydrate. This is about the water of crystallization. And if there are 10 water of crystallization, we call it as decahydrate. If there are 5 water of crystallization, we call it as pentahydrate. If there are 2 water of crystallization, we call it as dihydrate. There is another one example of the salt water of crystallization, that is gypsum. Gypsum is a salt with formula calcium sulfate. Actually, it is calcium sulfate. It has to water of crystallization. The chemical formula of gypsum is calcium sulfate, CaSO4 to H2O. This is important. You have to remember the chemical formula of this compound, that is gypsum, because it has got its own commercial importance. What do we do with the help of gypsum? It is used in the preparation of plaster of Paris. In nowadays we are using plaster of Paris in large amounts. It has got its own commercial importance. Let us see. So let's see how plaster of Paris is prepared from gypsum. It is a very important compound. The chemical formula of plaster of Paris is CaSO4 of H2O, and the chemical name of this compound is calcium sulfate hemihydrate. Calcium sulfate hemihydrate. Why it is called so? Calcium sulfate, as there is hot water molecule of crystallization, it is called as hemihydrate. You may wonder why it is written as half. This means that among two molecules of calcium sulfate, there is one water of crystallization. There is one molecule of water of crystallization between two formula unit of calcium sulfate. So we will represent this formula as CaSO4 of H2O. Okay. Then how do we prepare this from gypsum? We know that gypsum has the formula CaSO4 to H2O. When it is heated at 373 Kelvin, we get plaster of Paris. So at this temperature, this calcium sulfate dihydrate will lose the water of molecules to form calcium sulfate hemihydrate, that is plaster of Paris. This is a very important compound, as we see that when bones get fractured or there is some cracks in bones of legs or hands, doctors usually wrap the hands or legs with the plaster, that is made up of plaster of Paris, so that the bones will be fixed in the right position. And also they are used in making toys, beautiful toys, and the plaster of Paris is used in making the surfaces smooth. Nowadays modern homes are built in such a way that the ceilings look very beautiful. This is because the surfaces are made smooth and attractive by using plaster of Paris. And also many statues are also made with the help of plaster of Paris. As we have already said that it is used as plaster for supporting fractured bone in right position. Okay, this is all about gypsum and plaster of Paris. It is very important from the examination point of view. You must remember the names of all these compounds. It is calcium sulfate dihydrate, commonly known as gypsum. You should remember both the chemical name and common name. Okay. The chemical name of this compound is calcium sulfate hemihydrate, and the common name is plaster of Paris. And you should remember the commercial application of these compounds. With this, we will end the chapter. Almost all the concepts have been cleared till now. Now let us discuss some of the questions. Let us see some of the questions from your in-text. Name the substance which on treatment with chlorine yields bleaching powder. In today's session itself, we have studied that the dry slaked lime upon treating with chlorine yields bleaching powder. So our answer will be, we have to name the substance. It is dry slaked lime. Then write the reaction between plaster of Paris and water. We know that the chemical formula of plaster of Paris is this. Once it reacts with water, gypsum is formed. There is a formation of gypsum, calcium sulfate dihydrate. This is the reaction of plaster of Paris and water. This is gypsum and this is plaster of Paris. And the next question, write the chemical formula for bleaching powder. We know that chemical formula is CaOCl. This is all about the chapter acids, bases and salts. In the next session, we are going to solve some of the very important questions including exemplar and PYQs in the next session. Okay, all the best. Hello everyone. In the previous videos, we have covered the chapter chemical reactions and equations, acid, bases and salts. And today we are going to solve some of the important questions on acids, bases and salts. Okay, without delay, let's get started. Yes. First, let us solve the MCQs, that is 1 mark questions. Let me read the first question. When carbon dioxide gas is passed through the lime water, it turns milky. The milkiness is due to the formation of. We know that when carbon dioxide gas is passed through the lime water, the reaction that takes place is this is lime water. When carbon dioxide gas is passed through the there is a formation of calcium carbonate. This calcium carbonate is white precipitate. It is insoluble in water because of which the lime water will turn milky. So the correct answer is calcium carbonate. Due to the formation of calcium carbonate only, the lime water has turned milky. Then our next question. It is a very easy question as you all know. Antacids contain. Antacids are usually taken when there is excess acid in our stomach, that is when we are suffering from acidity. So antacids contain weak base. In order to neutralize the excess acid in our stomach, the antacids are taken. They contain weak base. So our answer is B, that is weak base. Then the next question, which of the following is acidic in nature? Gastric juice, sodium hydroxide solution, lime water, milk of magnesia. We know that gastric juice contains hydrochloric acid, so it is acidic in nature. Then what about sodium hydroxide solution? We all know that it is a strong base. So this is wrong option. Then lime water, it is a calcium hydroxide. It is also base. Then milk of magnesia is nothing but magnesium hydroxide. This is also a base. So our correct option is gastric juice, which contains hydrochloric acid. Okay. The next question is, to protect tooth decay, we are advised to brush our teeth regularly. The nature of the toothpaste commonly used is acidic, basic, neutral or corrosive. We know that tooth decay is caused when the pH of the mouth decreases. When the pH of the mouth is less than 5.5 it causes tooth decay. So what we have to do? We have to normalize that is we have to neutralize the acid in our mouth. We should maintain the acidity in our mouth. So the toothpaste that we have to use must contain basic substance. That is, it should contain mild base. So our answer will be basic. Okay. Then the next question is, if a few drops of concentrated acid accidentally spills over the hand of a student, what should be done? Our options are wash the hands with saline solution, wash the hands immediately with plenty of water and apply a paste of sodium hydrogen carbonate. After washing the hands with plenty of water, apply sodium hydroxide solution on the hands. Then the next option is neutralize the acid with strong alkali. What happens if concentrated acid accidentally spills over our hand? First, we need to wash our hands immediately with plenty of water. Then what we need to do is we need to apply a mild base on it. Otherwise, if you apply a corrosive basis or very strong basis like sodium hydroxide, again our skin will be affected. So what we need to do? We should apply the mild base on it to neutralize the excess acid there. So, our correct option will be wash the hands immediately with plenty of water and apply a paste of sodium hydrogen carbonate. Why? Because sodium hydrogen carbonate is a basic salt. So, after applying this, we will get relief. We should never apply sodium hydroxide solution on our hands as it is highly corrosive. And also, we should not neutralize the acid with strong alkali as they are corrosive in nature. It will affect our skin. Okay. While solving the questions like this, we have to think practically. We should never think that we should neutralize the acid that has spilled on our hand. No. We should think it practically. As bases are corrosive in nature, we cannot apply directly the corrosive bases, that is very strong bases like sodium hydroxide or potassium hydroxide on our hand. We have to apply mild bases. Even in case like when we are suffering from acidity, we will be taking mild bases like magnesium hydroxide that is contained in antacids. You should remember this. Okay. Then the next question is, 10 ml of solution of sodium hydroxide is found to be completely neutralized by 8 ml of given solution of HCl. If we take 20 ml of the same solution of sodium hydroxide, the amount of HCl solution, the same solution as before, required to neutralize it will be. What has happened here? 10 ml of NaOH is neutralized. It is completely neutralized by 8 ml of given solution of HCl. Okay. So 10 ml is neutralized by 8 ml of given solution of HCl. Then our question is, if we take 20 ml of the same solution of sodium hydroxide, the amount of HCl solution that is required will be, so if we want to neutralize 20 ml of the same solution of NaOH, I have to take here NaOH. Okay, if 20 ml of the same solution of sodium hydroxide is taken, means we have not changed its concentration. The same solution that is taken in another volume. Okay, 20 ml of NaOH is taken, then what amount of HCl will be needed? So it is clear that 10 ml needs 8 ml, means if double the amount is taken, then double the amount of hydrochloric acid is also needed. That is 8 into 2 is equal to 60 ml. If I have doubled this amount, that is 10 ml of NaOH first we had taken. Again now we are taking 20 ml of NaOH, means initially 8 ml of HCl was needed. Then in the second case we should require 16 ml of HCl to neutralize the base completely. Okay. So our answer will be D, 16 ml. Next, the chemical formula of plaster of Paris is, we know that plaster of Paris is calcium sulfate hemihydrate, that is CaSO4 hemihydrate of H2O. So our answer is this one. Option B is the correct answer. So our next question is, when a small amount of acid is added to water, the phenomenon which occur are dilution, neutralization, formation of hydronium ions, salt formation. We know that when acid is added to water, what happens there? There is a formation of ions. The acid will produce H plus ions, which will combine with water to form hydronium ions. Yes, if HCl is dissolved in water, what happens there? There is a formation of hydronium ions and chloride ions there in case of hydrochloric acid. And also again one thing happens. What is that? When we are mixing water in acid, that is acid in water, the process is called as dilution. Yes. So here we can say that the two phenomenon occur. One is dilution and another one is formation of hydronium ions. Yes. First what happens? It will form H plus and Cl minus ions. As H plus ions are unstable, they will combine with H2O. So they will combine with H2O to form H3O plus. Okay, there is a formation of hydronium ions there. So both dilution and formation of hydronium ions takes place there. Then what about option B and D? Neutralization? No. When acid is dissolved in water, neutralization will not take place. Neutralization reaction will take place in presence of base. When acid and base combine together, there is a neutralization reaction. Then what about salt formation? Yes, even salt formation is also occur in the presence of base only. Acid and base combine with each other, that is they react with each other to form salt and water. So these two are wrong. So our correct option will be A and C. Which is the correct option? That is A and C. Okay. Then which of the following salts do not contain water of crystallization? First, we should know the molecular formula of each compound in order to identify which of these is not containing water of crystallization. What is blue vitriol? It is copper sulfate, pentahydrate, CuSO4, 5H2O. It is a formula for blue vitriol. Then what about baking soda? The formula is NaHCO3, sodium bicarbonate. Then what about washing soda? It is sodium carbonate decahydrate, that is 10H2O. What about gypsum? The formula is calcium sulfate, that is CaSO4 to H2O. So the question here is, which of the following salts do not contain water of crystallization? You can see here blue vitriol, washing soda and gypsum all have water of crystallization. So which is that salt that is not having water of crystallization? That is baking soda. So our correct answer will be B, that is baking soda. Next, match the chemical substances given in column A with their appropriate application given in column B. Yes, this is an important question. You should always remember the applications of the salts or the compounds that have given in your syllabus, like baking soda, bleaching powder, washing soda, sodium chloride, etc. So let us see here. Bleaching powder, among these, which is the use of bleaching powder? What is the application of bleaching powder here? It is used in the decolorization. Bleaching powder, it is used in decolorization. Then what about baking soda? You can see here, it is used as an antacid, as it is having the basic character. It is a mild basic salt. Yes. So baking soda is used in antacids. Then what about washing soda? It is used in the preparation of glass. Washing soda. It is used in preparation of glass. Then sodium chloride. As we all know that sodium chloride is used in the preparation of sodium hydroxide, where we will get the byproducts, that is hydrogen and chlorine also. So sodium chloride is also used in the preparation of H2 and Cl2, that is hydrogen and chlorine gas. So which will be our correct option? A3, A3, B4, C1 and D, sodium chloride 2. So this will be our correct option. Okay, let us move to the next question. You are given three unknown solutions with pH values 6, 8 and 9.5 respectively. Which solution contains the maximum OH minus ions, that is hydroxide ions? Let us take sample 1, sample 2, sample. All these solutions pH values are given. Sample 1 has pH 6 and sample 2 8 and sample 3 9.5. So our question is, which solution is having the maximum OH minus ions? As we all know that as pH value increases from 7 to 14, the concentration of OH minus ions also increases. This means more the pH value, more will be hydroxide ion concentration. So among these, which is having more pH value? That is sample 3 is having more pH value. So more the pH value, more will be the hydroxide ion concentration. So our answer will be B, that is sample 3. Next, the acid produced in our stomach during digestion of food is hydrochloric acid, oxalic acid, lactic acid, acetic acid. It is 100% sure that our stomach produces hydrochloric acid in the gastric juice. Okay. Next, which of the following are electrolytes? Dilute HCl, sugar solution, alcohol in water, lime water. We know that electrolytes are those compounds which produces ions in the solution and conducts electricity. So we know that dilute HCl also forms ions and conduct electricity. Sugar solution, it will not form ions. Alcohol in water, it will not form ions. Then lime water, it will form ions. Lime water means CaOH twice, that is calcium hydroxide. It will form ions in water. So our correct option is 1 and 4. 1 and 4. The correct option is B. Next question. In the neutralization reaction, when excess of acid is added to an alkali, salt and water are produced. What is the nature of the solution after the reaction occurs? First, understand the question properly. In the neutralization reaction, when excess of acid is added to an alkali, okay, when acid and alkali they are mixed, it forms neutralization, means they undergo neutralization reaction. Okay, then our question is, excess of acid is added. This is added in excess. If they are added in the same amount, means the amount that is required for neutralization reaction, then it would be neutral in nature. But here excess of acid is added to an alkali. What happens? The neutralization reaction that takes place will be resulting in the formation of salt and water, but the solution will be acidic in nature as we are adding excess of acid there. So the resulting solution will be acidic. Okay. Next, it is AR question, that is assertion reason question. Assertion is ammonia is acidic in nature. Reason, ammonia dissolves in water and forms hydroxide ions. You can easily see here assertion is wrong. Ammonia is not acidic in nature. It is basic in nature. When ammonia is dissolved in water, it forms hydroxide ions. So the reason ammonia dissolves in water and forms hydroxide ions is correct. So let us see the option now. Both assertion and reason are correct, and reason is the correct explanation of A. No, assertion is wrong. So option A is also wrong. Both assertion and reason are correct. No, assertion A is wrong. So this option will also be wrong. Assertion is true, but reason is false. It is clear that assertion is not true. So this option will also be wrong. Then assertion is false, but reason is true. Yes, it is true that this assertion is wrong, but the reason that ammonia dissolves in water and forms hydroxide ions is, so option D will be correct. When ammonia is dissolved in water, what happens? Ammonium hydroxide is formed. It will produce hydroxide ions. Okay. Let us read the next question. It is a case study question. Read the passage carefully and answer the following questions. A compound C of sodium forms a white powder. It is a constituent of baking powder and is used in some antacid. When heated, it gives a compound D which is anhydrous and absorbs water to become hydrated salts. When this salt is kept in the open air, it loses water molecules in a process called efflorescence. When dissolved in water, it forms a strong base and a weak acid. Here. First of all, you have to read the question properly. You have to understand it before going to attempt the questions. Okay. Let me solve step by step. A compound C of sodium forms a white powder. What is C here? C is compound of sodium. Again, what hint they have given is it is a constituent of baking powder. What is C? It is constituent of baking powder. So, by seeing this only we can understand the constituent of baking powder is sodium hydrogen carbonate, that is sodium bicarbonate, and it is also white in color they have given, and also it is mentioned that it is used in some antacids. Then it is 100% sure that it is used in antacids, so the compound C will be sodium bicarbonate. Then which of the following is compound C? The question is we have to find out the C. Then from this only it is clear that the compound C is sodium hydrogen carbonate or sodium bicarbonate. Then the next question of this passage is which of the following is compound D? They have given that when compound C is heated, it gives a compound D, that is anhydrous, and it absorbs water to become a hydrated salt. Okay. When this compound C is heated, what they have given, it forms a compound D, that is anhydrous. We know that when sodium bicarbonate is heated, we get sodium carbonate, water and carbon dioxide. Okay. And they have also given it is anhydrous. Yes, it is anhydrous. And when it absorbs the water molecules in the crystal structure, it forms sodium carbonate decahydrate, that is washing soda. So the compound D will be sodium carbonate only. Okay, you should not write sodium carbonate decahydrate. Okay, it is anhydrous. After heating sodium bicarbonate, we will get sodium carbonate. So the compound D will be sodium carbonate, that is Na2CO3. Then again they have given that when this salt is kept in the open air, it loses water molecules in a process called efflorescence. When it is dissolved in water, it forms a strong and a weak acid F. Okay, and they have given that when this sodium carbonate, that is D, it is dissolved in water, it forms a strong acid and a weak base. So when sodium carbonate is dissolved in water, it forms strong base sodium hydroxide and weak acid, that is carbonic acid. This sodium carbonate is formed by the combination, that is neutralization of strong base sodium hydroxide and weak acid carbonic acid. So what is the nature of the solution formed by dissolving D in water? D here is sodium carbonate. When this is dissolved in water, the resulting solution will be alkaline, as this sodium hydroxide is strong. It is a strong base. So the resulting solution will be alkaline. So our answer will be D. So have you understand? How is it? The nature of the solution, D is the nature of the solution formed by dissolving D in water is alkaline because it is having the strong base here, because of which the solution will be alkaline in nature. And also they have given it forms a strong base and a weak acid F. Yes, when sodium carbonate is dissolved in water, it forms strong base, that is sodium hydroxide, and weak acid carbonic acid. Okay. So a weak acid is F. In the next question, they have asked which among the following is compound F. Compound F is weak acid, that is carbonic acid. This is the correct answer. Then sodium carbonate is a basic compound because it is a salt of. How sodium carbonate is formed? It is formed by the neutralization of sodium hydroxide and carbonic acid. It forms, yes. This sodium carbonate is formed by strong base and weak acid. Carbonic acid is weak acid as it partially ionizes in water to form H plus ions. So the resulting salt will be basic in nature. The answer is it is a salt of strong base and weak acid. That is the strong base and weak acid. Next, illustrate an activity to investigate whether all compounds containing hydrogen are. We have also seen in the NCERT activity itself that all the compounds that are having hydrogen are not acidic in nature. But we have to illustrate an example or activity here also. What can we do? We should take two beakers. In one beaker, we can take any acid like hydrochloric acid or sulfuric acid. In another beaker, we have to take either alcohol or glucose solution. Then we have to make the circuit by connecting the terminals to the battery and connecting the bulb in those two separate beakers. The circuit in which the current is flowing will cause to glow the bulb. In the circuit where it is not complete and electric current is not passing, there the bulb will not glow. Let us write it. Okay. Take two beakers separately. In them take solutions of HCl, that is hydrochloric acid, and glucose. Then in each solution take two nails fixed on a rubber cork and connect the nails to the terminals of the battery and bulb. Okay, we have made the electrical connections using the two solutions separately there. When the electric current is passed, the bulb in the circuit containing HCl glows, whereas the bulb in the circuit containing glucose will not glow. This shows that hydrochloric acid has produced H plus and Cl minus ions and conducts electricity, whereas the glucose solution has not produced ions. So our answer will be all the compounds containing hydrogen are not acidic. Only those solutions which produce H plus ions on dissolving it in water will be acidic in nature. Okay. So all compounds containing hydrogen are not acidic. We know that even glucose has hydrogen atoms. It has also hydrogen atoms, but these hydrogen atoms are not ionized. Means this glucose solution will not produce ions, because of which it will not behave as acid. It is not having acidic character. Okay. So how we have checked this? We have to take the two beakers separately and we have to take the solutions of HCl and glucose. Why we have taken glucose? We want to show that even those containing hydrogen atoms may not be acids there. So we have taken glucose, and then in each solution take two nails fixed on a rubber cork and connect the nails to the terminals of battery and bulb. Okay, so that circuit is complete. When the electric current is passed, the bulb in the circuit containing HCl glows because there the solution is conducting electricity because of formation of ions, whereas the bulb in the circuit containing glucose will not glow because glucose has not formed any ions. So the circuit is not complete there and the bulb will not glow. This shows that HCl has produced H plus and Cl minus ions and conducts electricity, whereas the glucose solution has not produced ions, so all compounds containing hydrogen are not acidic. Only those compounds which forms H plus ions are acidic. Okay. Understood? Then the next question is, a compound P forms the enamel of the teeth. It is the hardest substance of the body. It does not dissolve in water but gets corroded when the pH is lowered below 5.5. We have to identify the compound P. Okay, we know that our tooth enamel is made up of the hardest substance, that is calcium phosphate. The answer is calcium phosphate. Then how does it undergo damage due to eating chocolate and sweets? What should we do to prevent the tooth decay? So even though it is the hardest substance, how does it get damaged? Yes, when sweets and chocolates are eaten, the particles are stuck in the mouth. Yes, the particles are stuck in the mouth. Those particles are degraded, means they undergo degradation by the bacteria present in the mouth. By the bacteria present in the mouth. Those bacteria, while degradation of the particles, release acid in the mouth. What they do? They release acid in the mouth. This acid corrodes the tooth enamel. So how it has happened? When the particles of the food that we eat or the chocolates, the sweets that we eat are stuck in the mouth, there are bacteria present in the mouth. Those bacteria will act on the particles and cause them the degradation by releasing acids in the mouth. When the acids are released in the mouth, the pH of the mouth will decreases, because of which that acid will corrodes the tooth enamel, causing the tooth decay. Then we have to answer that what should we do to prevent the tooth decay. Here we have answered the compound P is calcium phosphate. Then we have also answered that how does it undergo damage due to eating chocolates and sweet. Now there is still one more question. What should we do to prevent the tooth decay? To prevent tooth decay, we have to wash the mouth after every meal. We have to clean the mouth. And also, we can use the toothpaste that are basic in nature, so that it will neutralize the acid that is released in our mouth. To prevent tooth decay, what we have to do? Wash the mouth properly after every meal and use toothpaste that has mild base. Okay, so that it will neutralize the acid of the mouth. Nowadays, mouthwash is also given by the dentist. What it contains? That mouthwash also contains the mild bases, so that it will neutralize the excess acid in the mouth. When the when the acid character in the mouth increases and it goes, that is pH, when it goes below 5.5, the tooth decay is caused. Okay, this is how we can prevent the tooth decay. Next, sodium hydrogen carbonate is a basic salt. Justify this statement and how is it converted into washing soda. How sodium hydrogen carbonate is formed? It is formed by the neutralization reaction of sodium hydroxide and carbonic acid. So it is formed by the strong base and weak acid. Yes, this is formed by the neutralization of strong base and weak acid, because of which this sodium hydrogen carbonate is a weak, that is basic salt. It is, we know that when the salt is formed between the strong base and weak acid, it will be basic in nature. It is formed by strong base and weak acid. If the salt is formed between the strong acid and strong base, then the salt will be neutral in nature. If it is formed by the strong acid and weak base, then the resulting salt will be acidic in nature. Okay. And they have also given how is it converted into washing soda. It is prepared by heating sodium hydrogen carbonate. When sodium hydrogen carbonate is heated, sodium carbonate is formed. When it is heated, it forms sodium carbonate. So when sodium bicarbonate is heated, sodium carbonate is formed. What is the washing soda? It is obtained by recrystallization of sodium carbonate. Okay. recrystallization of sodium carbonate gives washing soda. What is recrystallization? When this sodium carbonate is dissolved in water and it is left for some time, what happens? There is a formation of crystals, and also the water molecules are absorbed in this crystal structure to form this washing soda. This is called as water of crystallization. It is a fixed number of water molecules present per formula unit of the salt. Okay, these molecules are present in the crystal structure. Do not get confused. Baking soda is different and washing soda is different. It is washing soda. You should remember the molecular formula, and this is sodium carbonate. You should remember the names and also chemical formula. Overall, how we have got washing soda from baking soda? That is, it is baking soda. When it is heated, we get anhydrous sodium carbonate. It has not any water of crystallization. And when it is recrystallized from the solution, we will separate the crystal of this salt, that is washing soda. So finally, the recrystallization of sodium carbonate gives washing soda. This is how you have to write the preparation. You have to read the whole question properly and then answer. The first question is sodium hydrogen carbonate is a basic salt. Justify this statement. We have to justify how it is formed by the neutralization reaction of strong base and weak acid. So it is a basic salt. Then we have to write how is it converted into washing soda. We will form washing soda by heating sodium bicarbonate and then recrystallization it from the solution gives washing soda. Okay. Then the next question is, what is the action of litmus on dry litmus paper? So what happens here? When the litmus paper is held, the next question is, what is the action of litmus on dry HCl and solution of ammonia gas in water? Let us answer the first question. The action of litmus on dry HCl will be, there is no change in the color as there is no formation of ions there. The litmus will show color change only when there is presence of H plus ions. So when the litmus paper is held near dry HCl, there will be no change in the color. So you have to write no change in color of litmus because H plus ions are not produced. Then what is the action of litmus on solution of ammonia gas in water? We know that solution of ammonia gas in water gives hydroxide ions. So they will give OH minus ions. So the red litmus will change to blue color. The second answer will be red litmus changes to, as it produces hydroxide ions which are basic in nature, changes to. So the litmus will changes from red to blue color. Okay, have you understood this answer? Then let us move to the next question. So the question is, a compound X which is prepared from gypsum has the property of hardening when mixed with proper quantity of water. Identify X and write its chemical formula. They have given that X, it is prepared from gypsum, and also they have given that it has the property of hardening when mixed with proper quantity of water. Then it is sure that it is plaster of Paris. X will be plaster of Paris because it is prepared by heating the gypsum at 373 Kelvin. And we have to write the chemical formula. What is the chemical formula of plaster of Paris? It is CaSO4 of H2O. Okay. So let us write. So compound X is plaster of Paris as it is prepared from gypsum. Chemical formula, it is CaSO4 of H2O. It is also called as calcium sulfate hemihydrate as it has half water molecule of crystallization. Means in between two formula units of calcium sulfate, there is one water molecule of crystallization. How it is formed? It is formed by heating gypsum at 373 Kelvin. Then you can also write the reaction, how it has happened. When gypsum is heated at 373 Kelvin, we will get plaster of Paris. This is plaster of Paris. Okay. Then the next question is, this is first question. State the difference in chemical composition between baking soda and baking powder. We know that baking soda is nothing but sodium hydrogen carbonate. It is sodium hydrogen carbonate. Whereas baking powder means it is a mixture of sodium hydrogen carbonate and edible acid like tartaric acid. This is baking powder and this is baking soda. Okay, let's read the next question. What happens when nitric acid is added to eggshell? We know that eggshell is made up of calcium carbonate. Okay, when the nitric acid is added to calcium carbonate, what is the reaction that happens? Let us write calcium carbonate plus HNO3, that is nitric acid. It forms calcium nitrate plus water and carbon dioxide. So our answer will be eggshell contains calcium carbonate. When nitric acid is added to eggshell, carbon dioxide is liberated and calcium nitrate is formed. And you have to write the reaction then. Okay, this is calcium carbonate. When it reacts with nitric acid, calcium nitrate, water and carbon dioxide are formed. Okay, then the next question is, what are strong and weak acids? In the following list of acids, separate strong acids and weak acids. Okay, we know that the strong acids ionize completely in aqueous solution. They ionize completely in aqueous solution, forming hydronium ions. Whereas weak acids ionize partially to form hydronium ions. Means in case of weak acids, what happens? All the molecules are not ionized. Only some molecules are ionized to form hydronium ions. So the aqueous solution of same molar concentration of weak acid has very less number of hydronium ions than that of strong acid. Suppose if I have taken the same molar concentration of the two acids, that is weak acid and strong acid. In strong acids, what happens? All the molecules are ionized and form hydronium ions. Whereas in case of weak acid, what happens? Only part of the molecules, some of the molecules are ionized to form hydronium ions, because of which the same molar concentration of, in both the cases, the amount of hydronium ions will be more in number in case of strong acids. Okay, this is the main difference between strong and weak acids. And among these, we have to separate the strong and weak acids. Okay, let us write strong acids here. Among these, the strong acids are hydrochloric acid, nitric acid is strong acid, sulfuric acid is also strong acid. Okay, hydrochloric acid, nitric acid and sulfuric acid. The other three acids are weak acids, as they do not completely ionize in water. Weak acids: citric acid, formic acid and acetic acid. Yes. So understood? These acids are mineral acids which are strong. So they will completely ionize in water to form the hydronium ions. Whereas these are organic acids which are weak when compared to strong acids. Okay. Next. Identify the correct representation of reaction occurring during chlor-alkali process. These are all reactions representing the chlor-alkali process, but we have to identify the correct representation of the reaction. See here, in chlor-alkali process, we will take the aqueous solution of sodium chloride, that is brine. We will take the aqueous solution of sodium chloride. And then what we get sodium hydroxide, chlorine gas and hydrogen gas. So let us see which is the correct option here. Here they have given liquid L, but sodium chloride is aqueous solution. What we have taken is brine, that is aqueous solution of sodium chloride. This will be wrong. Then see here this is also not the correct representation of water. We will write L for it. So this is also wrong. Then see the C option, sodium chloride aqueous. Yes, it is correct. H2OL, it is correct. NaOH, that is aqueous solution. Yes. Here chlorine and hydrogen are representing the aqueous solution, but they are in the form of gas. So this option is also wrong. See the next option here, sodium chloride aqueous, that is correct. Water, liquid, sodium hydroxide is aqueous solution. We are getting chlorine and hydrogen gas. So the correct option will be D. So you have to remember the physical states properly when it comes to the important reaction, as This reaction is very important. The chlor-alkali process is very important from the examination point of view. You have to remember the process that is involved in the reaction, and also you should remember the equation, that is balanced chemical equation. Okay, next. Write a balanced equation to show the reaction that occurs when a piece of aluminum is dipped in a dilute solution of sulfuric acid and sodium hydroxide. So can you remember, this is a reaction between metal and acid. What we were going to get when metal and acid were reacted? We get salt and hydrogen gas. So let us take this given example, that is aluminum reacts with sulfuric acid. Okay, let us try to write the reaction here. Aluminium reacts with sulfuric acid, so it forms the salt aluminium sulfate. Okay, this is aluminium sulfate. Then what is the formation? Hydrogen gas is liberated. Okay, this is the equation. Now we have to balance. There are 3 sulfurs here. We have to put here 3. Again, there are 3 twos are 6 hydrogens here. Here also we should get 6 hydrogens. Then aluminium, there are 2 aluminium atoms here. We have to get 2 aluminium here. Now it is a balanced equation. So what happens when aluminium reacts with sulfuric acid? We get aluminium sulfate. You should write the reaction along with the names. Aluminium sulfate, and this is hydrogen, as we all know. So metals react with acids to form salt and hydrogen. So you all know how to write the chemical formula that you have studied in class 9 also. Let me recall it. AlSO4. Okay, aluminium sulfate. The valency of aluminium is 3. Valency of sulfate is 2. So cross multiply. I will get Al2SO4 thrice. Okay, you have to remember the method to write the chemical formula. Then again the question is asked that reaction of this aluminium with sodium hydroxide. How do metals react with bases? This is about the reaction of metal with base. We know that not all the metals will react with base. You should remember only aluminium and zinc will react with the strong base like sodium hydroxide to form salt and hydrogen gas. So aluminium reacts with sodium hydroxide in the presence of water to form sodium aluminate. Okay, we have to balance the equation. So aluminium will also be 2. Then what about hydrogen? Here there are 2 plus 2 to the 4, 6 hydrogens. So I should get here 6 hydrogens. Okay, this is balanced equation now. It is sodium aluminate. Remember that aluminium reacts with sodium hydroxide in the presence of water to form sodium aluminate and hydrogen. You have to remember the name and chemical formula. Okay, next. Write the color of the solution formed when copper oxide is treated with hydrochloric acid. Give reason for this observation. So, we have to solve this. When copper oxide is made to react with hydrochloric acid, what happens there? There is a formation of salt, that is copper chloride and water. They have asked that write the color of the solution formed when copper oxide is treated with hydrochloric acid. We know that when copper oxide reacts with hydrochloric acid, it forms copper chloride. And the color of the solution is, we know that it is blue-green in color. Copper chloride is blue-green in color. This is a reaction of metal oxides with acid to form salt and water. That is, metal oxide, they behave as bases here. They are basic in nature. Okay. Why this happens? The color of the copper oxide gets changed. Why? Because copper oxide reacts with hydrochloric acid to form copper chloride and water. Because of this, the color of the solution becomes blue-green. Copper oxide is actually black in color. Once it reacts with hydrochloric acid, it forms blue-green solution of copper chloride. Okay. Next, the question is list the important products of chlor-alkali process. Write on important use of each. Okay, we know that in chlor-alkali process, the product formed are, we get sodium hydroxide, we get chlorine gas, and we get hydrogen gas. And here we have to mention the important use of each. We know that sodium hydroxide is used in manufacture of soaps and detergents. Soaps and detergents. You can write only one use of each as they have asked one, detergents. No problem even if you write one or more. What is the use of chlorine gas? It is used in cleaning of the swimming pools. Yes, cleaning of, as it is a germicide, or it is, you can also write, used in water treatment. Then what is the use of hydrogen gas? There are many uses, like it is used in the rocket fuel, and the one more important is it is used in the manufacture of ammonia by Haber's process. Okay, it is used in the manufacture of ammonia. Okay, these are the products of chloralkali process, and these are the one use of each product here. Okay, so we should always remember the commercial benefits of these products, like chlorine, hydrogen, sodium hydroxide, and the other products that are obtained from sodium chloride, like baking soda, washing soda, etc. Then the next question is, how do metal carbonates and metal hydrogen carbonates react with acids? Taking magnesium as metal, write a balanced chemical equations in both the cases. State the method to test the gas evolved in each in the reactions. We know that when metal carbonates or metal hydrogen carbonates, they react with acids, what they form? They form salt, carbon dioxide and water. Okay, so here we have to write the equation by using magnesium as metal. We have to write the balanced chemical equation here. Let us write the reaction. Magnesium carbonate, MgCO3, reacts with hydrochloric acid. It is a acid to form salt, magnesium chloride, and there is a formation of carbon dioxide and water here. This is a metal carbonate, this is acid. When the metal carbonates reacts with acid, they form metal salt and carbon dioxide and water. Okay, we should also write the magnesium hydrogen carbonate, its reaction with hydrochloric acid, as they have asked the both equations. Okay, magnesium hydrogen carbonate, the formula is MgHCO3 twice. Here also salt MgCl2 is formed, carbon dioxide gas is released, and also there is formation of water. Okay, sorry, here we have written gas. Now balance the equation. There are two carbon atoms here. Here also we should get 2. What about oxygen? Here there are 6 oxygen atoms plus 4. Here also we have to get whole 6 oxygen atoms. Now the equation is balanced. Okay. This is the reaction of metal carbonates, that is magnesium carbonate and magnesium hydrogen carbonate with hydrochloric acid to form salt, carbon dioxide and water. Okay. And also they have given that we have to mention the test to test the gas evolved in the reaction. Here you can see clearly that carbon dioxide gas is released. How to test the carbon dioxide gas? We all know that when carbon dioxide gas is passed through the lime water, it will turn lime water milky. Okay. Test for CO2 gas. When CO2 gas is passed through lime water, it turns milky. This is the test for carbon dioxide gas. You can also write the equation for it. This is lime water. When CO2 is passed through it, it forms calcium carbonate. It is white in color, because of which the solution will turn milky. Okay. This is a test for carbon dioxide gas. Now the next question is, 2 ml of sodium hydroxide solution is added to a few pieces of granulated zinc metal taken in a test tube. When the contents are warmed, a gas evolves which is bubbled through a soap solution before testing. Write the equation for the chemical reaction involved and test to detect the gas. Name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. Okay, let us solve this question. 2 ml of sodium hydroxide solution is added to pieces of granulated zinc. So we have to write the reaction for zinc with sodium hydroxide. Okay, zinc reacts with sodium hydroxide. It is a reaction of metal with base. It forms sodium zincate. It is sodium zincate. Here there is a evolution of hydrogen gas here. They have given that a gas evolves which is bubbled through a soap solution before testing. Write the equation for the chemical reaction involved and the test to detect the gas. We have written the chemical reaction here. We have to test the hydrogen gas. Okay, we know that when hydrogen gas is evolved and a burning candle or a matchstick is brought near the gas, it will burn with a pop sound. Okay, when a burning candle or matchstick is brought near the gas, it will burn with pop sound. So we have solved these two. Write the equation for the chemical reaction involved and the test to detect the gas. We have written the chemical equation also. So balance this. Then again they have given that name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. See, it is little bit twisted, but if you understand the concept well, then it is very easier to write. The same metal means here you have to take again the zinc only. When the same metal, that is zinc, reacts with dilute solution of strong acid, you can take strong acids like hydrochloric acid or sulfuric acid. Let us take hydrochloric acid here. What is the formation? When metals react with acids, we get salt ZnCl2 plus H2. Okay. This is the reaction that forms. Again, they have asked that name the gas which will be evolved when the same metal reacts with dilute solution of strong acid. Here also, we should write zinc reacts with hydrochloric acid to form zinc chloride. It is salt and the gas evolved is hydrogen. So you should complete the answer. First check the question properly. What all they have asked you. Okay, in the same question you can see here it is of 3 marks actually. You have to write the equation for the reaction of zinc and base here, that is sodium hydroxide. You should write the complete equation. Then they have given that write the test for gas, for the gas that is evolved. So we have written the test for hydrogen gas here. And also they have asked to write the reaction for the same metal, that is zinc. You have to take the same metal which is mentioned in the question with the dilute solution of strong acid. Strong acid means you can write hydrochloric acid. So it will form again the salt and hydrogen gas. And at last you should mention that which is the gas that is being liberated. That is here hydrogen gas is liberated. You have to mention it. Okay. Read the question properly and answer each and every part of the question without miss. Okay. Next, write the name, method of preparation and uses of following. It is also a very easy question. This is, we know that bleaching powder. Let us write the method of preparation for bleaching powder. We know that it is prepared by bleaching powder is prepared by the action of chlorine on dry slaked lime. How does this forms? When dry slaked lime is taken and it is made to react with chlorine, we get bleaching powder. This is bleaching powder. And also they have given that we have to write the uses of the following. What is the uses of bleaching powder? It is used as an oxidizing agent. It is used as an oxidizing agent. And also, as the name itself indicates, it is used to bleach the cotton and linen textile in the textile industries. Okay, it is used to bleach cotton and linen in textile industry. After bleaching, there is a shining appearance on the cloths. Because of that only, the cotton and linen textiles are bleached with bleaching powder. Okay. Again, we have to write the preparation of plaster of Paris, that is calcium sulfate hemihydrate. Okay. So let us write the preparation of calcium sulfate hemihydrate, that is plaster of Paris. We know that CaSO4, it is plaster of Paris. It is prepared by heating gypsum at 373 Kelvin, that is 100 degrees Celsius. This is gypsum, that is calcium sulfate dihydrate. When you heat this at 373 Kelvin, we get plaster of Paris. And there is a removal of water molecule here. Then we should write the uses. What is the uses of plaster of Paris? There are many uses. It is used in the making of statues and toys, and also it is used to fix the fractured bones or cracks in right position, used in making decorative materials, toys, statues, and also it is used in fix fractured bones in right position. Okay, you might have seen whenever there is accidental fracture, the doctors will wind the plaster that is made up of plaster of Paris, so that after some days the fracture will get recovered and the bones will be in the right position. Yes, this is all about calcium sulfate hemihydrate, that is plaster of Paris. Then also they have asked about sodium bicarbonate. How is it prepared? Third one is sodium bicarbonate. We know that it is prepared by using sodium chloride as raw material. Okay. What happens? The reaction of sodium chloride in the presence of carbon dioxide, water and ammonia, there is a formation of sodium bicarbonate. This is sodium bicarbonate or sodium hydrogen carbonate. We have written its reaction and also we need to write its uses. There are many uses of sodium bicarbonate. Among, let us mention some of them. It is used in the fire extinguishers. We know that when this sodium bicarbonate reacts with acid, there is a formation of carbon dioxide gas there. So in fire extinguisher, this reaction is used where carbon dioxide gas is liberated, and this carbon dioxide gas is helpful in extinguishing the fire. Okay, and also it is, as it is basic in nature, it is used as an antacid. It will neutralize the excess acid in our stomach. Okay, this is all about the preparation and uses of these compounds. Then let us move to the next part. Next question. Yes, the question is explain why an aqueous solution of sodium sulfate is neutral while an aqueous solution of sodium carbonate is basic in nature. We know that the acidic or basic nature of the salts depends on the acid and base which are involved in the neutralization reaction. We know that how sodium sulfate is formed. Sodium sulfate is formed by strong acid and strong base. Neutralization of strong acid and strong base, that is when NaOH and H2SO4 neutralized sodium sulfate is formed. Whereas sodium carbonate is formed by weak acid and strong base. How is it formed? Sodium carbonate, when sodium hydroxide and carbonic acid react, we get sodium bicarbonate. Okay, this is the reaction. In this case, the neutralization reaction is between the strong acid and strong base and strong acid So the resulting salt will be neutral. Whenever there is neutralization reaction between strong acid and strong base, neutral salt is formed. But here the neutralization reaction is between strong base and this carbonic acid is weak acid. So the resulting salt will be basic salt. You have to remember this. Okay. As carbonic acid is weak acid and sodium hydroxide is strong base, the neutralization reaction between them will result in the formation of basic salt, because of which sodium carbonate is basic in nature. Okay, this is all about the PYQs and exemplar questions. So we have covered almost all the questions along with their concepts. So go through all the concepts. Once you go through the concepts, then it will be easier for you to solve the questions. Before solving the questions, keep in mind that you should read the question properly. Okay, by this let us end this session. In the next session, let us discuss the another chapter. Hello everyone. In the today's session, we are going to discuss on the chapter carbon and its compounds. Yes, carbon is such a versatile element. Yes, carbon is such a versatile element that we do find its applications in every field. So, what are the concepts that we are going to study in this chapter? We are going to study about the bonding in carbon. How carbon will form bond with other elements or itself, and we are going to study its versatile nature because of its nature, that it is able to form huge number of compounds. Then we are going to learn about the saturated and unsaturated carbon compounds. Then nomenclature of carbon compounds, means how do we name the compounds of carbon with a certain set of rules. Then we are also going to study the chemical properties of carbon compounds, and at last we are going to study some important carbon compounds, that is ethanol and ethanoic acid. We are going to study the uses and properties of these two compounds. Yes, let's get started. See the things that you can see in the picture: food, pencil, charcoal, oil, sanitizers, living organisms, diamond, table, clothes, perfumes. All these substances, all these things consist of carbon. Why are we studying carbon in this separate chapter? Because of its huge importance. It can form several number of compounds. It can form thousands of compounds, lakhs of compounds because of its versatile nature. When you see living organisms, we have carbon in our body. We do have proteins, lipids, we have fats. All these are made up of carbon. They contains carbon also. Then when you see the things like sanitizers, books, cloths, diamond, what are these? They consist of carbon. When you see diamond, it consists of carbon only. It is not a compound. It consists of only the carbon atoms. When you think of table, chair, which are made up of wood, that also consists of carbon. Then soaps and detergents that we use in our daily life, they also consist of carbon. So there are innumerable number of compounds that carbon forms, because of which it has its own importance. Okay, in this chapter only we are going to understand its versatile nature. Carbon is an element, that too it is a non-metal. It is a non-metal. In carbon, the atomic number is 6. The atomic number of carbon is 6. Then we can write its electronic configuration here. Electronic configuration of carbon is 2 4, which means 2 electrons are present in K shell, 4 electrons are present in L shell. Yes, and one more important thing, and where do we find this carbon? About 0.02% of carbon is found in the earth's crust in the form of minerals. Yes, earth crust contains about 0.02% of carbon, and about 0.03% of carbon is found in the form of carbon dioxide, that is present in our atmosphere. Yes, it is present in the form of carbon dioxide, and in spite of this small amount, it has got its own immense importance. You can see here, carbon atom has electronic configuration 2 4, means in the outermost shell it is having 4 electrons. According to the octet rule, what we have, it should have 8 electrons in its outermost shell, so that it will become stable. All the elements in the nature, they tend to have the electronic configuration of the nearest noble gas, means they tend to have the outermost shell to be completely filled. Now you can see here, carbon is having 4 electrons, but it needs 4 more electrons to get complete octet. Yes, then it shows that it will form bond with other compounds. Yes, it will form bond with other elements in order to complete its shell, outermost shell. Okay, let us see how does the bonding takes place in carbon. As I have already said that it is having 4 electrons in its outermost orbit. Then how can it become 8 here? Either by gaining 4 electrons, it can be stable by gaining 4 electrons, so that it will become 2 8, or there is one more possibility that it can lose these 4 electrons to become stable, that is it will be having duplet electronic configuration. That is, if it loses electron, it will get 2 electrons, means if these electrons are removed, then the outmost shell will be K shell. It will be having 2 electron, which is completely filled, because K shell can occupy only 2 electrons. So it will have stable duplet configuration. Okay, let's see how it goes. How does a bonding in carbon can takes place? It could gain 4 electrons to become, yes, in the previous chapter we have seen that the elements tend to lose or gain electrons in order to get the stable electronic configuration. Yes, you have seen in the case of NaCl, sodium was having 1 electron in its outermost orbit, so it loses 1 electron in order to become stable. And chlorine, it is having 7 electron in its outermost orbit, so it was having tendency in order to gain 1 electron. So there was a bond formed between these two by complete transfer of 1 electron from sodium to chlorine. Now carbon can also do the same thing here. It can gain 4 electron in order to become carbon anion. Yes, if it gains 4 electrons, then the number of electrons that will be carbon having is 10 electrons. Yes. But count the number of protons here. It is same as that of earlier. Yes, we are not changing the number of protons. When the elements form bonds, that is when the atoms participate in bonding, there is no change in the number of protons. So it is having 6 protons only. Atomic number of carbon is 6. It is having 6 protons and 6 electrons. Suppose if it gains 4 electrons in order to become stable, what happens? It will be having 10 electrons. But it would be difficult for these 6 protons to hold on 10 electrons. Yes. So the carbon atom will not gain 4 electrons as it is difficult to hold 10 electrons instead of 6. Initially it was having 6 electrons, but if it gains 4 more electrons, then it will become 10 electrons. So it is difficult for this protons to hold 4 more electrons. That is total 10 electrons. So it is difficult protons to hold 6, that is 10 electrons. So carbon atom will not form C4 minus anion. Yes. And is there any possibility of losing these 4 electrons? Yes. It is having electronic configuration, as we know. Carbon is having electronic configuration 2, 4. Now the first possibility cannot happen. That is, it cannot gain 4 more electrons. It is not possible. And let us check whether can it lose these 4 electrons and become the stable duplet that is nearer to the noble gas, that is helium. It is also not possible, because in order to lose these 4 electrons means in order to remove these 4 electrons, large amount of energy is required. So it cannot form C4 plus cation. Initially what happened in case of sodium, it was having only 1 electron in its outermost orbit. So it is easy to remove this 1 electron. Even if it is having 2 electrons, in case of magnesium, it is having 2 electrons. It is also easy to remove these 2 electrons in order to form stable octet. But carbon is having 4 electrons in its outermost orbit. It is not that much easy to remove these 4 electrons. Large amount of energy will be required. So it is not stable. Hence, what happens? It will not form C4 plus cation. What is the another possibility here? It could lose 4 electron to form C4 plus cation. But large amount of energy is required to form C4 plus cation. That is to remove 4 electrons from each carbon atom. So these two possibilities are also not possible. It is not possible to form either anion of carbon and cation of carbon. Then what is the possibility that is left which can be useful for bonding? It is true that it should form bond with other elements in order to get stable octet. How does this happen then? There is a possibility that carbon will share its 4 electrons with other elements or even with itself. If it shares 4 electrons, what happens? There is a sharing between the two atoms here. Yes, if carbon share its 4 outermost electron with other elements, those elements also share their outermost electron with carbon, resulting in the formation of octet configuration. So let us see how does this happen. Yes, so carbon overcomes this problem by sharing the valence electrons. You are going to now understand how the sharing of electron takes place in carbon. First, let us see some simple examples in order to understand how does this sharing of electrons takes place. Yes, let us see some simple examples here. Now, see, I have said that there is a sharing of electrons between the carbon and other elements in order to form stable octet. How does this sharing happens? Let's take the simple example of hydrogen molecule here. how does the bonding takes place in hydrogen molecule. And that bond which is formed due to sharing of electron is called as covalent bonding. You are going to understand this bonding right now. Yes, carbon, sorry, hydrogen is having one electron in its outermost shell. The atomic number of hydrogen is 1 and it is having K shell and the electron is present in that K shell only. Now it needs one more electron in order to have duplet configuration. Yes, duplet configuration is also stable. It is a stable electronic configuration of helium atom. Yes, every element tends to have stable electronic configuration of the nearest noble gas. Now the hydrogen atom needs one more electron in order to satisfy it duplet. Yes, what it does is it will form bond with other hydrogen atom. Now this hydrogen atom will share its one electron with this hydrogen atom and this hydrogen atom will share its one electron with this hydrogen atom. Means there is a mutual sharing of these electrons. These two hydrogen atoms are identical. Simply for understanding purpose, we have shown it with a different color. Now, once the sharing of electrons takes place in between these two atoms, these two electrons are belonging to both the atoms. So that this hydrogen atoms also gets the duplet configuration and this hydrogen atom will also have the duplet configuration. Means this hydrogen atom is also having two electrons here and this hydrogen atom is also having two electrons here. So that the configuration is satisfied. Yes, so that they are become stable now. In this way hydrogen molecule is formed. Let us see few more examples and remember that the bond that is formed between them is called as covalent bond. Means here there is a mutual sharing of electrons between these two atoms. That type of bond is called as covalent bond. And if each atom shares one electrons towards with other atom, then there is a formation of single bond here. Yes, and there is also possibility of formation of two bonds. We will see this. Now let us see how does this covalent bonding occurs in oxygen molecule. Yes, see here the atomic number of oxygen is 8 and it has electronic configuration 2 6, means 6 electrons are found in the outermost shell. Now this oxygen atom needs two more electrons in order to become completely filled. Yes, I can represent this as oxygen atom and it is having 6 electrons in its outermost shell. These are its 6 electrons. This is another oxygen atom. It is also having 6 electrons in its outermost shell. Now what happens? Each oxygen atoms need 2 more electrons in order to become stable. So what they do is they will share 2 electrons with other oxygen atoms. Yes, this oxygen atom will share these 2 electrons with this oxygen atom and these 2 electrons are shared by this oxygen atom. So that each oxygen atom will get 8 electrons for their outermost shell. Yes, the bonding takes place as like this. See here, these 4 electrons, they are belonging both to oxygen atom. They are belonging to both the oxygen atom. Now count the number of electrons that each oxygen gets. 1, 2, 3, 4, 5, 6, 7, 8. And for this oxygen atom also 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. Yes, so each oxygen atom now has got 8 electrons in their outermost shell. So this results in the formation of O2 molecule. Now it is O2 molecule. And when they are sharing one electron with other atom, there is a formation of one bond. If it is sharing 2 electrons, means a pair of electron, then it will be having 2 bonds. So oxygen molecule has double bond. Why it is having double bond? Because each oxygen atom has shared a pair of electron. In the earlier case, that is hydrogen, it was sharing only one electron. So one bond is formed here. In this case, two electrons are shared by each oxygen atom, so that the bond will be double. This is the representation of bond. How do we represent bond? By a single line. Now this O2 molecule is having two bonds. In case of hydrogen, it is having only one bond. Yes, this bond is called as covalent bond. What is covalent bond? The bond that is formed by the mutual sharing of electron. Why do we call here sharing? Because these electrons are belonging to both the atoms. In the previous case, that is in case of ionic bonding, there was complete transfer of electron from one element, that is from one atom to another atom. Whereas in case of oxygen molecule that is formed by the covalent bond, here there is a sharing of electrons. So this bond is called as covalent bond. Yes. Now let us see one more example here. Chlorine molecule. What is the electronic configuration of chlorine molecule? It is 2, 8, 7. How many electrons does each chlorine atom need in order to form stable? It needs 1 electron. Yes. We can represent its configuration, that is its valence shell electrons as 1, 2, 3, 4. We can represent the outer shell electrons as 1, 2, 3, 4, 5, 6, 7. And in case of another chlorine atom, 1, 2, 3, 4, 5, 6, 7. See here, in both the case, each chlorine atom needs one electron to form stable octet. So what they do is, they mutually share their electron. Each chlorine atom share one electron, so that there will be a pair of electrons between these two atoms. This results in the formation of covalent bonding. How do they form bond here? Chlorine, they will share each electron. Now see here, the shared pair of electrons are belonging to both the chlorine atoms. Now count the number of electrons here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, so these two electrons are belonging to both the chlorine atoms. So it is called as covalent bonding. Now we can represent this bond as Cl, Cl, as there is sharing of one electron each between these two chlorine atom. There is a formation of a single bond here. Next, let us take another example here. Nitrogen molecule. What is the electronic configuration of nitrogen here? Electronic configuration of nitrogen is 2, 5. Means the atomic number is 7. Yes, nitrogen is having atomic number 7. Now, how many electrons does the nitrogen atom needs in order to become stable? It needs 3 electrons. So, I can represent it with the electron dot structure as the representation of these electrons, that is valence electrons around the element, that is chlorine or any other element. It is called as Lewis dot structure. What we are going to represent here? We are going to represent the valence shell electrons around the symbol of element, that is called as Lewis dot structure. Yes, here it is having 5 electrons in its outermost shell. Okay, 1, 2, 3, 4, 5. Now what each nitrogen atom does is, it will share 3 electrons with other nitrogen atom, so that they will be having 6 electrons in between them. All these 6 electrons are belonging to both nitrogen and this nitrogen. So how the bond is formed here? Yes. How does this look? It is a triple bond. Why? Because there is a sharing of 3 pair of electrons. Remember, if there is a sharing of 1 pair electron, then there is a single bond. If there is sharing of 2 pair of electrons, then there is a double bond. If there is sharing of 3 pair of electron, then there will be triple bond. Yes, these are covalent bonds. This is how nitrogen molecule has formed. And you can also count here the number of electrons for each nitrogen atom. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So each nitrogen atom will get 8 electrons. This is how covalent compounds are formed. And remember that these covalent compounds have some properties like they are having low melting and boiling point. They are having some general properties like covalent compounds they have low melting point and boiling point. Unlike ionic compounds, why these covalent compounds are having low melting and boiling point? Because there is no such strong intermolecular force of attraction. Even though this bond is strong, the covalent bond is strong, no doubt, but the intermolecular force of attraction is not that much strong here. Because of which these will melt easily, these will boil easily, as the intermolecular force of attraction is less in case of covalent compounds. And also, these are poor conductors of electricity. Covalent compounds are conductors of electricity. Why? They are poor conductors of electricity because there is no formation of ions here. There is a mutual sharing of electrons between the atoms. So there is no formation of ions which are required for conduction of electricity, because of which these are poor conductors of electricity. Yes, you have to remember these points. Now let us come back to the carbon. How does the valency of carbon is satisfied by covalent bonding? Let us see. Now let us represent the dot structure, electron dot structure for carbon here. It is having 4 electrons in its outermost orbit. In order to become stable, it needs 4 more electrons. Then how does it forms bond? Let us take with the help of example methane molecule. Now it will form bond with 4 hydrogen atoms. As we have seen earlier, hydrogen atoms need one more electron in order to become stable. So each carbon atom will share one electron with one hydrogen atom. So it will share its 4 electrons with 4 different hydrogen atoms. Yes, this is hydrogen atom. It is having 1 electrons in its outermost shell. Yes, this is another hydrogen atom. It is having 1 electron in its outermost shell. This is another hydrogen atom which is having hydrogen atom in its outermost shell. In the same way, we are having this. So, carbon is sharing its 4 electrons with 4 different hydrogen atoms. Each hydrogen atom will share 1 electrons. 1 electron. Each carbon atom will share 4 electrons with 4 different hydrogen atoms, resulting in the formation of methane molecule. So the bond formed here is covalent bond between C and H. See here, as the shared electrons are related to both carbon and hydrogen, we can represent the molecule as like this. This is to show that bond has been formed between carbon and hydrogen, that is covalent bond. And these two electrons, these are belonging to both carbon and hydrogen. Now count the number of electrons around carbon here. Are they satisfied? Is the valence electron shell configuration is satisfied? It become completely filled now? Let us check. The carbon atom is having 1, 2, 3, 4, 5, 6, 7, 8. Yes, the valency of carbon is satisfied. What about hydrogen? Hydrogen should get 2 electrons. So each hydrogen has got 2 electrons here. You can check here. So the valency of carbon is satisfied and also hydrogen. This is CH4 molecule. And we can also represent it with the help of bonds as like this. Each bond represent that there is a sharing of one pair of electron between these two atoms. Okay. Now let us see the allotropy of carbon. Allotropy is the property by virtue of which an element can exist in more than one form. Yes, allotropy is the property an element can exist in more than one form. What does this mean? The same element is going to exist in different forms. The composition is same, but the manner in which the atoms are arranged is different. And this forms is called as allotropes. And these forms of element are called allotropes. We can see this property in case of carbon. Yes, carbon exists in different allotropes, like allotropes of carbon are, it exists in different allotropes like diamond, graphite and Buckminster Fullerene. See here, all these forms have carbon only. Entirely these forms are made up of carbon only. The manner in which the atoms of carbon are arranged is different, which results in the different physical properties. These allotropes have different physical properties. Yes, but they have identical chemical properties as the composition is same in all the forms. They are having the single element. They are not bonded to any other elements there, because of which the chemical identity is same. The chemical properties are same. See here, in case of diamond, each carbon atom is bonded to four different carbon atoms. Yes, like this. This is one carbon atom. It is bonded to four other carbon atoms. And in turn, this carbon atom is bonded to four other carbon atoms. And this carbon atom is bonded to four other carbon atoms. In this way, the carbon atoms are arranged in the three-dimensional structure. Each carbon atom is bonded to four other carbon atoms such that there is a formation of network. There is a three-dimensional structure that is formed, and the bond between them is covalent bond. Yes, the bond between them is covalent bond here. These atoms are tightly packed in the three-dimensional structure, giving them the crystal structure. They have definite geometrical structure, because of which this will give hardness to diamond. Have you seen diamond? It is very hard substance. In nature only, this is the hardest substance that we have got. This hardness is due to the pattern of arrangement of these carbon atoms. These carbon atoms are involved in the formation of three-dimensional structure, three-dimensional network that is very strong. The bond between the carbon atoms is very strong, giving them a very hard structure. Yes, what about the physical properties of diamond? Diamond is colorless. Yes, it is colorless. It is hard and it is poor conductor of electricity. It will not conduct electricity. These are the different properties of diamond. It is poor conductor of electricity. And here we can see each carbon atom is bonded to four other carbon atoms, giving them three-dimensional geometrical structure, resulting in the formation of crystal. Yes. What in case of graphite? In case of graphite, the arrangement is different than that of diamond here. Here, each carbon atom is bonded to three different carbon atoms. Each carbon atom is bonded to three other carbon atoms forming hexagonal rings. Forming hexagonal rings. And these hexagonal sheets are two-dimensional in nature. See here how the bonding takes place. Each carbon atom is bonded to three other carbon atoms. They will form a hexagonal sheet structure, and in turn this is bonded to different carbon atoms like this. In this way, there is an arrangement of carbon atoms such that each carbon atom is bonded to three different carbon atoms. Ask that how the valency is satisfied. Among these three bonds, one of the bonds will be double bond. Yes, one of the bond will be double bond. And along with this, as they form a hexagonal arrays, there is a formation of layers here. In this way, there is a formation of layers of these hexagonal rings one above the other. And between these layers, there is a van der Waals force of attraction between the atoms. What is van der Waals force of attraction? It is a weak force of attraction between the molecules. And because of this force of attraction, they are formed in the form of layer. Between these layers, there is some space, because of which the layers will slide over each other. And between these layers, there is again a force of attraction which is weak, that is called as van der Waals force of attraction. And because of this van der Waals force of attraction, these layers are connected to each other, and the space that is there in between these layers, it causes the slippery nature of this graphite. You might have seen graphite is slippery. It is used as a lubricant. Yes. And you might have also seen that it is used in making lead pencils and all, because it is slippery due to the presence of some space between these layers as the layers slide over each other. And also you might have seen that this is a good conductor of electricity. We have studied in the chapter 3. This is an exception. When we were studying about the properties of non-metals, usually non-metals are poor conductors of electricity. Even diamond is also poor conductor of electricity, but graphite, it is a good conductor of electricity, because you see here the fourth electron that is involved in the pi bonding, it is free, and that electrons of each carbon atom can easily move between these spaces, and it is available for conduction. Why does the substance conduct electricity? It is due to the availability of free electrons or free ions. Here there are no ions, but there is a free electron. The fourth electron that is free to move between these layers. This results in the good conductivity of graphite. Yes, what are the properties that we can see? Graphite is slippery, it is good conductor of electricity, and you have also seen that each carbon atom is bonded to three other carbon atoms, and the bond between them is covalent bond. These hexagonal rings, they form sheet-like structures. It is a two-dimensional sheet-like structure, and there is a force of attraction between these two sheets. Not only these two, there will be many number of sheet-like structures in this allotrope, and these layers are held together by van der Waals force of attraction. The layers of carbon rings, that is hexagonal carbon rings, are held together by van der Waals force of attraction. What is this van der Waals force? It is a weak force of attraction between the molecules. Yes, this is about the graphite. As there is different arrangement between the carbon atoms, it will change its physical property. Now only you have seen that diamond is a very hard substance. Why is that hardness? It is due to the closely packing of these carbon atoms with four other carbon atoms, resulting in the formation of network, and it is very hard to break those bonds, because of which it is having hardness. And in case of graphite, you see that each carbon atom is bonded to three different carbon atoms, forming a hexagonal rings, and the sheet-like structure that is formed between these uh, and the sheet-like structure that is formed have van der Waals force of attraction with other layers, and because of the space between them, they slip they show the slippery characteristic. Yes, this is about the graphite. Now let us see about the Buckminster fullerene. Another one form of allotrope is Buckminster fullerene. It is also class of carbon allotrope. It is also another class of carbon allotrope. Now we are understanding what is this allotropy. Here we are having the same element carbon, but the arrangement of this carbon atom is completely different. Yes, and the first fullerene that was identified was C60. Yes, the first fullerene discovered was C60, means it is having 60 carbon atoms, and these carbon atoms are arranged in the form of football. The carbon atoms are arranged in the form of football, and some of the carbon atoms will form pentagonal structure, some of the carbon atoms will form hexagonal structure, and this results in the formation of a football like structure there. Yes, like some of them will form hexagonal rings, and some may form pentagonal rings also. See here, the carbon atoms are arranged to form some of the pentagonal rings like this. Only 5 carbon atoms are there, and some may have 6 carbon atoms to form hexagonal ring. So this fullerene that was identified as C60, it was having 60 carbon atoms, which were arranged both in the pentagonal ring and hexagonal ring to form a football like shape. Yes, and it was named Fullerene because this was resembling the geodesic dome of designed by US architect Buckminster Fuller. This was resembling the geodesic dome that was designed by the US architect Buckminster Fuller. So it is named after him. It is also a class of carbon allotrope where this all the atoms are made up of carbon only. It is containing only the carbon element. So it is an allotrope of carbon. Actually, it is been recently discovered. Still, the research is going on about this class of compounds. Yes. Let us solve some questions on electron dot structure. This concept is very important. Question may be asked in your examination to write the electron dot structure of some molecules. So you must have knowledge regarding this. Yes. In order to solve such type of questions, you should know the valency of each element there. Yes. Now first let us see the first question here. Write the electron dot structure of carbon dioxide. For this we should know the valency of carbon and oxygen. Yes. Atomic number of carbon is 6. How does we represent electronic configuration? 2, 4. And what about atomic number of oxygen? It is 8. We represent its electronic configuration as 2, 6. You can see here carbon needs 2 electrons. Sorry, carbon needs 4 electrons in order to have complete octet. And oxygen needs 2 electrons in order to have complete octet. Let us represent the covalent bond with the electron dot structures. Carbon is having 4 electrons in its outermost orbit. 1, 2, 3, 4. And each oxygen atom is having 6 electrons in its outermost orbit. 1, 2, 3, 4, 5, 6. Another oxygen atom. 1, 2, 3, 4, 5, 6. Now see here, if oxygen shares 2 electrons with carbon atom, then its valency will get satisfied. 1, 2, 3, 4, 5, 6, 7, 8. And the same with other oxygen atom. 1, 2, 3, 4, 5, 6, 7, 8. And if carbon shares 2 electrons with each oxygen atom, then it will get 8 electrons. See how the bond is formed here. You can count the number of electrons for each atom. For oxygen atom, see here 1, 2, 3, 4, 5, 6, 7, 8. For carbon 1, 2, 3, 4, 5, 6, 7, 8. For another oxygen 1, 2, 3, 4, 5, 6, 7, 8. So the number of bonds formed between the carbon and oxygen will be 2 here, as oxygen and carbon have shared 2 pair of electrons. So the number of bonds that is formed here is 2. So how to represent the molecule with the electron dot structure? See, there is a formation of 2 bonds with oxygen, and here also there is a formation of 2 bonds with oxygen and the remaining electrons. This is the electron dot structure for CO2 molecule. What are the steps that are involved in writing the electron dot structure? First you have to remember the atomic number, then electronic configuration, then you have to represent the number of valence electrons, that is valence electrons around each element. Then you have to show the bond formation so that when the bond is formed, the both electrons are belonging to both the atoms. Yes. Now let us see the next example. Write the electron dot structure of H2S molecule. Atomic number of hydrogen 1. So electronic configuration will be 1, simply 1. Then atomic number of sulfur is 16. Then electronic configuration will be 2, 8, 6. It needs one more electron in order to form stable. It needs 2 electrons in order to form stable. Let us represent it with the electron dot structure. Sulfur is having 6 electrons in its outermost orbit. What about hydrogen? It is having 1 electron. Now they will share electrons between them in order to form covalent bond. Hydrogen will share 1 electron with 1 sulfur atom. Each hydrogen atom will share 1 electron with the sulfur atom. And sulfur atom will share 1 electron with each hydrogen atom. Yes. Now count the number of electrons around each element now. Hydrogen 1, 2. Yes, it is satisfied. Now sulfur 1, 2, 3, 4, 5, 6, 7, 8. Yes, the valence is satisfied. In case of hydrogen 1, 2. This is also satisfied. Now we have to represent it with the dot structure H, S, H. The remaining electrons are shown here. This is the electron dot structure of H2S molecule. This one bond, that is this single bond, represent the shared pair of electron is only one, because of which single bond is formed here. Here also there is a formation of single bond, that is covalent bond between sulfur and hydrogen. This is how we represent the electron dot structure. Hello my dear students. In the previous session, we had discussed about the nature of bonding in carbon, and also we have learned how to draw the electron dot structure for covalent compounds. And in this session, we are going to understand the versatile nature of carbon, which results in the formation of large number of compounds of carbon. And also we will discuss about the different classes of carbon compounds in this session. Okay, let's get started. Yes, my dear students, in the beginning of the chapter, we have learned that there are many things which are around us that contains carbon. Right from the clothes that we wear, the soaps and detergents that we use, fuels, they consist of carbon, plastics, rubber, dyes, all these substances contain carbon, which means carbon can form large number of compounds, and practically more than 3 million of carbon compounds exist. So what is the reason behind it that carbon can form such a large number of compounds, that too all these compounds are stable? It is due to the versatile nature of the carbon, which will lead to the formation of these large number of compounds. Yes, let us understand the nature of carbon. It is due to mainly two reasons that carbon can form huge number of compounds. Yes, what are they? That is tetravalency of carbon. Means carbon is having valency 4, so that it can share its 4 electrons with other atoms of carbon and also with atoms of other elements. So it can form 4 bonds. And also not only this, it can form bonds with many other atoms like oxygen, sulfur, chlorine, hydrogen, nitrogen, bromine, iodine. In this way, it forms stable bond with these atoms. And the second reason is that it is and the second reason is that it shows the property of catenation, which means it is capable of bonding with other atoms of carbon, resulting in the formation of large number of molecules here. Okay, let us understand its versatile nature here. Yes, carbon is having tetravalency. Carbon can form, yes, it can form bond with 4 different atoms of carbon and also with atoms of other elements. It can form bond with atoms of sulfur, nitrogen, oxygen, chlorine, hydrogen, iodine, etc. Yes, this carbon atom can form bond with all these atoms and also many number of atoms of other elements. This gives rise to formation of many number of compounds. And the bond between the carbon and these elements, atoms of these element, is quite strong because it is due to the size of carbon atom. The size of carbon atom is small, so the bond formed between the carbon atom is quite strong. Why it is strong? Because the size of the carbon atom is small, which results in the shared pair of electrons to be held strongly by the nucleus. The shared pair of electrons between the two atoms, that is in between carbon and any other atoms, these shared pair of electrons are held together by the nucleus with strong force of attraction, so that it is not easy to break these bonds, because of which carbon shows bonding with these atoms. Yes, and also another one reason is it is due to the catenation property. What is this property? It is the property of carbon that it can form bond with other 4 atoms of carbon, resulting in the formation of large molecules. Yes. carbon can form bond with other atoms of carbon, resulting in large molecules. Yes, carbon can form bond with other carbon atoms, like it can form chain chain structures. Carbon can bond with other carbon atoms to form chain, and also they can form branches. They can form branches like in this way, and also they will form rings. These will result in the formation of rings of many number of carbon atoms. This give rise to formation of large number of carbon compounds, and also they show single bond between the carbon atoms, and also they will have double bond between the carbon atoms, and they can have triple bond between the carbon atoms. In the previous session only we have discussed that when there is sharing of one pair of electrons, there is a single bond. If there is sharing of two pair of electrons, then it results in the double bond. When there is sharing of three pair of electrons, it will result in the triple bond. Yes. And when there is formation of only single bond between the carbon atoms, then such compounds are called as saturated carbon compounds. In case of CC, single bond. In the molecule, there is only presence of carbon single bond. And when there is presence of double or triple bond between the carbon atoms, then those compounds are called as unsaturated compounds. And as I have already said that the bond between these carbon atoms is quite strong. The covalent bond, it is very strong because the size of carbon atom is small, and the shared pair of electrons between the carbon atoms, it is sharing a pair of electrons between them. These pair of electrons are strongly held by the nucleus. This results in the carbon-carbon bond to be very strong. Yes, carbon-carbon bond is very strong. When the bond is strong, this will result in the formation of stable compounds. So, this carbon which can form large number of molecules, they exist because due to stability of this carbon-carbon bond. Even some of the elements like sulfur or silicon, they can also form chains or rings. But these are quite reactive. Some of the catenation property is also seen in the elements like silicon or sulfur, but these compounds are not that much stable as that of carbon compounds. They are quite reactive. Silicon can form chain up to 7 or 8 carbon atoms, 8 silicon atoms. Yes, it can also form chain, but these compounds are quite reactive. The bond between them is not that much stable as that of carbon-carbon bond, because of which a large number of molecules are existing in the carbon-carbon compounds, because of which there is a existence of large number of carbon compounds. Okay. So, overall, these two properties of carbon will lead to the formation of large number of compounds, that is both tetravalency and catenation property. Even there are many elements which have tetravalency like silicon, germanium, but these both the properties will lead to the formation of large number of compounds which are stable. Yes, this is very important. You have to note these two properties. Okay. And the carbon compounds which we are studying, they are called as organic compounds. Why the name is given as organic compounds? Because initially these carbon compounds were extracted from the living systems only, which were occurring naturally. So these carbon compounds are named as organic compounds. Initially, these compounds means compounds of carbon. Initially, the compounds of carbon were extracted from living organisms. So these compounds were called as organic compounds. We ourselves are also made up of carbon compounds. The proteins, many biomolecules, they contain carbon. Yes. Later, it was identified that These compounds can also be synthesized in the laboratory. The compounds of carbon can also be synthesized in the laboratory. And Frederick Wöhler was the first scientist to synthesize the organic compound, that is urea. He was the first scientist. Frederick, he was the first scientist. He synthesized the first organic compound in the laboratory. What was that first organic compound that was synthesized in the laboratory? It was urea from ammonium cyanate. It was the first organic compound that was synthesized in the laboratory. Yes, again there are many number of organic compounds that can be made artificially. Initially it was thought that only these compounds of carbon were extracted from the living organisms, so these were named as organic compounds. Until today we will study the compounds of carbon in the branch called as organic chemistry only. Except some of the carbon compounds like carbon dioxide, carbon monoxides, or hydrogen carbonates or carbonates, we will study the rest of all the carbon compounds under the organic chemistry. Okay, and now we are going to study the compounds of carbon. Yes, hydrocarbons, these are the compounds of carbon. As the name itself indicates that it contains hydrogen and carbon. These are the compounds of carbon and hydrogen. And these contain the atoms of carbon and hydrogen only. These are called as hydrocarbons. These are the compounds containing carbon and hydrogen only. Yes, among the hydrocarbons, we will see different class of hydrocarbons. Okay. There are basically two different hydrocarbons. They are saturated hydrocarbons and unsaturated hydrocarbons. In saturated hydrocarbons, we will see between the carbon atoms there is only carbon-carbon single bond. Whereas in case of unsaturated hydrocarbons, we will see there is a presence of at least one carbon-carbon double bond or carbon-carbon triple bond. Yes, these hydrocarbons contain only carbon-carbon single bond. Whereas in case of unsaturated hydrocarbons, these contain at least one double bond or triple bond between the carbon atoms. And recall again, single bond means there is a sharing of only one pair of electrons. Double bond means there is sharing of two pair of electrons. Triple bond means there is sharing of three pair of electrons. Yes, we can give many number of examples. This is a saturated hydrocarbon. It is called as ethane. We will come to the naming of these hydrocarbons a little bit later. Now just understand about the saturated hydrocarbons and unsaturated hydrocarbons. Here there is presence of only carbon-carbon single bond in these molecules. It is ethane. We are seeing here carbon-carbon single bond is present. Whereas in case of unsaturated hydrocarbons, there is either carbon-carbon double bond or triple bond. In this way, there is a presence of double bond, and also there may be presence of triple bond also. And understand one point that in case of saturated hydrocarbons, there may be only one carbon atom also. There may be existence of compound of one carbon atom also, as in case of methane. Here there is no presence of double or triple bond. Whereas for formation of double or triple bond, we need two carbon atoms, at least two carbon atoms, as in case of ethene and ethyne. There is no existence of any molecule which contain only one carbon atom in ethene or ethyne. There must be presence of at least two carbon atoms so that there is a double or triple bond. Yes? Yes. In saturated hydrocarbons, we are going to study about the alkanes. Alkanes are the saturated hydrocarbons. These are saturated hydrocarbons with the general formula CnH2n plus 2. As we have already learnt that carbon forms many number of compounds, and these alkanes are saturated hydrocarbons. They are having the general formula CnH2n plus 2, means they have only carbon-carbon single bond in their molecules. Yes, We have many examples for them. If it and this n represent the number of carbon atoms. If I take the number of carbon atom to be 2, then I get the formula C2H2 into 2 plus 2, that is C2H6. This is called as ethane. This is called as ethane. Means what? Ane represents it is an alkane, and eth represent that it contains 2 carbon atoms. Depending on the number of carbon atoms, we will start the naming with pro, eth, meth in this way. We will learn about the naming, that is nomenclature of this compound in the later part. For time being, understand that if the carbon atoms is only one, then we represent the compound with meth, means only one carbon. And if there are 2 carbon atoms, then we will represent it with eth, 2 carbon atoms. If the compounds contain 3 carbon atoms, then we will call it as prop, 3 carbon atoms. If it is having 4, then we call it as but. Pent is for 5 carbon atoms. Hex is for 6 carbon atoms. Hept is for 7 carbon atoms. Oct is for 8 carbon atoms. Non is for 9 carbon atoms. And dec is for 10 carbon atoms. If the compound contains 1 carbon atom, we will use the meth, eth for 2, prop for 3, but 4. In this way, for 10 carbon atom, we will use dec. And here, ane represent it is an alkane. If it is alkene, we will use ene. Yes, we will come to it little later. And there can be still many examples. If the number of carbon atoms is 3, we will get the formula as 3 into 2 plus 2, that is C3H8. What can we call this compound? It is having 3 carbon atoms, so it will be propane. As this is following the general formula, that is CnH2n plus 2. It is propane. All the alkanes will follow this general formula. Yes, all the compounds of carbon, that is alkanes, they will follow the general formula CnH2n plus 2. If I write C3H8, then it is an alkane. And it shows that there is the presence of only single bond between the carbon atoms without any doubt. Yes. And you can form many number of carbon compounds of alkanes. And this is about the saturated hydrocarbons. Then in case of unsaturated hydrocarbons, we will come across alkenes and alkynes. Yes. In unsaturated hydrocarbons, we will be studying the class of compounds called as alkenes and alkynes. These alkenes are the unsaturated hydrocarbons with at least carbon-carbon double bond. One carbon-carbon double bond. Yes, these are unsaturated hydrocarbons with general formula CnH2n containing at least one carbon-carbon double bond. If the compound contains carbon-carbon double bond, then those unsaturated hydrocarbons are called as alkenes. And the general formula for the alkenes is CnH2n. Let us write some examples. If the number of carbon atoms is 2, then what will be the formula? 2 into 2, that is C2H4. This is ethene. In the previous section only we have seen eth is used when there are 2 carbon atoms. And ene represents it is an alkene. Yes, in this way we can also write the 3 carbon atoms C2, 3 into 2, that is C2H6. It is, C3H6. It is propene. And we are going to see how these structures are drawn in the later part. Yes, for time being, understand that this name is used when there are 3 carbon atoms and it is an alkene, propene. Yes, in this way you can form many number of compounds of alkene. Then what about alkynes? These are also unsaturated hydrocarbons, but they have the general formula CnH2n minus 2. These are unsaturated hydrocarbons with general formula CnH2n minus 2. And it is very important that you have to remember this general formula. Yes, if a compound is given and you need to identify whether it is an alkane, alkene or alkyne, based on the general formula, it is very easy to detect whether it is an alkane, alkene or alkyne containing at least carbon-carbon triple bond. So this shows that alkynes contain at least one carbon-carbon triple bond. Let us see the examples following the general formula. Let us take C2, 2 into 2 minus 2, that is C2H2. This is called as ethine. Again, eth represent it contains 2 carbon atom. Ine represent it is an alkyne. Yes. And you can also write C3H2 into 3 minus 2, that is C3H4. It is propyne. In this way, these alkenes and alkynes are classified. Do not get confused with these alkanes, alkenes and alkynes. Remember, in alkanes, there is only carbon-carbon single bond. In case of alkenes, there is presence of at least one carbon-carbon double bond. In case of alkynes, there is presence of at least one carbon-carbon triple bond. There is only change in one letter here. Alkanes, alkenes, alkynes. A, E, Y. There is only change in the one letter. Do not get confused with these compounds. Yes. Next, we shall study how to draw the structure of these hydrocarbons. Whenever the molecular formula is given and you need to draw the structure of those hydrocarbons, how can you write it? Yes, let us study this with the help of example. Let us take an example of ethane. Yes, it is an alkane. In the step 1, we are going to write the carbon atoms by linking them together with single bond. Yes, here there are only 2 carbon atoms. I will write the carbon atoms in this way. This is called as carbon skeleton. Okay. And in the next step, I am going to satisfy the valency of this carbon atom, means both the carbon atoms, with hydrogen atoms. Yes. In the next step, see here already there is one bond between the carbon atoms. Now we have to satisfy its valency. What is the valency of carbon? 4. Again we will write the hydrogen atoms here so that valency of carbon atom is satisfied. In both the carbon atoms we have 3 hydrogen atoms. As the molecular formula is C2H6. This is the structure of ethane molecule. There are 6 hydrogen atoms, 3 for each carbon. In this way, we will write the structure of hydrocarbons. Then try one more example, ethene, C2H4. Yes, same here. In the step 1, we are going to write the carbon atoms in the form of skeleton. There are 2 carbon atoms. And see here, it follows the general formula of alkenes. Yes, it means there is a double bond between the carbon atoms. Okay, let us follow the step 2 here. Now we are going to satisfy the valency of this carbon atom with hydrogen atom. How many hydrogen atoms are present here? 4 hydrogen atoms. So let us write those 4 hydrogen atoms in the structure. 1, 2, 3, 4. For each carbon, we have written 2 hydrogen atoms. See here whether the valency of carbon is satisfied. No. Valency of carbon is not satisfied. It is still 3. Then we have to satisfy it with the help of double bond. Then the valency of carbon will be satisfied. And also from the molecular formula also we can understand it is an alkene. In this way we are going to draw the structure. Let us solve some more example for clarity. Let us draw the structure for propane. C3H8. As usual, in the step 1, we are going to write the carbon skeleton. That is, there are 3 carbon atoms here. 1, 2, 3. And in the step 2, we are going to satisfy the valency of carbon with hydrogen atoms. Why are we writing the hydrogen atoms around the carbon? Because this is hydrocarbon and it consists of only carbon and hydrogen here. You can clearly see from the molecular formula. So in the next step, we are going to satisfy the valency of carbon with hydrogen atoms. Each carbon should get 4 bonds. You can see in the first carbon, it is bonded to only one carbon atom, means there is only one bond here. So we will write 3 hydrogen atoms so that its valency will be 4. But in the second carbon, it is already linked to 2 other carbon atoms. Already it is having 2 bonds. So we have written only 2 hydrogens here. Whereas in case of third carbon atom, again it is linked to only one carbon atom. So we have written 3 hydrogen atoms for that carbon. Now overall, the molecular formula C3H8 has this structure. Then what about propene? How to write its molecular formula? How to write its structural formula? Again, as usual, in the step 1, we are going to write the carbon atoms linked together by single bond. There are 3 carbon atoms, so we will write 1, 2, 3. In the step 2, now we are going to satisfy the valency of carbon with hydrogen atoms. Again, see here, it is propene, means it consists of carbon-carbon double bond. So I can write here one double bond between the carbon-carbon atoms. Now write the number of hydrogen atoms. Here there is one bond, means still it needs 3 bonds. So 1, 2, 3 hydrogen atom. Here already it is having 3 bonds. Now its valency is to be satisfied with only one hydrogen atom. In case of third carbon atom, it already has two bonds. So I need to write 2 hydrogens for this. So totally I was having 6 hydrogen. 1, 2, 3, 4, 5, 6. And this double bond is because it is an alkene. And from seeing the name also we will understand it is an alkene. And by seeing the molecular formula also understand it is an alkene. Let's see propine. As usual, in the step 1, we are going to write the carbon skeleton. There are 3 carbon atoms here. 1, 2, 3. In the step 2, we are going to satisfy the valency of each carbon atom. And by seeing the name, we can see here there is a carbon-carbon triple bond. And by also seeing this formula also we can understand there is a presence of one carbon-carbon triple bond. So I will write one carbon-carbon triple bond. Now satisfy the remaining valency of the carbon atoms. Okay. There are 4 hydrogens here. We have to write 4 hydrogen atoms for this structure. Here there is one bond. So remaining 3 hydrogen atoms will form the bond here. And this carbon, the valency is already satisfied. Always remember that the valency of carbon is 4, and if there are 4 bonds around it, then do not add any atom to that bond. Okay. So here we are not adding any hydrogen as its valency is already satisfied. What in case of this carbon? Still it needs one hydrogen atom. So this is a structure for propine. And also we can write the electron dot structures for these compounds. Okay. Let us see. In your examination, questions may be asked about the electron dot structures, molecular formula and also structural formula. Yes. Now we shall study how to write the electron dot structure for these hydrocarbons. Let us draw the electron dot structure for ethane molecule. Yes. The molecular formula is C2H6. For drawing the electron dot structure, we have to write the valence electrons around each atom. For carbon atom, we are having 4 valence electrons. Yes. 1, 2, 3, 4. And for another carbon atom, C, 1, 2, 3, 4. There are only 2 carbon atoms here and there are 6 hydrogen atoms here. For one carbon atoms, they will form bond with 3 different hydrogen atoms. Hydrogen has only one valence electron. Each hydrogen is having one valence electron. Now count the number of electrons around each atom for this carbon. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And in this molecule, there is a covalent bond between this carbon and this carbon atom also, that is single carbon-carbon bond. And with 3 different hydrogen atoms also, there is covalent bond. And between these hydrogen atoms and carbon also, there are 3 different covalent bonds. Yes, this is electron dot structure for ethane molecule. First, what we have done, we have written the carbon atoms here. Around each carbon atom, we have written the valence electrons. And they form bond with hydrogen atoms. Each carbon forms bond with 3 different hydrogen atoms. And here, duplet of hydrogen is also satisfied. And octet structure of carbon is also satisfied. See, for this carbon atom, there are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. For this carbon atom also 1, 2, 3, 4, 5, 6, 7, 8. And as we know, the shared pair of electrons will belong to both the atoms involved in the bonding. So overall, how many covalent bonds are here? I can represent this in the compact form as like this. So you can also count the number of covalent bonds here. 1, 2, 3, 4, 5, 6, 7. There are 7 covalent bonds here. In this way, we will draw the electron dot structure. Let us take one more example here. Propene. It is having the molecular formula C3H6. Here also we are writing the carbon atoms, and around each carbon atom we are going to write the valence electrons. There are 3 carbon atoms here. 1, 2, 3. Okay. And here the name suggests that there is one double bond in the molecule. There is one carbon-carbon double bond in the molecule. Okay. Now let me write the valence electrons. 1, 2, 3, 4. For this carbon atom also 1, 2, 3, 4. Why have I written here both the valence electrons here? I know that there is one double bond between these 2 carbon atoms. At least one carbon-carbon double bond is present in this molecule. So the shared pair of electrons will be 2 pairs here. So because of which I have written 2 electrons in this side only. And for double bonding, this carbon is used here. So it will also have 4 valence electrons. 1, 2, 3, 4. Again, why I have written both the electrons here only? Because I know there is a double bond between these 2 carbon atoms. And double bond is formed only when there is sharing of 2 pair of electrons. Yes, if there is only sharing of 1 pair of electron, I might have written only 1 valence electron on each side. Here I know that there are double bond. There is double bond between these carbon atoms, because of which I have written both the valence electrons in this side only. Okay. Now write the hydrogen atom. Each hydrogen has one valence electron. How many hydrogen atom will be for this carbon atom? As already one bond is present here. So remaining 3 hydrogen atom will be here. This what it represents. Already there is a bond between this carbon atom. Okay. And for this carbon atom, already there is presence of 3 bonds here. 1, 2, 3. And I need to write only one hydrogen for this in this way. Yes, because already there are 2 bonds here. And here there is one covalent bond between these 2 carbon atoms. So I have written only one hydrogen here. And in this case also you can see there are 2 bonds here. Remaining I need 2 hydrogens. So I will write here 2 hydrogens. Okay, in this way we will represent the electron dot structure. And you can also count the number of valence and you can also count the total electrons around each atom after bonding. Duplet of hydrogen is satisfied in all the cases. What about carbon? Here 1, 2, 3, 4, 5, 6, 7, 8. In case of this carbon atom, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All the valencies are satisfied for all the carbon atoms. Okay. It can also be written in the compact form as, why is this double bond here? Because here there is a sharing of two pair of electrons. Okay. This is how we will write the electron dot structures for covalent compounds. And in the beginning of this chapter only we have seen these carbon compounds will form chains, branches and rings. Let us take the examples. They can form chains. Examples, take butane. Butane suggests that it consists of 4 carbon atoms and it is an alkane. It is an alkane. So, if these carbon atoms are arranged in the form of chain, we will get this. All these carbon atoms are in the form of chain. So, this is called as chain structure. This is called as chain structure. And there is possibility of these carbon atoms to be arranged in the manner. Write the skeletal structure. Yes, we know that it consists of 4 carbon atoms. And these carbon atoms may also be joined in this manner, forming a branch. Now you can satisfy the valency of each carbon atom by writing hydrogen. 1, 2, 3, 4. 1, 2, 3. Already 3 bonds are there. I can write only hydrogen, 1 hydrogen here. Here there is 1 bond, means remaining 3 bonds are to be written. Here there is 1 bond. So 1, 2, 3 more. This is branched structure. And you can observe here the number of atoms of carbon and hydrogens are same in both the cases. It is also having the molecular formula C4H10. Yes, both of them are having the molecular formula C4H10 here. This is also having C4H10 and this is also having C4H10. The only difference is the arrangement of the atoms here. So these type of compounds which have same molecular formula but different structures, they are called as structural isomers. Okay. So these type of compounds with same molecular formula but different structures, they are called as structural isomers. Why they are called structural isomers? Because they differ in their structures but have the same molecular formula. And these hydrocarbons can also exist in the form of ring structures. For example, here the carbon atoms are arranged in the form of ring and this compound is called as cyclohexane. And there may also be carbon-carbon double bond in the cyclic structure. And while satisfying valency, you should be very careful when there is double bond. Here already there are 3 bonds. So we need to write only 1 hydrogen here for this and this carbon atom. See here, this compound is called as cyclopentene. Cyclo because these are arranged in the form of ring. Pent because there is presence of 5 carbon atoms and ene because there is carbon-carbon double bond here. In this way, we will draw the cyclic structures for hydrocarbons. And there is one more popular cyclic hydrocarbon, that is, it is having carbon-carbon single bond arranged in an alternate manner. This has molecular formula C6H6 and this compound is called as benzene. In your higher classes, you are going to study the various reactions of this benzene. Yes, this is all about the cyclic structures of hydrocarbons. Then how can we draw the structure for cyclic hydrocarbons? Let us take example of cyclopentane. It has 5 carbon atoms. So I will write these 5 carbon atoms in the form of ring. Yes. Now we have to satisfy its valency with the available hydrogen atoms. There are 10 hydrogen atoms here. Okay. First let us see this carbon atom. Already 2 bonds are present. I will write here 1, 2. So that it will be having 4 bonds. Then this carbon also having two bonds here. It will be having two hydrogens. And this carbon atom is also having two bonds. So, in this way. So, while having any bond, we have to check whether the valency of each atom is satisfied. Okay, in this way we will draw the structure for cyclic hydrocarbons. Okay, let us solve some examples. Write the molecular formula of the compounds and write their electron dot structures. And this concept is very important. You should be able to write the molecular formula and also the electron dot structures for these compounds. Ethene, and it suggests that it belongs to alkenes. It is an alkene. And the word that eth, it suggests that it is having two carbon atoms. Okay, we know that alkenes having the general formula CnH2n. So eth suggests that it is having two carbon atoms. So substituting 2 here, I will get 2 into 2. That is C2H4. What is the molecular formula of this compound? C2H4. And also we have to draw the electron dot structure for this compound. Okay, there are two carbon atoms. I need to write the valence electrons around each carbon atom, and I have already know that it is ene, means it consists of double bond. So while writing the valence electrons, I will write the two pair of electrons between these two carbon atoms. Okay, first I have written the C here. Now I will write the valence electrons. We know that valence electrons of each carbon atom will be 4. So it will be 1, 2. I am writing here both third and fourth electron here only. Why? Because I know it is having double bond. Double bond means it will share two pair of electrons. Double bond means it will be having two pair of electrons. So instead of writing only one electron between these two, I will write 2. Overall it is 4 only. And for this carbon also, I will write here 2 valence electron on this side only. Then remaining 2 electrons on this side. Now I have to bond these carbon with the hydrogen atoms. And here it is already having 2 bonds here. How many hydrogen atoms I need to make bond with the carbon atom? 2. It will be 2. We know that valence electron of hydrogen is only 1. Here also 1. In this case, it will be having 2 hydrogens only. Why we have written 2 hydrogens here? Already there are 2 bonds here between these carbon atoms, because we know that it is having double bond. Double bond means 2 pair of electrons. Okay. Now you can also count the number of electrons around each atom, whether their valences are satisfied. Hydrogen, it is satisfied, that is duplet. And in case of carbon, we are having 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And remember every time that whenever there is sharing of electrons, these electrons are belonging to both the atoms. Okay, here it has shared two pair of electrons, means these electrons are belonging to this carbon also and for this carbon also. Yes, this is electron dot structure for ethene. Now let us solve this. And by seeing this name only we can understand it is an alkyne. And alkynes have the general formula CnH2n minus 2. And it is eth, means it has two carbon atoms. So substituting 2 here, I get C2H2. So the molecular formula of the compound is C2H2. It is molecular formula. And also we have to draw the electron dot structure for this compound. Here there are two carbon atoms. So I will write two carbon atoms here. And also I know that there is a triple bond between these carbon atoms. Now I need to write the valence electrons here. Okay. I will write one valence electron here and 3 valence electrons here. Why? Because I know there is a sharing of 3 pair of electrons. Okay. For this carbon also I will write 3 valence electron on this side only and remaining 1 electron here. Okay. Or you can also write valence electron here also. Total one carbon should get 4 valence electrons. Okay. Again I am repeating why I have written all these 3 valence electron on this side, because it is sharing 3 electrons with the other carbon atom. How we have find out this? Because it is an alkyne. Alkyne means it should have triple bond. Triple bond means there is sharing of 3 pair of electrons in this way. Yes. Now I need to write the hydrogens here. Hydrogen will be having one valence electron. Each carbon atom needs only one hydrogen because already there is presence of 3 bonds here. 3 bonds means remaining is only one bond here, that too with hydrogen. Okay. This is how ethyne dot structure is. These 3 pair of electron represents there is a triple bond between the carbon atoms. Okay. Now you can count the carbon now if you can count the number of electrons around each carbon atom. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. This is ethyne. In this way we are going to write the electron dot structures for covalent compounds. Hello my dear students. In the previous class, we had discussed about the hydrocarbons, and also we have learned how to draw the electron dot structures for many compounds. And in the today's session, we are going to discuss about many compounds of carbon where carbon is bonded to atoms of different elements. Okay, let's get started. So far, we have learned about the hydrocarbons, that is the compounds containing carbon and hydrogen only. That is alkanes, alkenes, and alkynes. And we also know that this carbon atom can be bonded to different elements, atoms of different elements, like the carbon atom, it can be bonded to atoms of different elements like nitrogen, sulfur, oxygen, chlorine, bromine, etc. Yes, the carbon atom can form covalent bond with the atoms of other elements also. And how these are formed? The hydrogen atom or hydrogen atoms of the hydrocarbons is replaced by these atoms, the atoms of other elements, giving rise to the different compounds. The hydrogen atom or atoms. One or more hydrogen atom can also be replaced by these atoms of other elements. Yes, the hydrogen atom can be replaced by the atoms of other element, resulting in new compounds. And this and these atoms of other elements replacing hydrogen are called heteroatoms. They are called as heteroatoms. And these heteroatoms may be also in group. They may be also present in the group. The heteroatoms can be present in group. And when these heteroatoms or group of these heteroatoms are substituted by hydrogen, means when hydrogen atom is replaced by these heteroatoms or group of heteroatoms, then the properties of that hydrocarbon will get completely changed and it will confer different properties to the compound. So these heteroatoms or group of these heteroatoms, they are called as functional group. Yes, these heteroatoms or the groups containing these heteroatoms confer different properties to the hydrocarbon. Yes, once the hydrogen atom of the hydrocarbon chain is replaced by these heteroatoms, then the property of that hydrocarbons will get changed. So they will confer some special properties to the hydrocarbon chain. So these are called as functional groups, as they confer different properties to the compound. They are called as functional group. Okay. These are called as functional groups. Yes, we are going to understand what are these functional groups. See here, we know that carbon atom can be bonded to atoms of different elements like nitrogen, sulfur, oxygen, chlorine, bromine, etc. And these are formed by replacing the one or more hydrogen atoms by these atoms. And these atoms of other elements replacing hydrogen, they are called as heteroatoms. They may be present in the form of group also. And these heteroatoms, they confer different properties to the hydrocarbon chain. So they are called as functional group. How they look? Let's see here. See here how the different heteroatoms are attached to the carbon chain. When the chlorine, bromine are attached to the carbon chain, then the functional group will be either chloro for chlorine atom, bromo for bromine atom, in this way. You can see the example. If the chlorine atom is attached to this carbon chain, this is a heteroatom here, and the functional group is called as chloro. This functional group is called as chloro. If it is bromine, then it is called as bromo, in this way. And this heteroatom can also be present in the group. For example, oxygen. This oxygen is present in the group here. This group is called as alcoholic group. When this group is attached to the carbon chain, then the compounds will be alcohols. Yes. For example, this is a carbon chain. The alcoholic group is attached to this carbon chain. This group is called as alcoholic group, and it is the functional group here. And if this aldehydic group is attached to this carbon chain, then those compounds will be aldehydes. If this ketonic group is attached to the carbon chain, then it will be ketone compounds. If carboxylic acid is present in the carbon chain, then those compounds will be carboxylic acids. For example, here this functional group is of carboxylic acid. This is a carboxylic acid functional group. And these compounds are called as carboxylic acids. Means these functional groups, they will provide the different special properties to that compounds. So they are called as functional groups. Okay, these are some functional groups here. You have to remember these functional groups. Okay, it is very important to remember all these functional groups. Okay, now we have understood how these functional groups are attached to the hydrocarbon chain. Now we are going to study about the homologous series, which is closely related to these functional groups. Yes, the series of compounds which have the same general formula and same functional group, they are called as homologous series. Yes, the series of compounds with same functional group and same general formula is called homologous series. And we have learned that whenever a functional group is attached to the chain, it will depict the special properties to the hydrocarbon. Then it is regardless of the chain length. The chain length may be of any number of carbon atoms. It may be of 2, 3, 4, 5, 6. Regardless of the chain length, the functional group will confer the special properties to that hydrocarbon. Yes. Now let us see the homologous series of alkanes. The members of alkanes are CH4, C2H6, C3H8, C4H10 in this way. Okay, these are some of the members of alkanes. And you can see here between the two members, that is successive members of the homologous series, you can easily observe here there is a difference in the molecular formula by CH2 unit. You can also see these two successive members. Here also there is difference in the molecular formula by CH2 unit. This shows that in case of homologous series, the successive members of a particular series, they will be differing by a CH2 unit. You can take example for another homologous series. Let's take for example alcohols. They have general formula. Yes, they have the same functional group, that is OH. Let us write some of the members for alcohol. CH3OH, C2H5OH. C2H5OH is nothing but CH3CH2OH. This only I have written in the compact form. And also C3H7OH, C4, C4, H9, OH. Here also you can take any two successive members here. They differ in their formula by a CH2 unit. Yes, this is about the homologous series. You can take any homologous series and write their members. If you take alkenes here, if you take alkenes, the members are C2, H4, C3, H6, C4, H8, C5, H10 in this way. Yes, they have the same functional group and the successive members, they differ in their molecular formula by CH2 unit. This is all about the homologous series. Now let's see what are the characteristics of this homologous series. All the members of the homologous series, they have same functional group. Yes, we know that if I take the series of alcohols, all the alcohols have the same functional group, that is OH. And irrespective of the chain length, they have the similar chemical properties. You can take methanol, you can take C2H5OH ethanol or propanol. These are belonging to the same homologous series of alcohols. All these compounds have the same functional group and they show the similar properties because of the functional group, which is same. Okay, and they have same general formula. Members of homologous series have similar chemical properties. Yes, all the members of the homologous series, they have same chemical properties, and these chemical properties are mainly due to the presence of this functional group. In case of alcohol, they have functional group, that is OH, and the properties of those compounds are due to this functional group. And the successive compounds of the series differ by CH2 group, as we have seen already. They differ by a CH2 group. Yes. And in any homologous series, a gradation in the physical properties is seen. They show a regular gradation, means gradual increase or decrease in their physical properties. Gradation means it is gradual. The change in the physical properties is gradual, and those physical properties are somewhat comparable also. Yes, this is about the characteristics of homologous series. Now let us see some set of rules for writing the names of carbon compounds here. The first step is identify the number of carbon atoms in the compound. This is the most important step to be followed while naming the carbon compounds. As we have discussed in the previous class only, that the number of carbon atoms is indicated by the root words meth, eth, prop, but in this way. Yes, if there is one carbon atom, yes, if there is one carbon atom, the keyword will be meth. If there are two carbon atoms, the keyword will be eth. If there are three, we use prop, 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. These are the keywords that we use for writing the number of carbon atoms. If there are 2, we use eth. If there are 3, we use prop. If there are 4, we use but in this way. Yes, you have to remember all these keywords while naming the carbon compounds. Yes, this is the first step. In the next step, the functional group is indicated in the name by adding suffix or prefix. First, we have to identify whether there is any functional group here. Then we will name that functional group by adding suffix or prefix. See here, if chlorine bromine atom is attached to the carbon chain, then we will use the prefix chloro, bromo, etc. Means if it is fluorine, we will use fluoro. If it is iodine, we will use iodo in this way. Yes, always prefix will be used for halogens. Remember, for example, if this is a compound. If this is a compound having the bromine as functional group here, we will indicate the name of this compound by writing the prefix here. Yes, bromoethane. Why we have given here Bromoethane, because bromo is the functional group, that is prefix, and ethane means it consists of two carbon atoms and there are no double bond here. So the name of the compound is bromoethane in this way. And if the name of the carbon chain is to be given as suffix, the name of the carbon chain is modified by deleting the final E and adding the functional group. See here, these are the suffix which are used when the functional groups are alcohol, aldehyde, ketone, carboxylic acid in this way. And while naming the normal hydrocarbon chain, if it is propane, yes, we want to name the compound that is alcohol. If this is alcohol, yes, this is alcohol. We have to name this compound. Count the number of carbon atoms here, 3. So the keyword will be pro. And it is not propane because functional group is present here. So the suffix is to be added because the suffix for alcohols is all. So the suffix will be propanol. Means all will be the suffix here. Normal, the hydrocarbon will be propane. We are removing this E. We are removing this E and replacing this E by all, that is suffix. It is due to the presence of the functional group, that is alcoholic functional group. Okay. And if the name of the if the carbon chain is unsaturated, then the final ane in the carbon chain is replaced by ene in case of double bond and ine in case of triple bond. Yes, if the carbon chain contains any double or triple bond, we will indicate that by using the suffix ene, ene and ine. Ene and ine are used if double or triple bond is present respectively. Yes, you can see here for double bond we will use the suffix ene. For triple bond we will use the suffix ine. Once we solve some of the example, we will clearly come to know how these compounds are named. Okay, let us solve some of the compounds here. Example, you can write propanol or ethanol. This is ethanol. It consists of two carbon atoms. So the keyword will be eth. Why ethanol? Because the functional group is alcoholic. So the suffix all is to be used. How do we use this all? By removing the last E of the normal hydrocarbon compound and replacing it with all. So the compound will be ethanol. What will be the compound? It will be ethanol. What in case of aldehyde? In aldehyde, we know that the functional group will be CHO. Yes, CH3, CH2, C. This is the aldehydic functional group. And while naming, you have to count this carbon atom also because this is present along with the chain. So we will also take into account this carbon atom. So what are the number of carbon atoms here? 3. So the root word will be prop. Prop will be the root word. And what is the functional group? Aldehyde group is the functional group here. So propanol. Why do we use al here? Because the suffix for aldehyde is al. So it is propanol. If you use all, then it is alcoholic group. If you use al, then it is aldehyde group. Okay. What in case of ketone? Suppose this is a example. How do we name this compound? There are 3 carbon atoms. So the root word is prop. Then the functional group present is on. So I have to write on here. Propanone. It is propanone because the suffix when ketonic group is present, it is on. In case of carboxylic acid, how do we name this compound? First count the number of carbon atoms here. 1, 2, 3, 4. There are 4 carbon atoms here. So what will be the keyword? But. Yes, but will be the keyword. And is it a simply hydrocarbon? No. This is having the functional group that is carboxylic acid. This carboxylic acid is also written as COOH or in the simplest form COOH in this way. Yes. So the suffix that is used will be oic acid. because of which it will be butanoic acid. If it was a simply hydrocarbon, we had used butane, but it is not the simple hydrocarbon. There is a presence of group, that is functional group here. So we are using the suffix oic acid here. Yes, this is butanoic acid. If there is double bond in the carbon chain, see here there is a presence of double bond here. Then what is the suffix that we use when double bond is there? It is -ene. So count the number of carbon atoms here. 1, 2, 3, 4. Yes, it is but. What will be the name of this compound? Butene. Because the suffix -ene will be used if there is double bond. Then when there is triple bond in the compound. Suppose this is a compound. We have triple bond here. So the number of carbon atoms are 2. So eth. So eth is used as the number of carbon atoms are 2. Then the suffix that we will use will be "ine." So it will be ethyne because it is triple bond. So we are using the suffix ethyne here. In this way, we are going to name the carbon compounds having functional group. And it is very important that you have to remember all these functional group along with their prefix and suffix, which must be used in case of naming. Yes, let us solve some of the questions here. Write the structures for the following compounds. First one is bromohexane. Let us write the structures for these compounds. Bromohexane. Hex means it is having 6 carbon atoms. Yes, hex means it is having 6 carbon atoms. 1, 2, 3, 4, 5, 6. And also the functional group is bromine here. So it is indicated by Br. Yes, we have to write here Br. Then satisfy the remaining valencies of carbons by writing the hydrogen atoms here. Each carbon should get 4 bonds. This is the structure of bromohexane. Hex indicates that it consists of 6 carbon atoms. So I have written 6 carbon atoms in a chain, and I have written bromo, that is Br for bromo functional group. It will be bromohexane. Okay, this is answer for A. For B, propanoic acid. Here prop is given, which means it consists of 3 carbon atoms. 1, 2, 3. Yes, including the functional group, it has 3 carbon atoms. And oic acid means it indicates the functional group is carboxylic acid. What is the carboxylic acid functional group? COOH. Yes, I will write here COOH. Including this carbon atom, we have propanoic acid. Okay, we should not leave this carbon atom. Overall, totally we are having 3 carbon atoms in propanoic acid. Okay, do not exclude this carbon atom. And write again COOH. Do not write that. Okay. Now satisfy the valency of carbon with the hydrogen atoms. This is propanoic acid. You have to remember the functional group formula. You have to remember the root word. Then you have to name the compound. Then you have to write the structure for the compound. Yes. Propanone. Yes, this is a third compound whose structure is to be written. See. Prop. Again, it consists of 3 carbon atoms. And one means it is ketonic group. What is the ketone group? CO. This is a ketone group. And these two ends are attached to the 2 other carbon atoms. Okay. So I will write here CO. This is a ketonic group. Okay. Then I will write the remaining valencies with hydrogen atom. Then I will satisfy the valency of carbon with hydrogen atoms here. This is propanone. Okay. Let's see the next compound. Pentanol. D. Pent means it consists of 5 carbon atoms. C, 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 C. And the functional group is al, means it is aldehyde. What is the formula for aldehyde group? We know COH. CHO. It is aldehyde group. Yes, COH. And satisfy the valency of carbon by writing the hydrogen atoms here. This is a structure for pentanol. So overall what we have done, first we have to count the carbon atoms by seeing here the keyword hex means 6 carbon atoms, hept means 7 carbon atoms, pent means 5 carbon atoms. Then we are going to observe what is the functional group and we are going to write the functional group in the structure. Next, draw the structural isomers for pentane. What is the structure of pentane here? CH3, CH2, 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 CH3. Means it consists of 5 carbon atoms. What are structural isomers? These are the compounds with same molecular formula but different in the structures. They have different structures but same molecular formula. For writing the isomers, what we can do is we can arrange all the carbon atoms in a single chain, and one more compound I can write here by writing 4 carbon atoms in a chain and writing the 5th carbon as a branch. Then satisfy the remaining valency of carbon. This carbon atom also be bonded with hydrogen for satisfying valency. This is isomer of this pentane. This is one structure possible. This is another structure. You can also write it in the condensed form like CH3, CH2, CH. This group can be written as CH3, CH3. This is one isomer possible, and also you can write the compound as by writing the carbon atoms in a chain, that is 3 carbon atoms in a chain and 2 carbon atoms like this. This is also a pentane only because it is having the same molecular formula as that of this one, and satisfy the remaining valency of carbon. Already this carbon, the valency is satisfied, so no need to write the hydrogen here. Now I need to write hydrogen for this carbon atom. I can write it as CH3C. This group can be written as CH3 and this group can be written as CH3 and this also we can be written as CH3. This is also a pentane. These are the structural isomers for pentane. Yes, to summarize, how can we write the structural isomers? First, writing the all the carbon atom in a single chain. All the 5 carbon atoms in a single chain, and we should check the possibility of writing this carbon atom out of the chain also. Yes, we can write one carbon atom out of the chain like this. In the third step, I can write 2 carbon atoms out of the chain. When satisfying the remaining valencies of carbon, we will get the different isomers here. Okay. And you can check all of them are having this one, this one, this one. All of them are having the same molecular formula. Only their structures are different. Okay. So I can write it as these are the 3 structural isomers for pentane. Okay. Now name the following compounds. We have to name them. See here there are 3 carbon atoms, so the keyword will be pro and the functional group is ketonic group. So we will add the suffix on. So the name of the compound will be propanone. As this is a ketonic group, I should add suffix on here. So the name of the compound will be propanone. And in this case, there are 3 carbon atoms again. Again the root word will be pro. And what is the functional group? It is aldehyde group. So how will we write the aldehyde group? As a suffix al. We will use al. So the name of the compound will be propanol. Okay. Then see this example. There are 1, 2, 3, 4, 5, 6 carbon atoms here. And which is the functional group here? All the carbon atoms are in single bond, but here there is a double bond between the 2 carbon atoms. So the suffix I should use will be in. The number of carbon atoms are 6. So hexene. This is the name of the compound. As there are 6 carbon atoms, I have written hex in because there is a double bond between the 2 carbon atoms. Next, this CH3, CH2, CH2, COOH. This is again carboxylic acid. It containing 4 carbon atoms. So, but. And for carboxylic acid, we will use oic acid. So, the name of the compound will be butanoic acid. This is how we will write the name of the compounds. And also, we have learned how to draw the structures for these compounds. Hello my dear students, in the today's session we are going to discuss about the chemical properties of carbon compounds. Yes, let's get started. Now we are going to study how these carbon compounds react with other substances. The first reaction that we are going to study is combustion. You have heard this name in your junior classes. Yes, carbon burns in the presence of oxygen to form carbon dioxide along with the release of heat and light. So what do we mean by combustion? What do we mean by combustion? Combustion means it is burning. When a substance burns in the presence of oxygen, we call that process is called as combustion. Yes, combustion means burning, burning of substance in presence of oxygen. Carbon and its compounds burn in the presence of oxygen to release large amount of heat and light. When carbon is burnt in the presence of oxygen, it forms carbon dioxide, and along with the formation of carbon dioxide, it releases large amount of heat and light. This is oxidation reaction here. Yes, and the compounds of carbon, that is hydrocarbons, they also undergo combustion to release carbon dioxide. Along with carbon dioxide, they release water as hydrogen is present here. It is also oxidized to water. Along with it, there is a release of heat and light. All carbon compounds, that is hydrocarbons, they will burn in the presence of oxygen to form carbon dioxide, water, and also they release heat and light. This is ethanol. It will burn in the presence of oxygen to form carbon dioxide, water, along with heat and light. You can balance these equations. Yes, there are 6 hydrogens here. So I should get 6 hydrogens here also. Here there are 2 to the 4, 4 plus 3, 7 oxygen atoms here. So here also I should get 7 oxygen atoms. So this equation is balanced. In this way, the compounds of carbon, that is hydrocarbons, they will undergo combustion reaction to form carbon dioxide, water with the release of large amount of heat and light. Yes, combustion is, in simple words, it is burning of a substance in presence of oxygen. Yes, and you can see here what type of reactions all these, they are exothermic reactions, as there is release of energy in the form of heat and light. It is exothermic reaction. And when these hydrocarbons burn, they will burn with the flame. Yes, what type of flame it will be? It depends on the type of hydrocarbon. Yes, in case of saturated hydrocarbons, we will see a clean blue colored flame. Whereas in case of unsaturated hydrocarbons, we will see a yellow smoky flame. Yes, basically we know that there are two types of hydrocarbons, saturated hydrocarbons and unsaturated hydrocarbons. These saturated hydrocarbons will give a clean blue colored flame. They burn with clean blue flame. Whereas unsaturated compounds, they will burn with yellow flame, that is smoky. Why does this happen? These saturated hydrocarbons, they will give clean flame because it is due to the complete combustion of the hydrocarbon. When there is no complete combustion, that is when there is incomplete combustion, it will result in the formation of soot. What is that soot? It is a black colored substance that you can see when there is flame. For example, naphthalene balls. When the naphthalene small cubes or balls, they are burnt, you can easily see there is a soot that can be absorbed. Why does this happen? It is due to the incomplete combustion of the matter there. In case of saturated hydrocarbons, that is in your kitchen you might have seen, we will use LPG gas stoves. When LPG is burnt, it will give clean flame. It is giving clean flame, blue colored flame. You can easily observe there is no soot there because it consists of saturated hydrocarbons, and also there is a complete combustion taking place. And sometimes you might also have observed that there is a black color material that is formed behind at the bottom of the vessels when they are kept on the burner of these LPG stoves. Why does this happen? Even though they are giving clean flame, why is that soot formed there? It is due to the blockage of the air holes on the burner. You might have seen on the burner of LPG stoves there are many number of holes that are made. Why these holes are made? In order to supply air to the mixture of LPG so that it can burn easily in the presence of oxygen to give energy, to give heat energy there. Yes. And when these holes are blocked, somewhat they are blocked, this results in insufficient supply of oxygen. Again, insufficient supply of oxygen result in the sooty flame due to the incomplete combustion. Yes, generally saturated hydrocarbons give clean flame. But in case if there is insufficient supply of oxygen, they will form sooty flame. Yes. And in case of unsaturated hydrocarbons, they will burn with yellow flame that is smoky. This is due to the incomplete combustion. Why does this happens? Because in case of saturated hydrocarbons, percentage of carbon is less when compared to the unsaturated hydrocarbons. Here, the percentage of carbon is more. When the percentage of carbon is more means it needs more amount of oxygen for burning, and the atmospheric oxygen is not enough to cause the complete combustion. Here it consists of less percentage of carbon which is sufficient for complete combustion resulting in the clean flame. Whereas here the oxygen that is present in air, it is not that enough in order to cause the complete combustion, because of which they will give sooty flame. And in case of saturated hydrocarbons, when there is limited supply of oxygen, they will also give some smoky flame. Yes. And when we talk about flame, do all the substance burn by giving out flame? Have you seen each and every substance that gives out flame on burning? The answer is no. Because there are some substance like you might have seen coal or wood. They will not completely burn by giving flame. Initially, they may give flame, but after you might have seen that it will glow red when it is burning. Why does this happen? Flame is produced only when the substance is in the gaseous state. Yes, flame is produced when the gaseous substance is formed. In case of candle, you might have seen first the wax get melted and its vapor will catch fire in order to give out the flame. Whereas in case of coal or wood, what happens? There is no gaseous substance that is formed there. Initially, it will burn with flame because of the volatile substances that are present. Once those volatile substances or gases are burnt away, then it will only glow red as there is no formation of gas there. And it is to be noted that in some fuels like coal and petroleum, they contain sulfur and nitrogen elements. Once they are burnt, they will give oxides of sulfur and nitrogen. And these are the pollutants in the atmosphere. Why do we say that? When petrol and diesel they are burnt, it will produce the polluting gases because of the presence of sulfur and nitrogen in those fuels. So far we have learnt that the combustion results from burning of a substance in presence of oxygen. All the compounds of carbon will burn in the presence of oxygen to give carbon dioxide, water along with heat and light. And the saturated hydrocarbons will burn with clean flame due to the complete combustion, and the unsaturated hydrocarbon will burn with yellow color flame that is smoky. It is due to the incomplete combustion. And in some materials, the flame is not produced. Flame is produced only when gaseous substance is burnt. This is all about the combustion reaction. Now, the next type of reaction that carbon compounds undergo is oxidation reaction. What is oxidation? It is addition of oxygen to the compound. We have learned it in the previous sections. Addition of oxygen to a compound is called oxidation. Let's see the example here. When this alcohol is oxidized, we get carboxylic acid. And for this oxidation, we need reagent, that is oxidizing agents. What are these? These are the oxidizing agent. In order to carry out the oxidation process, that is oxidizing this compound, we need the reagent. What are those reagents? They are oxidizing agent which are capable of adding oxygen. You can see here, initially it was having one oxygen. In the product, it is having two oxygen atoms. So there is addition of oxygen here, because of which we will call it an oxidation reaction. And this substance is oxidized from ethanol. This is ethanol and this is ethanoic acid. And those substances which oxidize another substance, they are called as oxidizing agent. You might wonder, in the previous case also, there was oxidation taking place where oxygen was adding to carbon, resulting in carbon dioxide. The difference is that in case of combustion reaction, they will burn completely. The reaction is vigorous, resulting in the carbon dioxide, water, heat and light. Here, we are adding oxygen in a controlled way. We are not burning the compound here. In the previous case, we were burning the compound. That is combustion. Here we are adding oxygen to this compound in a controlled way to form oxidation reaction. In this case, we will require the suitable oxidizing agents. These two are oxidizing agents, that is potassium dichromate. This is potassium dichromate and this is potassium permanganate. You should remember the oxidizing agents. What has happened here? In case of oxidation, the carbon compounds will undergo oxidation in the presence of oxidizing agents to form the respective oxidized products. Yes, in case of ethanol, it is oxidized to ethanoic acid. This is ethanoic acid. This is about oxidation reaction. And remember here, these both are not used at a time. Any of the oxidizing agent can be used, either acidified potassium dichromate or alkaline K-menophore. Any of these oxidizing agents can be used. In this type of reaction, the unsaturated hydrocarbons react with some substance to form a single product. The name itself indicates it is addition. There is addition of some molecules or atoms here. Let's see the example. Suppose this is alkene. In alkene, we know that there is the presence of double bond. And this R represents their alkyl groups. They may be CH3, they may be C2H5, C3H7, in this way. They are alkyl groups. Now we are focusing on the double bond here because we are adding the molecule to this double bond. What happens when hydrogen is added to this double bond? We get hydrogenated product. This hydrogen will attack this bond, the double bond is broken and hydrogen atom is added to both the carbon atoms here. So this bond is broken and the bond is formed between the carbon and hydrogen here. And for this reaction, we require the catalyst. Nickel or palladium may be used as catalyst. What is catalyst? Catalyst is a substance which is added in order to increase or decrease the rate of reaction. Suppose I want to speed the reaction, I will add catalyst here. And catalyst is not always added for increasing the rate. It may also be added for decreasing the rate of reaction. And at the end, this is not involved in the product. This comes as it is, as it was before. So it is called as catalyst. What it does is it will alter the rate of reaction. It will sometimes speed up the reaction and wherever necessary it can also be used to slow down the reaction process. So here in case of the addition reaction here, this hydrogen molecule is added to the double bond here. Each hydrogen atom is added to carbon and this carbon also. and this bond is broken. And we know that carbon can form only 4 bonds. So this bond is broken and hydrogen is added to here. And for adding this hydrogen, we need the catalyst like nickel or palladium. And here it has undergone the reduction reaction. Addition of hydrogen is nothing but reduction. And this reaction is also called as hydrogenation. As we are adding hydrogen to this molecule, we call this reaction as hydrogenation reaction. Is there any practical application of this reaction? Yes. In conversion of vegetable oils into vegetable fats, we are carrying out this reaction. In the conversion of vegetable oils to vegetable fat, we are carrying out hydrogenation. What vegetable oils contains? They contain unsaturated carbon chain. Unsaturated carbon chain. Whereas once the hydrogen is added to these unsaturated carbon chain, we will get the saturated carbon chain. That is vegetable fats. They contain saturated. This reaction of converting vegetable oils into vegetable fats require hydrogenation. Means we are adding hydrogen to this unsaturated carbon chain. Because vegetable oils contain double bond, that is unsaturated carbon chain, double or triple bond. Yes. And we say that example for the vegetable fat may be dalda. Have you seen dalda? It is prepared from vegetable oils. Vegetable oils can be sunflower oil, it may be flaxseed oil, anything. When these are hydrogenated, we will get the vegetable fats, and we say that these vegetable fats are harmful for health. These vegetable oils are suitable for cooking purpose. And also animal fats also contain the saturated carbon chain. They are not that much good for health. So vegetable oils are preferred for cooking, and dalda is not at all preferred for cooking purposes because it is harmful for health. The next type of reaction is substitution reaction. Here the name itself indicates substitution, which means we are substituting some atoms by some other atoms. In case of hydrocarbons, the hydrogens that are attached to the carbon, they can be replaced by some other atoms. In saturated hydrocarbons, one or more hydrogen atoms attached to carbon can be replaced by some other atoms or group of atoms. Such type of reactions are called as substitution reaction. Whenever the hydrogen atoms that are attached to carbon atom can be replaced by some other atoms, then we call such reactions as substitution reaction. Yes, let us take an example here. Usually what happens, the hydrocarbons, that is saturated hydrocarbons, they are not that much reactive. But when these hydrocarbons, they are made to react with chlorine in the presence of sunlight, they undergo substitution reaction easily. For example, this is methane. When it is made to react with chlorine in the presence of sunlight, it undergoes substitution reaction, means one hydrogen atom of this methane molecule is replaced by the chlorine atom. So we get CH3Cl plus HCl. And again, if you carry out the reaction further, if you leave the reaction in the sunlight only, if you leave the reaction mixture in the sunlight only, all these hydrogen atoms are replaced by the chlorine atoms. The reaction may also be proceeded as when CH3Cl, again it is made to react with chlorine, it undergo further substitution to form dichloromethane. Again, these two hydrogen atoms can also be replaced in the presence of sunlight to form trichloromethane. And at last, all the hydrocarbons are replaced by the chlorine atoms to form tetrachloromethane. This is also called as chloroform. CHCl3 is also called as chloroform. Okay. In this way, the substitution reaction takes place in methane. Means the hydrogen atom attached to the carbon is replaced by the chlorine atom. Okay, this is the substitution reaction. Now, we are going to discuss about some important compounds of carbon. The first important carbon compound that we are going to discuss is ethanol. It has the formula CH3 CH2 OH. It is alcoholic group. So it belongs to alcohols. As the name indicates, eth means it consists of two carbon atoms here. Okay, let's study about this compound. How it is, how does ethanol looks? It is a colorless liquid. And in general terms, it is also called as alcohol. Simply, this is called as alcohol because it is the main ingredient that is used in alcoholic drinks. Whatever the alcoholic drinks that are available in market, they are made from this ethanol only. The diluted form of ethanol is present in those alcoholic drinks. And this ethanol is not consumed directly. The pure ethanol is very dangerous to drink. Sometimes it will cause death of a person even if small amount of this ethanol is consumed in pure form. So whatever the ethanol that is available in the market, it is diluted one. Okay, those alcoholic drinks contains diluted ethanol. And coming to its properties, it has low melting and boiling point, and it is soluble in water. It is very easily soluble in water. And we know that direct consumption of absolute alcohol means pure ethanol. It is lethal, means it can cause death of a person. Then consumption of dilute alcohol can cause drunkenness. Nowadays we see the people who are addicted to this alcohol. Even they drink dilute alcohol, it will cause very serious health problems. It can cause habit. This alcohol is habit forming. So it is never recommended to consume the alcohol as it has many bad effect on our health. And dilute alcohol consumption has many harmful effects on health. Means long-term consumption of this alcohol, that is diluted alcohol, has serious health effects. So it is never recommended to consume the alcohol. And coming to its commercial importance, it is a very good industrial solvent. Industrially, it is used as a solvent, and in also the laboratories, it is a very good reagent as it can dissolve many compounds in it. Now let's see the uses of this ethanol. As discussed, it is an important industrial solvent. So it can dissolve many compounds in it. It is used in alcoholic drinks. The diluted ethanol is present in alcoholic drinks. It is used as laboratory reagent. For making many reactions, we are using this ethanol. And it is also used in medicine like tincture of iodine, cough syrups and many tonics. You might have seen cough syrup contain small amount of ethanol in it, because of which we will feel drowsiness when we take cough syrups. Yes, it is used in such medicines. And also commercially it is used in the manufacture of paints, rubber, perfumes, sanitizers, dyes and many more products. This ethanol is used. So it is a very important compound. Then what are the harmful effects of this alcohol consumption? What happens when a person is addicted to alcohol? When large quantities of alcohol are consumed, it slows down metabolic process and depresses central nervous system. When alcohol is consumed in large amount, it directly affects our central nervous system. It is a depressant, because of which there is a lack of coordination and there is mental confusion, and also the person will suffer from drowsiness. Whenever this is consumed in larger amount, it will cause the lack of coordination, and also at that time the person will lose a sense of judgment. These are all the ill effects of consuming alcohol, and the person will not come to know what to talk, how to walk, how to behave, because his central nervous system is depressed once it is consumed in larger amounts. Yes, and also muscular coordination is seriously impaired. And even small amount of alcohol can show fatty changes in liver. Long term effect is hepatitis and irreversible damage to liver. If this alcohol is consumed for a long duration of time, it will directly damage to the liver. We know that liver is a very important organ. It is a detoxicating organ, as we all know. Once this liver is toxin, means this liver has damaged, even small amount of alcohol can show fatty changes in liver. Long-term effect is hepatitis and irreversible damage to liver. When this alcohol is consumed for a long duration of time, it will directly affect the liver. We know that liver is very important organ and it helps in detoxification. Once this liver is damaged, it will affect other organs also. And in order to avoid the misuse of this alcohol in the industrial level, what they do is they will denature the alcohol. The alcohol is denatured. Denatured means they are going to add some poisonous substance to this alcohol so that people will not consume it in the industries. The substance that is added is methanol. Methanol is also an alcohol. Even when it is consumed in very small amount, it can cause death. Can cause death. What happens is is when this methanol reaches liver, there it is converted into methanol. Methanol is aldehyde. Yes. Methanol, when it reaches liver, it is converted into methanol, and this methanol will coagulate the protoplasm in our body. It will coagulate. When this protoplasm is coagulated, the person will die. Yes, you can imagine when egg is boiled, what happens? The inner part will get solidified. Yes, it is coagulated. In the same way, the protoplasm present in our body will also get coagulated when methanol is formed in the liver. So it will cause death of a person. So alcohol is made denatured by adding small amount of methanol to it. Yes, by adding methanol, not methanol, methanol. By adding methanol to it, it is denatured. So overall, we have learned the harmful effects of this alcohol consumption. So it is never recommended to have the alcohol. Now let's discuss about its chemical properties. First is reaction with sodium. That is how ethanol reacts with sodium. When ethanol is made to react with sodium, it forms sodium ethoxide and hydrogen gas is liberated. What it is? It is sodium ethoxide. And this H is given out as hydrogen and the Na will form bond here. What happens here? Ethanol reacts with the metal sodium to form sodium ethoxide with the liberation of hydrogen. You can balance the equation. So ethanol reacts with sodium to form sodium ethoxide. And there is a brisk effervescence of hydrogen gas that is formed. Okay. And the next reaction is with concentrated sulfuric acid. When ethanol is heated in the presence of concentrated sulfuric acid at 443 Kelvin, then dehydration takes place. Here what happens? There is a removal of water molecule here, resulting in the formation of ethene. Here we are converting alcohol to alkenes. This is one of the methods that we use for production of alkenes. Yes. What happens here? This OH group and this H atom will be removed as a water molecule, resulting in the double bond between these two carbon atoms. We know that carbon should have valency 4, means it should have bonds that is 4. So the double bond will form between these two carbon atoms, and with the removal of the water molecule, this OH and this H, they are removed as water molecule. Okay, this is how alcohols are converted into alkenes. It is alcohol and it is alkene. So ethanol is converted into ethene. ethanol is converted into ethene. And this reaction is also called as dehydration reaction. Why? There is a removal of water molecule here. So this is also called as dehydration. And this concentrated H2SO4 acts as dehydrating agent because it removes the water molecule. Now the next compound that we are going to study is ethanoic acid. What is the formula for this? CH3COOH. It belongs to the group of carboxylic acids. And we know that carboxylic acid group is this. This is a carboxylic acid group. As it contains two carbon atoms, it is called as ethanoic